Hello everyone. In this session, we are going to learn about industrial automation. So what is industrial automation? So let's split the word like industrial and automation. Let's see about automation first. So the word automation means we can tell it may be the self-dictating machine, right? So you can find and it is the mechanism move by itself, right? And it is derived from the Greek word, and auto means self and matos means moving. So combinedly they are calling this as automation, right? So any process which is handled automatically with less amount of human intervention. We cannot tell that human effort is not at all there in automation. It will be there, but it will be in the very less amount, right? And what are the types of automation we can see? Even in our home also we can see the automation, right? Take an example of washing machine, microwave oven, security alarm, like that. In our home itself we are finding so much of automation, right? So automation is having general classification. Fine. So you can find scientific automation, home automation, public transport automation, laboratory automation, robotic automation, like that. We have so many types. In that, industrial automation is one of the type, right? So the automation introduced in the industries are called as industrial automation. So we can tell what kind of industry it may be, right? It may be a manufacturing industry, automobile industry, assembling industry, cement industry, and packaging industry. Like that we have various type of industries. So for there we need to have a automation to increase what? That is the next question. So why we are introducing automation in the industry? So let's see that. So yes, so why automation? You can find the picture over here. So man who is handling a hand valve and by checking the temperature gauge. Fine. And what is his work is he need to control the hand valve. Maybe that is the fuel over there, which is he's controlling the fuel quantity inside that plant, right? And he is checking the temperature. According to the temperature, he is changing the hand valve. So imagine this case. So he is the responsible for this operation, right? And the first point is obviously human error will be coming. He cannot be more accurate, right? The precision will be missing. And moreover, he is not in a safe place, right? So always a man nearer to the boiler is not safe for his health also, right? So we are facing such difficulties in the manual control. Yes, can you find a picture over here in the right side? And here a man is converted into the controller now, right? And hand valve is converted into the control valve, and gauge is converted into the transmitter. So here, according to the temperature of the plant, a transmitter is sending signal to the controller, right? So for the controller we have already set point we have given. So SP means it is a set point and PV is the process variable. So temperature is a process variable over here. So it is sending signal to the controller, and for the controller we have already given the set point. So the controller is taking a decision. According to that, it is giving the control output CO to the control valve. So automatically control valve will be opening and closing or adjusting its position according to the decision of the controller. So imagine we are making a controller by replacing a man. So in this case we are in safe place. There is no man over there. So there is no danger for him, right? And moreover, accuracy, precision, everything is very good comparing to the manual control. And obviously it will lead us to, our productivity will increase. So there are so many reasons like this if we are introducing in the automation in the industry. So that is the main reason we are using automation in the industry. So let's see, and the point whatever we have discussed. So increase the productivity, to improve the product quality, to reduce the labor or production cost, to improve safety, and to assist remote monitoring, right? So obviously, yes, to assist remote monitoring. So as I have discussed about the plant, we have seen a chemical industry, manufacturing plant and all, right? So there, the plant will be very huge. It will be occupying big area. So how can I able to monitor everything in the field? You may have more field instruments. How we are going to monitor? By using a remote monitoring technique, right? So this is the introduction to automation. So I'll meet you in the next session with another interesting topic. Thank you. Hello everyone. So in this session we are going to see about evolution of automation. So we have seen what is automation, why automation and all, right? So to how to make the system automation, how to do the automation. For that, to know that, we need to know how it is get that growth. Okay, how it got evolved, right? Evolution is very, very important, right? So it is not that one day process, correct? So we are into a manual control once upon a time. So from that, how we are into the complete automation, like full automation. So how it is possible. So we need to know the history. So obviously the slide is going to explain you about the history of automation, right? So let's go to the slide. Yes, and you can see 4 steps, right? So let's start with the down. So we were into the manual control once upon a time, right? So you can find a man, the same pic we have seen in the previous session. So man who's handling the hand valve. So the problem also we have discussed. What was the problem in the manual control? It is not accurate and it will not help us to increase the productivity, and safety is also not good, right? So we have faced such disadvantages in manual control, and that's what we jumped into the hardware control. So hardware control is nothing but electrical machines, relays kind of, right? So what is the problem over there means, obviously since it is the electrical machines kind, so it is occupying more space. Okay, so if it is occupying the more space, it will lead you to the complexity, and obviously troubleshooting is also very difficult. Power consumption is more, because of that loss is also more, power loss is more, and overall efficiency will get reduced because of that. Safety is also less. Comparing to manual control, it is okay, but it is not up to the mark. Okay, so these are all the difficulties we have faced in the hardware control, right? And there is a one quote, they will tell codes like 5 hours to find out the error and 5 minutes to fix the error in a hardware control. See, it is very difficult to find out the error. That's what I have told. It is very difficult for troubleshooting. Okay, it will have a bunch of wires, so you couldn't able to find which wire is faulty. Even if you find, it will take more time, right? So in the meantime, we need to shut down our plant. So it will reduce our productivity. It is a, we need to shut down our plant. So it is not advisable, right? So these are the difficulties we have faced in the hardware control. So that's what we have jumped into the, or moved into the electronics control. So electronics control is nothing but the gates or electronic devices, maybe a PCB or ICs and all. So the advantages we have faced when comparing to the hardware control are, it is very small and compact, and it's very, very easy to handle. Power consumption is very low, and wire requirement is very less comparing to the hardware control. So these are all the advantages we have faced comparing to manual and hardware control, but here also we faced so much disadvantages. So let's see what is that. The main thing is, obviously, since it is very small and compact, it is also very difficult to troubleshoot. Okay, imagine we have a TV remote in our home, right? So if the TV remote is not working, maybe not because of the battery, okay? So if it is not working, really, we will do the repair we will get that to the repair shop and we will do the repair, and we will go for the new remote. Obviously, the second point, right? We will go for the new remote. Why means, if I go for the troubleshoot, they will cost me more, right? Maybe it is a minor issue, but they will cost me more because it is an electronic circuit. So this is the main disadvantages in the electronics control. And one more thing is there, it cannot withstand heat, right? Because the controller I'm going to implement is in an industry. In the industry, the temperature will be more. It need to run for 24 into 7. Imagine we cannot run a laptop for more than 5 to 7 hours, right? So it will deliberate the heat, even our mobile charge also, right? So because these are all the electronic components, so I cannot use this for 24 into 7. But in industry, I need a controller which can run for 24 into 7, right? So here is a complex. So that's what these are the disadvantages in the electronic control. That's what we have moved into the PLC. So what are all the disadvantages we have faced in the previous control systems we have overcome in the PLC. A PLC is a controller where I can implement in the industry, and I can run it for 24 into 7. Okay, and it can withstand the temperature, it can withstand the industry environment, and it is very easy for troubleshooting because it is having LED indications for all the IOs. So it is easy for us to identify the problem, where the problem is. That one I can easily identify. Okay, so these two are the main advantages in the PLC. And moreover, we can easily we can program it. Okay, the programming will be not that much difficult. It is very easy to program, and we have more expansion ports to increase the number of IOs, right? So yeah, so it is specially designed to work in an industry environment. That is a single statement I can tell for PLC. So that's what, this is the history about how we are in this PLC world. So how many steps we have come across. So yes, so this is the evolution of automation, right? So I hope you have understood. So I'll meet you in the next session with another interesting topic. Thank you. Hello everyone. In this session we'll see about programmable logic controller. So PLC is one of the tool we are using in industrial automation, along with PAC, along with the DCS and SCADA, right? So PLC is the controller. Fine. So let's see about PLC in depth. So it is a logic controller, and it is a unit of hardware used to control and automate an industrial process. So it is a unit of not only a hardware but also a software is also there, right? So PLC are capable of monitoring the input continuously from sensors or any other input devices and producing the output decision to operate the actuator based on the program. Okay, so actuator means it may be any one of the output device. It may be actuator, or it may be a lamp or motor, anything it may be, right? So it is a decision making controller. Fine. So from that we can able to make a logic. Okay, so this is a specialized controller. It is also called as industrial computer. Okay, so since we have mentioned it is a controller, we are having a processor inside it. Fine. So when it comes to the processor, we can compare this with a normal computer. Fine. Because in PLC also we are having a processor, we are having a memories, we are having some IO ports, everything is there. Let's see that. So this is the architecture of PLC. So you can find the CPU over here, and above that we have a power supply, we have input module, we have output module, and programming device. Right. So what is this power supply? Let's start with the power supply. Okay. So what is the use of power supply means? It is used to power CPU and also some input and output modules. Fine. And these modules supply the necessary power required to the whole system by converting the available AC to DC, or maybe it may be the DC also. Okay. So it also not only for the CPU, it will also supply power to input and output modules, right? This is the basic component that we require for the PLC. Okay, when it comes to the architecture, obviously power supply playing the very important role. Next come to CPU. So since I have mentioned, it is also similar to the computer. So computer is having a processor, right? Like that, PLC is also having a processor. Fine. So what it is going to do? That is very important, right? So as we have studied in schools, like CPU is the brain of the computer. Like that, CPU is the brain of the PLC. Okay, it is having a processor used to perform logic and controlling the communication among the modules, right? So the user can enter the desired circuit in the programmable form, which will be downloaded to the PLC, the CPU. And the processor accepts the input data from various input devices, execute the program which is stored in the program memory, and send signal to the output side, maybe the output module. Okay, so it is the CPU's working. And moreover, if you see the CPU, we are having memories over here, right? So we have so many types of memories, like read-only memory, random access memory and all. So read-only memory is only for OS, drivers and application program. If you see RAM, it is for user-written program and working data. For that and all, we will be using the RAM, okay, random access memory. And also we will have retentive memories also to save the user program and data when the power supply get breaks. If the power is fails, it will be used to restore the program. Okay, so for that we will be using some retentive memories also. So CPU is responsible for doing all the necessary data processing and computations by accepting the input and producing the respective output decisions. Fine. So this is the working of or function of CPU in the PLC architecture. Okay, so let's come to this IO module. We are having two IO modules now. One is this side, which is called as input IO module, and another one is this side, which is output IO module. So if you see the input IO module, it will be accepting all the input devices. Okay, so generally IO module is used to give the communication between IO devices and CPU. You cannot connect your IOs directly to CPU. You should have some bridge kind of structure, which will be called as IO modules. Okay, so depends upon the input and output you are connecting. It will be differentiate into input IO modules and output IO modules, and also in that we are having digital IO modules and analog IO modules, right? Because we are having two types of inputs like switches, sensors, these and all will come under the digital IO module. Okay, digital inputs. And if you see transmitters, current transducers, so these and all come under the analog inputs, right? So we will be having a separate module for accepting these two inputs. Okay, so if you are taking a digital IO modules, which is used to connect sensors and actuators. Okay, IO modules I'm talking about. It may be an input or it may be the output. So all the digital IOs are connected with digital IO modules. If you are having analog IOs like transmitters, control valves, VFDs, if you are having like that, you should use analog IO modules. Okay, so this is very important one. IO module is not common for both the signals. It will be different. Okay, and so this is then, and we are having optical isolation over here, right? So it is like for a safety purpose, right? So you electrically isolate the internal components of CPU is secured by the isolation. Okay, this is optical isolation, because we will be connecting our input and output devices directly to IO modules, so it should not affect our CPU. So for that we will be using this isolation barrier. We call it as isolation barrier also, right? So and the last one, we are having a programming device. So the use of programming device is used to write a program. Fine, that may be a computer or a laptop or a small handheld device like that. So in that we will have the software. So we will be writing the program. By using the communication cable, we can able to download and upload the program from or to PLC. Fine. So this may be a PC or computer nowadays. We will need to install the software. right? So apart from this, we have some additional components like operator interface device, which is used to allow the data entry or data monitoring by operators. So it is an optional one. And communication adapter for remote IOs, so that central computer or controller can be connected to remote sensor and actuators, right? So the communication adapter is also one of the additional component. And we have network interface to allow interconnecting of PLCs or any other controller into distributed control system. So these three are the additional components, right? And in that, communication interface modules are very important because it is like an intelligent IO modules that exchange the information between the CPU and the communication network. So these are used for communicating with other PLCs, and that may be a computers also that are placed at the remote or far away distance. Okay, so these are all the basic components, or which are all the components involved in the architecture of PLC, right? So this is introduction to PLC and the architecture of PLC. So we'll meet you in the next session with another interesting topic. Thank you. Hello everyone. In this session, let me see the types of PLC. So we have seen that PLC is one of the tool in industrial automation. So PLC is the controller and it is having various types. Okay, let's see that. So there are three categories, right? One is depends on size, another one is depends on hardware setup, and the third one is depends on power supply. So we can classify the types of PLC depends on all three categories, right? If you are going for the purchase of PLC, you may have a question like depends on size, or it depends upon the hardware setup, or depends on the power supply. So let's see what is this size. So in size also we have various types. So let's see that. Yeah. So if you see the depends on size, we have nano PLC, micro PLC, medium PLC, large and very large, right? So how they are classifying the size means depends upon the number of IOs they are using, right? So if you take a nano PLC, it will have very few number of IOs. If you find micro, it will be more than nano, but comparing to medium scale, it will be very less, right? So very large scale PLC will have more than 10,000 or 20,000 IOs it will be there. Combinedly, I'm telling, both digital, analog, everything. Combinedly, number of IOs will be more in very large. And moreover, memory is also having, so memory is also having some impact in this. So depends upon the memory size of the PLC also, it is getting vary. So this depends on size will get vary with the two parameters. One is number of IOs and memories. So these are all the general categories for nano PLC. Nano PLC, you can keep it in a shared packet. That much small it will be, right? So micro PLC is, comparing to nano, it is a bit big. And in oil and gas industries and all, they will be using a very large scale PLC. Okay. It is not that for large scale industry they should use this when nano cannot be used in large scale, not like that. It is not having such criteria. Depends upon my application, how many IOs. For my college project and all, I can go with the micro PLC, right? A food processing industry can use a medium scale industry. Even the amusement park rides and all, they can use a nano PLC or micro PLC. So it is depends on the project and the requirement, right? So this is the first category. And the second category we are going to see is depends on hardware setup. Right? This is very important because hardware setup is one of the main thing. Like if you see, the first step is compact or integrated type PLC. Right? So what is this compact or integrated type PLC means? It will be like a single box. So we have seen the architecture, right? We are having a power supply module, we will have IO modules and CPU and programming circuit and all we have seen, devices we have seen, right? So CPU IO modules. Both are main thing. So both are combinedly in this box. Right? So if you open this is the Siemens brand. If you open this, you can find the IO ports. Inside itself, CPU is there. So all the components are combinedly in one box. That is compact or integrated type PLC. For example, imagine this PLC is having 12 inputs and maybe 16 outputs. Imagine like that, okay? So if you are in need of extra inputs, apart from 12, more than 12 you are in need, extra 6 or 7 you are in need. So in that case, how can we use this compact or modular type, integer type PLC? Because this is fixed one. This is the number of IOs is fixed by the manufacturer. We cannot do anything. So in that case, some manufacturer can give the option to use the expansion module. So expansion module means when you are running out of IOs, when you are using a compact or integrated type, when you are running out of IOs, you can make use of the expansion modules. So expansion modules are nothing but extra IO modules. So in our case, we are in need of 6 or 7 IOs. That time you can get the extra input module by connecting this CPU and this PLC and this expansion module. You can make the communication and you can get your extra IOs. So this is, some manufacturer will have the facilities to have the expansion modules, right? And the second type of PLC is a modular type. So modular type PLC means CPU, power supply, IO modules, everything will be different. Can you see? All the modules are different modules. It will be like, plug and place. If the CPU is not working, you can remove the CPU and you can replace with a new CPU. But here CPU is faulty means you cannot use this until it get repaired or it get replaced. Right? So that is modular type PLC. In modular type PLC, you will have two types. One is rack and another one is chassis. Rack means it will be like a din rail, a silver kind of rod where you will be keeping your modules. Chassis means it will be like a box where the chassis will have some plug-in components. So you can just place your IO modules or CPU or power supply over there. So this is modular type PLC. So the third classification type is depends on power supply. This is also an important category because whenever we are talking about what is the power supply we need to give to PLC, that is one important thing that we should know, right? So what is a power supply means you can give both. It may be a 230 or it may be a 24 volt. Okay, it depends upon the types of PLC. That is what this classification is, right? So some PLC you can give 230 directly. But for some PLC you cannot give 230 directly. You should give 24. That means what? You are taking from the power supply from the board and you will be convert that, right? After that you will give the 24 volt, right? So suppose if you are giving 230 directly to the PLC, that means the PLC is having SMPS component inside. So PLC can work with 24 volt. Okay. So PLC input is 24 volt only, but in some PLC you can give 230 also because you can able to convert 230 to 24 because it is having SMPS inside it. It's not visible to outside. Okay. You can, if you open PLC, you can watch. So that is with the SMPS PLC. Suppose if you are giving 24 volt to the PLC and that will be the without SMPS. Right. That means what? A PLC is not having SMPS. That's what I am giving 24. Right. So these are all you can get from the user manual of PLC. Right. In there itself, they can mention what kind of power supply we need to give. They will be giving elaborately. So these are all the three general classification when it comes to the types of PLC. So we'll meet you in the next session. Thank you. Hello everyone. In this session, let's see about PLC brand. So like our mobile phones, PLC is also having various brands. So it depends upon the manufacturer, right? So let's see about it. So we have Allen Bradley, Siemens, ABB, Omron, Delta, Honeywell, GE, Modicon and Schneider Electric. So these are all the very popular brands which are widely used in the industries worldwide, right? So how we can classify this means depends upon the company, countries. If you see USA, their products are Rockwell, Allen Bradley, Emerson PLC is there, GE is there and Honeywell. So these are all the US product. Right? So if you find a industry in the USA, most of the people will be using these four products. Majority I'm telling, right? And if you see Europe, if we have ABB and Siemens or the Schneider, and these three are the very popular brand. And Japan, you can see Omron, right? And in China, we have Innovance and Kinko, and Taiwan, we have Delta, right? So these are all the very popular brands that we can differentiate with the countries. So in India, we can popularly use Siemens, Delta, Omron. It's not like we should use this one. It's not exactly like that, because it depends upon their budget, right? So if you see AB, Allen Bradley is very costly, right? So comparing to Delta or Omron, fine. So depends upon our industry requirement and budget also, we can get the manufacturer, right? And moreover, all these brands are also providing a safety PLC. So safety PLC is similar to, it's exactly the PLC only, but that PLC is completely into the safety department, right? So in if you see Allen Bradley, we are having God Logic, right? So that is a safety PLC, and safety PLC you can easily identify with color coding. It will be in the red color or it will be in the yellow color, right? So these are all the very popular brands. And now in this course, we are going to study this Allen Bradley, right? So which is a US brand. So I'll meet you in the next session with another interesting topic. Thank you. Hello everyone. In this session, let's start introduction to Allen Bradley PLC. So we have seen Allen Bradley is a US based company, right? So the company name is Rockwell Automation, and Allen Bradley is the brand name of their factory automation equipments. That means controllers. So along with a control system, they are having few more products. You can see sensing devices, HMI, network technology, industrial control components, industrial control panels, information softwares and motor control devices. So these are all the products of Rockwell Automation. In that, control system is one of the product. Under control system only, our controller part will be coming. That means Allen Bradley will be coming under the control system, right? So if you see Allen Bradley PLC, it is also having various types. So let's see what is that. Yeah, you can see three major classification of Allen Bradley PLC. So the first one is micro and nano control system. The second one is small control system. And the third is large control system. So they are classifying control system into three categories, depends upon the size. Okay. So first is micro and nano. That means these are all very small PLCs. So you can see micro 800, micro logic. So these two are coming under micro and nano control system. Like that, in small control system, you can see compact logic, smart guard, SLC 500. So these are come under small. So large means control logic control system, guard logic and soft logic. So these are come under large control system. For example, you can use this large control system in oil and gas companies, power plant and all, right? And according to the requirement, you can choose which control system you are in need. Okay, fine. So now they are having general 3 classification. In that classification also we are having so many series. So let's see what is that. So if you see micro 810 controller, micro 830 controller, micro 820 controller, and here you are having micro logic 1100, 1200, 1400. So these are all come under micro and nano control system. Yes, so inside this micro 800 control system, it is having various series. The processor may be changing, the memory size will be changing, number of IOs will be changing. So like that, these are all the criteria for these types. So if you find the difference between micro 810 and micro 830, it will be a number of IOs or the expansion module count, like that it will get vary, right? You see guard logic 600. So this is one of the safety control system, right? And compact logic and control logic 5580, 5570. So these are all the large control system, right? So PLC general 3 classification, in that classification is also having multiple series. So these series will be differentiate each other with the CPU and memories, number of IOs, like that it will be changing. So this is about PLC types and introduction to Allen Bradley. We'll meet you in the next session with the softwares we are going to use for programming the Allen Bradley PLC. I'll meet you in the next session. Thank you. Hello everyone. In this session, let's see the softwares we are going to use in Allen Bradley PLC, right? So since we have seen the types of Allen Bradley PLC, so we are having 3 types now. So in that 3 types, Pico and Micrologic will be coming under Nano and Micro PLCs. SLC 500 will be coming under small PLC, and this is the large one, logic platform. So for all these 4, we will be using these 4 softwares. For Pico, we should use the PicoSoft software, and all the Micrologic family will be using RS Logic 500, and even SLC 500 also can use RS Logic 500 PLC software, right? And in a large scale control system, like we have seen the control logic kind of PLC, we should use the Studio 5000 or RS Logic 5000. So these are all the software name, and depends upon the software and the type, the number of IOs will get varies, right? So we are having number of IOs for Pico will be 32 and inputs and 32 outputs. It may be 156, and like that it will vary. If we are adding some expansion modules, you can increase the number of IOs. So in this course, we are going to study for Micrologic PLCs, right? So we are going to use this RS Logic 500 for our PLC course. So I'll meet you in the next session with how to download and install the RS Logic 500 software in your system. Until then, bye. Hello everyone. In this session, let me see Allen Bradley PLC software package. So we are going to use RS Logic 500 as a programming software. So if we want to do the simulation, we are in need of 2 more package. Let's see what is that. So RS Logic 500 is a programming software where we are going to write the ladder logic for all the applications and examples or exercise, whatever we are going to do. We will be using this RS Logic 500 software, right? So RS Logic 500 is a programming software, right? If you are doing a program in this, how we are going to simulate it? We need to check whether it is running according to the logic or not. For that, we are in need of simulator. So that simulator is RS Logic 500 Emulate. So this is a simulation software. By using this software only, we can able to check whether our logic is right or wrong. So this is the symbol for RS Logic 500 programming software, and this is the emulator. And how to make the communication between RS Logic 500 and RS Logic Emulator. So for that, we are in need of third software, which is called as RS link. So which is the communication software which is used to make the link between your programming software and your simulation software, right? So if you are having all the three package, then only you can able to write a program and you can able to simulate it. Without RS link you cannot able to do the simulation. So RS link is the important one for making the communication. So that's it. So we'll meet you in the next session with how to download and install the software. Until then, bye. Hello everyone. So in this session we are going to see how to download these three packages from AB website. So first we need to download programming software, then emulator, then communication. You can rearrange the order. There is no particular order for installation, right? So let's go to Google. So in Google I'm just going to type AB or just type over here ab.com. So once you have entered into the AB, just go for downloads. I'm just clicking downloads. So it is taking us to the product compatibility and downloads. So before getting into the download, you need to make a account in the website, right? So already I have created my account. So without creating account, you cannot able to download the software, right? So once your sign up is done, you just go for this search button. So just type, just a minute. Just in this, just type RS Logic Micro Starter Lite. So once you have typed that, you will get the option RS Logic Micro Starter Lite. So don't go for separate link, okay? Because we need to download three package. Don't go for separate search, okay? Just type this one. You can see RS Logic Micro Starter Lite. Just select this. It is loading and taking you to the new page, right? So just wait for it. And yes, so you are seeing a download option here. So click on that. So it is taking us to the download page. In the download page, you are seeing 1763, some LXX, some series. Micrologic 1100 series is there. So in this, just expand this. Can you see? Just expand. Can you see the plus mark? Expand that. So once you expand, it is giving different version. So just go for version 11. Just select version 11 and select files. So once you click the files, select files, it will take you to the selection page. So in this, you can find your programming software. This is your programming software. Just click on that. So this is the version 8.30. This is the version we are in need. So just click on RS Logic Micrologic Starter Lite. If you come down, you can find your emulator also and classic also, communication software also. It is like 1 in 3, right? So because of that search only, you are getting all the three packages in one link. Else you need to download each and everything separately. Search and download separately, right? So if you follow this step, you can get all the three packages in single shot, right? So just go for downloads. So it is again asking download now. So once you click the download, it will take you to the basic details. It will ask for the name, where you are from, like that it will ask. So once it will ask for the phone number also. That is for general questions only, and there is no money for downloading this, right? So once you have done this, it will give you this page, right? Just flow, go with the flow. Just 2 steps are there, right? So once you are done, you will get a page like this. So once you click on this, it will ask you where to download. That's it. So downloading is done, right? So I'm just downloading. So it will start downloading. Yes, it is started downloading. Can you see here? And same, I'm going to download this emulator also. I'm going to put that in desktop itself, and also I'm going for link, right? Just click on that. Yes, just download. That's it. So this is the downloading procedure, and I'll teach you about the installation in the next session. Hello everyone. So in this session we are going to see how to install all the 3 packages. So once you have downloaded, you will have a package like this: RS Classic, this is Microlite, and this is Emulator. So just extract this first. Right click, extract. So once you extracted, it is again in a zip file. So again you just extract it. Yeah, so this is a setup file, and you just extract RS emulator also. Yeah, so it is in a folder, right? So first we'll do the setup for Microlite, which is a programming software. Okay, just click on it. Yeah, just go for yes. Yeah. Go for next. It will give the option. It will enable the option. Yeah, go for next. Accept. Go for next. Just give any name you can give. Go for next, and it should be complete, right? Go for next. Install. So it will take some time, right? Yes, so once it is downloaded, you will have the option called finish. So once you click, it will take you to the release notes. So that's it, that installation is done. So you just close this, and you can go for emulator now. Just click on this setup. It's a normal setup only, nothing new. Just give next and user agreement. Yes, so it is also giving the release notes. You just click on finish. So RS emulator is also done. Go for classic now. So this is a communication. click on that. So this is the one, it will take some time, right? So nothing new, you need to go with the flow. So just give, if the license is there, you just accept it. If it is asking for the complete download, you need to click on that. You can check the location. So for next, so RS link usually it will take some time comparing to ladder logic programming software and emulator. Since it is a communication software, you should have that patience to to follow the steps. It will take some time. So now the hardware installation tools are downloading, and it is having 13 steps to decompress the file. Yeah, that's it. The installation is done. Just click finish. So again the release notes came, right? For RS link it came. So this is the way to install the softwares. I'll introduce the software environment, like how to program, how to set up the configuration, everything we will see in the upcoming classes once the basic programming parts are done. Fine. So I'll meet you in the next session. Bye. Hello everyone. In this session, let's see about the programming languages in PLC. So we are having 5 languages to program the PLC. So ladder logic, functional block diagram, structured text, sequential function chart, and instruction list. So these are all the 5 languages, and in this course we are going to study about ladder logic. So let's see about ladder logic. So it is originally designed to represent construction and design of relay racks. So deployment of ladder diagram as the foundation stone of the new programming languages can be declared as practical, and programming in this language resemble ladder with vertical and horizontal lines. So ladder we will be using to climb some heights, right? So like that, a programming structure will have 2 vertical lines and some horizontal lines. So there only we will be writing the program. So ladder language is the classic programming language. When they have invented the PLC, they have introduced the ladder logic, and people started using ladder logic in 1970s itself, right? Still it is used in most of the industries. So yeah, it is widely used programming language in industry. And before entering into the ladder logic, we should know what are the components we are going to use in ladder logic. So these are all the 4 things we should know. The first one is power rails and rungs. So I have told 2 vertical lines and some horizontal lines. So these 2 vertical lines are called as rails, right? So or it will call as power rails. It will be plus, one side it will be plus, this left side will be plus, and this side will be minus. So this is called as power rails. And the horizontal lines, not only one line, there will be multiple lines. I'll show you in the software. So the horizontal lines are called as rungs. Okay, so power rails means it's a vertical lines, and rung means it is a horizontal line, right? And the next one is normally open contact. So this is one input and normally closed contact. This is another way to represent the input. So there are 2 types of input. This is called as normally open contact, normally closed contact. This will also, I'll explain the working when it comes to the software, right? And we are having output coil, which is used to represent the output. It may be a lamp or it may be a motor, like that. Fine. So these are all the components of ladder logic. So we need to know what are the do's and don'ts in ladder logic. So as I have told, we will have two horizontal lines, two vertical lines, right? So in that, this will be left side and this will be right side. So we should connect all our inputs to the left side only, right? So in the right side, we should end the rung with the coil. We should not end our ladder logic rung with input. It will be showing the error, right? That's the first point. And second point, the coil should be in the right side. So output should not be in the series. So in one rung, there should be only one output. You cannot connect multiple outputs in the series. So remaining do's and don'ts, I'll explain in the software itself. So we'll see the project creation in the next session. Until then, bye. Hello everyone. In this session, we are going to see how to create a new project in RS Logic 500. So the creation of project will lead us to write a program in ladder logic. So since we have the programming software is RS Logic 500, whenever you want to create a project, you should open RS Logic 500. So let's see how to do that. So just go to Windows. Right, you can find RS Logic Micro English here. So if you couldn't able to find, you just type over here RS Logic 500. Yeah, so you'll get RS Logic Micro English. Just click on that. So this is the programming software. So just maximize it. So this is the landing page when you open RS Logic Micro Starter Lite, right? So next, just go for File. So just click New. And when you click New, it will ask for the processor type. So RS Logic Micro Starter Lite. So this is the software which will accept only few processors, right? So if it is RS Logic 500, we can have more processor types. Since we have downloaded this from AB as a free software, we can have access to use only few processor, right? So once you choose the processor, you can go for OK. For example, I'm going to choose this MicroLogic 1100. And what may be this one and what is the difference means there may be a different in number of IOs. Apart from that, there is no huge difference. Okay, so just click any processor and go for OK. And once you click OK, your project is created. So this is the programming software environment. So this is the rung we have seen, right? Rung and rails. So this horizontal line, a small line is over there, right? This one and this one are rails, and the horizontal line is called as rung, right? And you can find the normal tools like open, save, print kind of, and you can verify the file. I mean, for error checking, zoom option is there, zoom in, zoom out and all. And these are all the instructions you can get. For writing a program, we are in need of instruction, no? So those things you can get from here, right? And this is the symbol we have seen for RS, programming software. And this is the project tree. This is the project tree. Here you can get the controller properties. If you click, it will tell you the controller properties. Can you see the controller properties and all you can get, right? So apart from that, this is IO configuration. Anything if you want to do with the IO configuration, you can. For example, see, this is the slot 0. Here we have added the processor. So if you are in need of some extra IOs, you may add some expansion modules. So if you want, you can add those expansion modules. See, for example, if I click this, that will add here, right? So like that you can do. I'm just going to delete this because I don't want now. So this is the IO expansion. You can add according to your requirement. And this is the channel configuration, and this one is important. Program files are important. See, this is the ladder logic, this ladder 2, this is the main page. Okay, and these two pages are used by the system. We'll see in the next session detail about this programming files and data files. So data files are the addressing format, right? For input, for output, it will have a different data files. Let's see that in the next session. So simply this is the way to create a project. To save this, just go for file, save it. It will ask for the name. Wherever you want, you can save it. I'm just saving this with example 1, right? So yes, so I'll meet you in the next session with CPU configuration and addressing format. Thank you. Hello everyone. In this session we are going to see CPU memory organization in RS Logic 500. So let's see that. So it is having two types of memory. One is user memory or also it is called as program memory, and the second one is data memory. So in user or program memory there are 4 things. One is system 0 and system 1, ladder 2, and from ladder 2 to ladder 255, right? So ladder 2 is the main program file. So here only we need to start a project. So apart from that, if you want to use some subroutines or subprogram, you can make use of ladder 3 to ladder 255. So up to 255 we can create the ladder program. And this system 0 and system 1, these two are assigned to system usage. It's not for user. We cannot write anything inside this. Even we cannot open that also. We can start writing program from ladder logic 2. So all these 4 are in user or program memory. If you come to the data memory, you can find some data files: output, input file, status file, binary, timer, counter, controller, and integer, float. So these are all the files you can get from data files. I'll show this in a software. So before that, let's see about addressing in Allen Bradley. So if you see the addressing format in Allen Bradley, it is having 5 things. One is file type, file number, rack number, and group, and the last one is terminal number. So what is this file type is, whether it will be telling whether it is an input or output, or whether it is a timer, it is a counter, like that. If it is an input, it will be start with I, like this, right? So if it is an output, it will be like a O colon, it will be O. And if it is a binary, you can find B3, it will start with B3. And if it is a timer file, it will be T, it will start with the T. Counter, it will be C. Float, it will be F. For integer, it will be N. I'll show that in a software. And if you see, this is the output data file. You can find, see, for the Micrologic 1100 series, you are having O colon 0.0. So this will be the channel. In one channel, it is having 16 bits, right? So in PLC, in one channel, it is having 16 bits, right? So it will be type colon word slash bit. So what is this type is, it will be like I, and this colon is a separator, and this 0, this one will be the channel, and this is the group, this one, terminal number, right? So like that we need to give the address. If it is the output, it will be O colon 0/0, right? So generally file number is used to define the number of IO, which IO module it is. Module, it will tell the module. And rack determines which rack the module sits in. So if we are going to place this module in the rack, so in that case, in which rack the module is exactly placed, that will be tell by this rack number. And group is a set of terminals within the rack, and the terminal is nothing but the bit number. So for example, terminal is 1 means that will be implying this one. Terminal is 15, 16 means it will be this one. It will be 15. So totally 16 bits. Since the address is started with a 0, we are ending with a 15, right? So this is the module addressing. I'll show this in a software. Yeah. So in the software, you can see program file system 0, system 1, and this is the main program, right? If you want to create, you can go with program files new. So that will be the ladder logic 3. So like that, these are all comes under the user or program memory, and this is the data files, right? You can see output file, input file, status, binary, timer, counter, control, integer, float. So these are data files. So if you open the input, you can find the number of inputs over here. See, the first 4 and the last 2 are analog inputs. So for micrologic 1100 series, you are having 2 analogs. So if you want to see the address of the particular bit, can you find here i:0/0. So if you are going to use some inputs and outputs in your project, you need to give the address. So address is the very important one when it comes to PLC. So address is not common for all the PLC. Addressing format is completely different. So in Siemens, the address will be different. So that's it about the addressing part. I'll meet you in the next session with another interesting topic. Thank you. Hello everyone. In this session, let me see the basic instruction. So for that, I'm going to get help from this slide. So in this, we have seen already in the previous sessions, right? Components of ladder logic. So here, these 3 are the basic instructions. Normally open contact, normally closed contact, and output device. So I'm going to teach you how to take the instruction in your programming software and how to give the address to this. Let's take a software. So in your software environment, this is the rung and rails. So this horizontal lines are called as rungs and the vertical lines are called as rails. So whatever instruction you want to add to your program, you should connect in your rung. So this is the 0th rung. You can find the number 0000 and this is the first rung, right? So the first thing is, if you want to insert more rung, then you can go for the menu. These are all the menu. You can get all the instructions. So in the user option, you can get the rung. You can get new rungs like this, right? So if you don't want, you just select the rung and keep press delete button, so it will go, right? So I'm going to use only one rung now. So this is the only rung, and this is the normally open contact, normally closed contact, and this is output coil. So if you just keep the cursor near the normally open contact, it will give some name. Examine if closed. Can you see? Examine if closed. That means this is a normally open contact. In Allen Bradley, it is called as examine if closed. The short form of this one is XIC, right? And if you see examine if open, that means this is the normally closed contact and this is the output energize, right? So just go for this one, examine if closed. So how to get that? You just click. See, after clicking the rung, you just click on this. So it will come over here. So this is the one way of taking the instruction. And the another way is, once you click the rung, just type XIC, right? So if you click XIC and click enter, normally open contact came. Got it? So how to take a normally closed contact? Just click on this and it will come next to this. If you want normally closed contact to be at the first, you need to click here and click on this. It will come here, right? So once where you are clicking, after that only the instruction will come. Where your selection part is there, after that if you are clicking, whatever instruction you are selecting, that will be coming, right? So now after you click on normally closed contact, next I am going to click output. So it will be coming at last. It will not come here because this is the last instruction, so it will come here, right? So if you click one more input, you can connect like this, right? So this is a way to take instructions, and it is asking some question mark over there, right? Correct? So you just click on the question mark, you just type the address of this contact. So how to get the address? We have seen the addressing format, right? So for input, if we are using this bit, so it will be I:0/0. You just see, you can see here, see, I:0/0. And the next one, if you want to give, you can give I:0/1. So let's give any address you can give. Just I'm giving I:0/ oh, it's not selected. Yeah, I:0/1 I'm giving, right? After you have written the address, just click enter, right? So once you click enter, it will be there. So the first contact is having the address of I:0.0/0/1. So that 1 is the terminal number. So for this you should give another address, because these two contacts are not same, right? This is one input and this is another input. So go for some other address, I:0/2, right? That's it. I'll tell you what is this later in the next session, right? So like this only you need to give the addressing part. So for output, just click on the question mark, just type O:0/1. Any address, you can start with 0 also, no issues. Yeah, so this is what you need to give. So you can find some E over here, right? This is like error. It means you have written the program, you need to verify whatever you have written is right or wrong. So how to verify that means, just click on a verify file. If you click on this verify file, it will give if you have any error or not, right? Just click on that, so that E is gone, and you can see here verify has completed, no errors found, right? For example, voluntarily I will give some error here. See, I have not given the terminal number, right? Just go for verify file. Now it is telling error is there. So one error. What is that error? Invalid submember specified. Correct? Because I have done the mistake, right? So just change that and check for verify. Now it is, yeah, you need to give enter also, right? Just type I:0/2. Yeah, so you should give the enter properly, then go for error check. It is gone. So now our program is ready to run. Fine. We'll see in the next session how to do the download and how to run a emulator. Thank you. Hello everyone. So in this session, let me see how to start the emulator, how to download the program first, and how to start the emulator. So for that I have taken one input and one output, right? So just verify the file and there is no error. If the error is there, you cannot able to run the program. So just make sure you are not having any error in your program. So once your program is not having error, just go for this place, just save it. If you are not saved the file, I have already saved it. with the name called EX1. If you want, you again save it, or if you want to replace, or if you want to save as, you can go for file save as. You can change the name of your file. So I'm not going to do that. So let's go with EX1. So once you are make sure there is no error and you have saved the file, and the third point is go to the option called offline. Click on the arrow mark, click on the symbol like download, go for download. So it is telling no response from processor, right? So for this we need to do the RS link setup, right? So how to do the RS link setup? Just go to Windows and type RS link, right? Just click on this RS link classic. So this one we have seen already. This is the communication software, right? So just go for this option, which is called as configure drivers. Click on that. Once you click on the configure drivers, it will give you the window available driver types. Just click on that and select the emulator. So now we are going to do the simulation, right? So just go with this SLC 500 emulator driver. Click on add new. So just go for OK and OK. Now the emulator is running, right? Just close this and minimize your RS link. So now we have linked the programming software with the emulator. You can find here. Driver is emulator. Before that it was not there, right? So just click on download. So once you click on download, it is again telling the processor is not supported by RS Logic Micro. If you are facing such issue in the beginning, just go for the controller properties, go for controller communication, go for who active. So it will take you to the another page, okay? So it will take you to the another page, which is communication, right? So in the communication, just select this workstation and click OK. Yeah, once it is OK, go to your previous window, just click apply and click OK, right? Now go for download. See, first step, you have done the RS link setup. And since you are running your software for the first time, you need to do the setup we have seen before also. You may come across such option in after doing so many programs also. That means that IO configuration. So for that you need to go for the controller properties. You need to choose that whatever we have done before, the same thing you need to do. After that, if you download, it will be giving you this option. Just go for yes. Do you want to go for online? Click on yes. So it is downloaded. The next step is you need to click the same option and go for run, right? So are you sure you want to change the processor mode to run? Click yes, right? So once you click yes, can you see the rail is in green color? That means it is in a running mode. It is ready to run, right? So you can able to turn on the switch and you can able to see the output also according to the program you have done, right? So this is the way to do the programming settings. To see the simulation, this is the settings you need to do. And if you go for the offline, just click on the same option and click go offline. So this is the editing mode. Now if you want to change any changes, if you want to do in a program, you can. See, I'm going to add one more normally closed contact and I'm giving some address for this, right? So check for errors. Again, once you have set the communication path in the RS link, see, we have already set the communication in the RS link, right? That is one time only, right? So it is done. After that, whatever changes you are doing in a program, you can straightly verify the file and go for download. Now the download is directly coming. There is no need to set the path again and again, right? Just go for OK, go for OK, and go for it. Click run. So first we need to go for download, then go for online, then use run option. Yes, so this is the way to go for the online, right? In the next session we'll see what is this NC, how it is working, and next what is this NO. I mean, this is NC, this is NO. We'll see what is the working of or function of these two contacts and how it is going to give the influence to the output. So once we have done that, we can run this, right? I mean, how to turn on this, we'll see in a upcoming session. So we'll meet you in the next session. Bye. Hello everyone. In this session, we are going to see what is the function of normally open contact and what is the influence it is going to do with the output. So let's see that. So select the run and go for normally open contact, which is called as examine if open in Allen Bradley. Select that and give the address I:0/0 I'm giving. Just click OK, and it is there. Select output and give address O:0/0. Click OK, and it also came. Verify the file. So what is this normally open contact? It is like a normal switches we are having in our home. What it will do? Unless or until we turn on a switch, it will not turn on the respective devices. Take an example of your fan. So to turn on a fan, you need to turn on the switch in your home, right? So if you turn on the switch, then only the fan will be running. If you turn off the switch, fan will be off, right? So this is the normal switch we are having in our home. Exactly, it is resembling the function of normally open contact. So whatever switches we are having in our home is a normally open switch. That means what? The control is in our hand. If we turn on, then only fan will be on. If we turn off, fan will be off. So simply we can tell the switches we are having in our home is a normally open contact. So I'll show you with the simulation. So I am going to take, imagine this is your switch and this is your fan. Output is a fan, right? So how to go for online we have seen already. Click download, click yes, and it will take you to the, there is one error. So I'm just going to set the controller properties or just go for save as function, save as option, go for some different name, go for download now. Yes, it is happening now. Do you want to go for online? Click on yes, go for run. So as I have already told, see, you have not touched the switch, so output is off. Your fan is in off condition. Now how to turn on a switch? So usually in our home we will be pressing that, right? So it will be, it's like a toggling from 0 to 1 or 1 to 0. So how to turn on a contact, this NC or examine if closed contact in Allen Bradley means just click on the contact which you want to turn on or which you want to change the position. Click on that, right click. So I just right click and there is an option called toggle bit, right? There is an option called toggle bit. Click on that. So once you click on, it is on. That means can you see the green color over there? So it implies that the switch is in on condition. Because of the switch is in on condition, you can find your output is also in on condition. Can you see your output is also in on condition? So suppose if you turn off this, to turn off this, there is the same procedure, right? Right click, toggle bit. That's it. It is off. Can you see the green color is gone? and your output is also off, right? So if you want to turn it on again, you can do it by toggle bit, again toggle bit to turn off. So this is the working of normally open contact, right? The control is in our hand. Unless you toggle it, it will not turn on and it will not turn on your output. So normally open contact function is like the switches we are using in our home. So I'll meet you in the next session with normally closed contact topic. What is the function and all we'll see in the next session. Hello everyone. In this session we are going to see about normally closed contact. So what is the working of normally closed contact? So I'll explain with the simulation, right? So for that I'm having one normally closed contact and with the output coil. So without the output we cannot able to do the simulation. For example, see, I'm removing that. So just go for verify file. It is giving the error. Output missing on run. So obviously output is much needed one in program, right? So just check for error. There is no error, right? So I'll just give the gist of information about normally closed contact. It is just opposite to normally open contact. What is this exact opposite means? The control initially it's not in our hand. That means once you go for the online, the the contact is already in on condition. See here, there is a difference. See, if I take a normally open contact, there is no green line above, around it, right? But see, normally closed contact is having green line around it. That means what? It usually in a normally closed condition, the switch is like already pressed state, right? So I'll explain this with simulation. Just go for download, go for online and click no. Just click run. Yes. So once you click on run, can you see the output is on? But we have not disturbed the switch, right? We have not toggled the switch yet. But output is on. So this is the function of normally closed contact. That means the switch is already in a pressed condition. So it is making the output to on. If you toggle it, what will happen if you toggle the switch which is in already closed condition? Yes, it will get open, right? So right click, toggle bit. So it will get open, which will make your output to off, right? So this is what I have told. This is exactly opposite to normally open contact. So if you press again, if you toggle it again, it will be on. If you toggle it again, it will go off. So this is what the working of normally closed contact. I'll explain it again because see, now it is normally closed contact which is having this green color around it. And this is in a off condition. When you go online, you cannot see the on condition of output when it is in a offline. That one you need to understand. Just go for online now. Go for download. Again it is showing the server through an just go for save. Just rename the file. Yes, just go for download. Go for online. Yes, run. Yeah. Can you see? Once you go for the online, you can able to see the output is in a on condition, right? So if you toggle it, it will go off. That's it. So this is the working of normally open and normally closed contact. So let's take one more run. There I am going to have one normally open contact, one different output, so that we can able to see the difference between both the switches clearly. For that you should give different output, right? You should not give the same output because each rung should have different output. Output can be act as the output in only one place, right? You cannot connect two outputs in different location. Just hold on, I'll just rename it. Go for download. Run. That's it. Can you see? The normally closed contact is making the output to put in on condition initially. But normally open contact is not turning on your output because it's open. It's in an open state, right? You can close this to see the output. If you toggle it, it will become open, right? So this is a way to use a normally open and close contact. And one more point I like to add is, so here I have taken this as a different switch, right? This is first switch and this is the second switch because I have used a different address. What if I use the same address? Because since it is a logic, see, I have given the same address. There is a way to copy the address, like you can drag it and place it over here. Okay, so fine. So now see, both are same switches. Since it is a logic, I can use the switches in a multiple places with the multiple conditions also. Like see, here the switch I:0/0 is as a normally closed contact. Here the same switch is act as normally open contact, right? Just check for error. Go for download. Just go online, run. Yeah. Now see, the same switch is normally closed is output is on and here it is off. Suppose if you toggle it, if you toggle anything, yeah, can you see? Once I toggle this, this is on because both are sharing the same address, no? If you toggle it, that will become close. See? So this is the logic. So you can use your inputs in multiple places as different switches. That is your choice, depends upon the requirement, right? So that's it about a normally open and closed contact and the coil also. So we have seen the three important components and we have seen the simulation also. So in our next session, we'll see how to give the description and how to give the rung comment and the title and all. We'll see in the next session. Until then, bye. Hello everyone. In this session, let me see how to give the description for the contact or output and how to give the comment and page title. So let's see that. So for that I'm going to take one input and one output. So just give any address and for this also you can give. So generally what is the description means? Like what is this I:0/0, whether it is a switch or it may be a push button or it may be a sensor or it may be a output contact also, because in ladder logic we may use output as a input in some logic as per the requirement. So in that case we need to give some information about the contacts we are using, what it is exactly, so that we can easily understand while we are go through, right? So how to give the description means just select the contact, right click, go for edit description. If you go for edit description, it will give you this page, small window. In that you can type what exactly this I colon 0/0. I'm just giving this is a switch 1, right? So just click OK. When you click OK, you can see a switch 1 name above the contact. So like that, if you see this, you can easily get I colon 0/0 is switch 1. Like that, you can able to get the information from the edit description, right? And same for output also, if you want give description, same procedure, right click, go for edit description. I'm just typing, this is the lamp 1, right? So once you click OK, it will be coming over there, right? This is the one way. And another way is, while creating contact itself, it will ask, for example, this is a new contact I'm going to create, I colon 0/1. So when you click, it will take you to the description page, right? So here also you can type your description, like that you can give. So if you want to edit this switch to means, you just click on that or right click, edit description. Two ways, you just click on it, it will take you to the description page directly, and you need to click on exact the description. You should not click on here, you should click here. So whatever change you want to give, you can give. Like I'm just giving this is switch 3, so it will be updated here, right? So this is the way to give the description, right? And the next one is run comment. Like you want to give some information about this whole rung. In that case, you can make use of the rung comment. So I'll teach you how to do that. So just click on the rung. Which rung you want to give the detail. Like for example, for this rung, for the second rung, if you want to give any information, you need to click on that. Or else you are going to give for this. So I'm just clicking on, I'm just selecting. This is a selection portion, right? Wherever you are keeping the red color is coming, no, that is a selection, right? So just click on that and right click. There is an option called rung comment. This is edit comment, no? So this is the rung comment. Just click on that. So when you click on rung comment, you will see two options. One is page title, another one is rung comment. So in the rung comment, you need to type what you are going to give information about the particular rung. So I'm just giving when switch 1 is on, lamp 1 is on. Like that you are just typing. You are giving some information about the rung. So once you click OK, can you find a yellow color highlighter over there which is telling about the rung? So this is the rung comment. Suppose if you want to give to this rung, same thing, go for select that, go for edit comment and you can type. That's it. It will come over above the rung, right? Which rung you want to give? Above that, the rung comment will be coming. So this is the rung comment, right? So there is one more option called page title, edit title. This is like for the whole page, what is the title? So I'm just giving so this is my project title. So lamp on off project. Just click OK. You can find the project title here. So this title is common for all the rungs. Rung comment is corresponding to that particular rung, right? So this is the description and rung comment and this is the title. Suppose, see this one is in a fluorescent color, right? Green color, and this one is in yellow color. The description is in some different color, right? So if you are not okay with these colors, you want to customize this, you don't want, see I'm selecting, this will be like a red color, right? So you don't want such colors, you want to give some light colors or you want to change the colors, means there is an option. For that you just right click on any place over here, right click properties. So once you go for the properties, it will take you to the colors. In that you can give, see description, this is the text color is black already, and this is the background color. If you want to change, you can, right? See I'm changing this to gray and just apply and it is changed to gray. Can you see, right? And same for comment. Comment the background color is yellow. If you don't want, you can change this to some other color like this. And this is the page title, right? Page title, it is in a green color. You can change that to some different color. Oh, that is a text color, and this is the background. You can apply and check how it is looks like. If you don't want, you can change. That's it, right? You can change, and moreover fonts also you can change. This Times New Roman is there. Font size, if you want to increase, you can increase. That's it. So this is the way to give and customize description, rung title and page title, right? This is like a project title. This will be at the top only. Rung comment will be added above the rung. That's it. I'll meet you in the next session with another interesting topic. Thank you. Hello everyone. In this session, let's start the programming concepts in ladder logic. So in the previous sessions, we have seen that what is NO, NC and output coil. With these three components, we are going to start our programming concepts. Let's see the first example. So write a ladder logic program to turn on a lamp when switch is on. So there is one input which is called a switch SW1. When we are turning on that, it will turn on the lamp which is called as L1. And I have a small animation over there like how it is in a practical way. Let's see this. This is the switch. When we are turning on, that time lamp need to on. When we are off, it will be off. But in a question, they are asking us to just turn on, right? So you just watch this. It's like a switch. It may be it should be a toggle switch, right? Like how we are having in our home. Like that it will be. Just watch it again. Yeah. So this is toggling. Up to this only our program is there, right? So how to do this in a ladder logic? First you need to guess what kind of switch you're supposed to use, right? For this particular switch, for this particular example, what kind of program we are going to use, that is very important. I mean, what kind of switch we are going to use. When we are turning on, that time only lamp will be on. So obviously the control is in our hand. The control is in our hand means that should be a normally open contact, right? So normally open contact directly connected with your lamp. So since they have given the command, I mean description as SW1, I am going to change this to SW1 and this is L1. That's it, right? So let's simulate this and check. Right? So just turn on. How to turn on? Right click, toggle bit. So whenever your SW1 is on, your lamp is on. Got it? So up to our exercise problem, this is what they have asked. Whenever SW1 is on, L1 is on. That's it. They didn't ask us to turn off and on. So this is the answer for the first question. So let's move on to the second question. Let's go offline. Yeah. So what is our second question? When SW1 is pressed, L1 is on. When SW2 is pressed, L2 is on. When SW3 is pressed, L3 is on. So they are having 3 inputs and 3 outputs. Let's see that here. See, when W1 is pressed, L1 on. Okay. And the third one. Right. So up to this one they have asked. So they are having 3 inputs and 3 outputs. Each input is having corresponding outputs, right? So each and everything is not interrelated, like SW1 is not related to SW2. So let's see this in a software. Since they are not having any relationship between each inputs, all the 3 inputs should be in different rung. So let's see that. So you should add 2 more rungs, because the next line is for next switch and this is the third switch. Since we have used this address, I am going to use some different address here. I:0/1 I am going to use, and this is SW2 I am giving, right? And for this I am going to give the next address. You can type that I:0/2, or you just drag this and place it over here. After that you can change. This is a shortcut way. You just change and give the new description. So it will be like this now, right? I'm changing everything to capital, right? So now the next new output L1, L2, L3, right? So I'm just giving new address with new comment, new description L2, and this I'm going to type L3. That's it, right? So the error check, go for download online, run. Now how they have done in a program, see, yeah, see, when they are turning on the first switch, L1 is on, correct? Yeah, so same thing we are going to do now. I'm going to turn on this first. See, here L1 is on. You are turning on the second switch, L2 is on. Turning on the third switch, L3 is on. That's it. So one by one you are turning on. Here we have connected everything in the different rung, because each and every input is not interlinked. There is no connection between the inputs and there is no connection between the outputs. All are different, right? So that's what I have connected everything in the different rung. So this is the solution for the second problem, right? So I'll meet you in the next session with third and fourth problem. Until then, bye. Hello everyone. In this session, let's continue with the previous session. So we have seen example 1 and example 2. So let's see the example 3 and 4 in this session. So when switch 1 is pressed, L1 should on. When switch 2 is pressed, L1 should go off. So here they are having 2 inputs and only 1 output. So what are the 2 inputs? SW1 and SW2. And 1 output is L1. So let's see the animation here. So they have turned on the SW1, L1 was on, now it is off because they have turned on the SW2. Let's see it again. Yeah, turning on, L1 is on, right? So when SW2 is on, it gone off. Yeah, so initially it is an off condition. So when you turn on this, it is on. If you turn on, it will go off. So let me see how to do this in a software. So this is very important, right? Because so far we have seen how to turn on an output. Now they are turning off the output, but with a different switch. It's not with the same switch. If it is the same switch, you will turn off that, right? But in the question, they have turned on SW1. They are not turning off in the old problem, right? After that, they are turning on some different switch which is making your L1 to go off, right? So see, this is a way to connect, right? To turn on SW1 is directly connected with the L1. So there is some rules in ladder logic. You should have it in your mind to understand the logic better. The first one is, whenever you want to turn on some output, that output should connect with that input directly without any disturbance. Without any disturbance in the kind like there is no need to connect any input or contact, anything in between. It's not like that. But even though you are connecting some inputs or some contacts in between the input and output, it should not give any disturbance to the output, right? So you should connect directly with your input. So I'm connecting SW1 directly with L1, right? So now if I turn on, this will on. Now I'm going to give one more input which will make my L1 to go off, right? So L1 is already in on condition. How to make this off? I need to disturb the line, right? See, this line was so clear. There is no disturbance in this line. That's what this is on. If I disturb this line, this fellow will go off, no? So that is the logic. So how to put the SW2 now? So let's connect like this. Let's give SW2 like this as a normally open contact. I should give I:0/1, right? Yeah. Now if I connect like this, what will happen? So let's see that. Because whenever you are going to give some input, you should finalize whether it should be a NO contact or NC contact. See, when I am turning on, my output is not on because this fellow is restricting to enter. This power flow is stopped here. So SW2 should not give any disturbance to SW1, right? So it should not give any disturbance means I should connect a NC contact like this. I should connect the NC contact, else it will be producing some disturbance when SW1 is on. See, if I give NC contact, let's see what will happen. Let's go for online, run. Now see, if I turn on, it will not give any disturbance. It is directly turning on my output. So this is what I have told. If you want to turn on an output, there should not be any disturbance. So even though I have put one contact, that is not creating any disturbance, right? So now here also you can get your second concept also. What is the second concept? Whenever you are turning on your SW2, your L1 should off. Suppose if you toggle this, your L1 is off. That's it. You got the logic now. So what is the conclusion means? If you want to turn off some output, use a normally closed contact. So normally open contact is to make the path or make the output to turn on, and normally closed contact is to break the output, break the line or break the circuit, anything you can take, right? So if you want to turn on, use NO. If you want to turn off, use NC. That's it, right? So this is the solution for the exercise number 3. Whenever SW1 is on, see, I'll repeat it again. This was the initial stage, right? So you are turning on, L1 is on. So if you are turning this on, L1 is off. That's it, right? So this is example 3. So let's see what is example 4. When SW1 is pressed, Q0 should on. When SW2 is pressed, Q0 should off. When SW3 is pressed, again it is on. Yeah. So it is off now. When this is pressed, again this is on. Got it? Yeah. SW1 is pressed, L1 is on. SW2 is pressed. It is going to press. Yes, L1 is off. So here they are having 3 inputs and 1 output. They have given Q0 here, and in the animation it was mentioned as L1. So any name you can give as a description, right? So let me take L1 instead of Q0. Let me take this as L1, right? So let's see how to do this in a software. So unlike our first problem, there in a first problem there was no connection between your inputs, but here there is a connection. What is the connection means? Whenever it is SW1 is on, your L1 was on, but whenever SW2 is on, L1 was off, like in third exercise, right? So when this is on, L1 is on. When this is on, L1 is off. Now they are introducing the third contact, which is on, to make your L1 again on. Right. So I have told there are 3 concepts you need to have in your mind to understand the ladder logic concept completely. What is the first concept is, whenever you want to turn on an output, there should not be any disturbance in the line, as I have shown you here, right? Whenever the second one is, whenever you want to turn off the output, use a NC contact. That is this one. So 2 concepts we have already used in the third example. Now whenever you want to turn on the output which was already turned off in the previous step, how you are going to turn on again means using a parallel contact. But where to use the parallel contact is where the line got broke. Just try to understand. Now here is the place where the line got broke, right? Because of SW2 only, my L1 was off. So here only my line got broke. So here I need to find a route to reach L1. Suppose if you are traveling from one place to another place, you are finding some some road or traffic or some blocks over there. What you will do? You will find some other way, right? Same concept. You need to find some other way parallel to this. So parallel means you can use the branches. So there is an option called branch here. So you need to skip this, right? So you need to find a parallel path. So click on this place and click on the branch. So once you click on the branch, it will give a branch like this. Just drag this branch and keep it after the contact. So can you see, it's like a parallel path, right? If you are not able to travel this route, you can use this route. So I'm going to get one contact here, and that contact is our new contact, which is SW3. Yes. Now, even though this fellow is off, you can find this way to reach your destination. So check for errors. Go online. Run. That's it. Yeah. Turn on your first input. Output is on. Turn on your second input. Output is off. Turn on your third input, output is again on. How output is again on means this line got broke, but from positive rail to negative rail I am taking this route. Can you find SW1, SW3, and it is reaching your destination. Power will be flowing like this. Positive rail to SW1, then SW3, then it will go, and like this it will go, right? So this is the third concept. To make contact, to break contact, to again make the contact, use the parallel contact. That's it, right? So these are all the 4 examples we have seen. In our next session, we'll start the logic gates, and we need to write a program for the logic gates. I'll meet you in the next session. Bye. Hello everyone. In this session, let we see about logic gates. So we are going to write a program, ladder logic program for this logic gates. So except a NOT gate, we have 2 inputs for all the remaining gates, right? For OR gate also 2, XOR also 2, and we are having only one output. And in NOT gate we are having one input and one output, right? So let me start with OR gate. So OR gate is like a option, right? So whenever one input is on, output will be on. Whenever two input is also on, output will be off. It's like any one need to be on to turn on the output. But AND gate is just opposite. It is like a condition. Both need to turn on a output, right? So AND gate is like a condition. And NAND is just opposite to AND. The NOT of AND is NAND. And the same, the NOT of OR is NOR. So XOR is like both need to be on. Both are similar means it should be 0, right? And both are different means it should be 1, like that. And XNOR is just opposite to XOR. So let me see how to do this in a software. So first we'll start with the OR gate. So I'm going to give a run command. OR gate I'm giving. So I'm going to take two inputs, right? So since OR gate is an option means it should be a parallel connection, right? So just take a parallel connection. I'm going to take a branch here and connect after your contact. So whatever you are going to connect here is your second input. So that is, I'm going to connect this as SW2. So OR means option. So whenever any one is on, your output will be on. So this is OR gate. So let's take one more rung, and I'm going to have AND gate. What is the use of AND gate? I mean, what is the function of AND gate? It's like a condition, right? So condition means obviously it should be in a series. It's like both input need to turn on a output. So I'm going to use the same input but different output. You can have the same inputs, but output should be different. So I'm going to connect different output, and I already named this as L2, right? So let me see the output of these two first. Let's go for run. Yeah. See, any one is, I'm going to on. First I'm going to turn on SW1. See, your L1 is on. Your OR gate is giving output, right? It is like 0. When it was 0, 0, everything was 0. Now it is 1, 0, your output is on. But 1, 0, AND gate is giving 0. So we'll turn on both. 1, 1 is 1 in OR gate, and 1, 1 is OR in 1, 1 is 1 in AND gate also, right? So if you turn off any one, just turn off the SW1. Your AND gate is off, but OR gate is still giving output because it is taking this way. It is like an option, I have already told, right? So yes, so this is AND and OR gate. So let me do NAND. So NAND, how we can do? What is NAND gate? So NAND gate, it's like 0, 0 should be 1, correct? It is just different to opposite to AND gate, right? So when both are 0, your output need to be 1, right? So how the contact need to be? So it should be initially giving the output, but normally open contact cannot give the output. So in this case, you should decide which type of input you need to use. Just see the first truth table, 0, 0, 1. So it should be a normally closed contact, right? So next condition, what is the next condition? 0, 1 should be again 1, right? So you cannot connect both the contacts in series now. It should be the parallel contact. You apply all the 4 conditions, it will be working. So it should be like this. I'm connecting a new output. Right? So what happens? 0 0, it will be 1. 0 1 also it will be 1. 1 0 also 1. And when both are 1 1, it should be 0, right? So we'll do that. Just it's opposite to AND. Have that in mind. Let's do the run. See, 0 0 output is 1, right? 0 0 1. Now 1 0. I'm taking 1 0. 1 0 is still 1. Now again 0 1. So I'm toggling this and I'm toggling this. Now 1 0. 0 1. This is 0, this is 1. Output is still 1. Now both are 0 1 1. 1 1. Output is off. Since it is a normally closed contact, this is the one condition for this, right? Normally closed condition, closed contact, 1 is this stage. So output is off. See, but AND gate is giving input, it's just opposite, no? So it is off. So this is NAND gate. Like that, NOR gate. NOR gate. NOR gate is just opposite to OR. So what is OR? 0 0 0. But NOR gate should give 1. What is the second condition? 1 0. In OR gate it should be 1. But NOR gate should give 0. Right? So here it should be both are normally closed contact in series. I'm connecting different output. Right? So this is NOR gate. Now see, 0 0 output is 1. 1 0 1. This one will get break. So the current will not pass through this. Output will be off. Now again 0 1. That time also it will be off. 1 1 it will be off again. Right? So this is NOR gate. I'll give the run comment. What are the two more gates? Which is XR and XNOR, right? So let's go for XNOR. XR, let's do for XR first. So in XR gate, 0 0 means 1. Similar means 0. It means 0 0 is 0. 0 1 is 1. So here it is like a mixed combination. Right? So it is like you need to use 2 inputs along with 2 more contacts, which is a duplicate of your inputs. Let's see that. It should be like this. 1 is normally open contact in one place. See, switch 1 is normally open in first place and normally closed in second place, second branch. And switch 2 is like this. It should be open in the next place. So this is XR. Just check online. See, now both are 0 0. Output is off. Now I am making 1 0. Your output is on. Right? Now what is the next one? 0 1. Right? Now make this to 1. 0 1. Output is on. If you make both to 1, I am making this one and this also one, output is off. So this is XR. Right? So what is the next gate which is pending? XNOR. So what is the XNOR means? It just opposite to XR. 0 0 means it should be 1. That is XNOR, right? So in that case you need to use 2 open contacts in one rung, and in a branch it should be 2 closed contacts. This will be the XNOR. SW1, here it should be SW1, and same this should be SW2, and here it should be SW2. So all the 4 conditions should match your logic. Right? So this is XNOR. So let's go online and check. Just see, both are 0, 0. I have not touched anything, but your output is in a on condition. Now check 1, 0. See, this is 1, this is 0. Your output is off. Now 0, 1. 0, 1. Output is still off. If you make both to 1, output is again on. So it is like a duplicate. You should not confuse that why we are using 4 contacts for XR and XNOR. We are using only 2 contacts, but in different place. See, this is a ladder logic. This is a logic inside your program. So you can use your inputs in the multiple places, in the multiple contacts. It may be an NC in one place and it may be a NO in another place. So this is the way to use the logic, right? To get the truth table possible, to get the XNOR gate possible, this is the way, right? So I'll just give the comment XR and this one is XNOR. What is the another gate which is pending? Which is NOT gate, right? NOT gate is having one input and one output. What is NOT gate? When the input is 0, you have not touched the switch, but your output need to be in a on condition, right? But so it should be a normally closed contact, right? Because that only will give output when your input is in a off condition. L7, just go online. So I have repeated the number of contacts because each and every time if we are creating new inputs, then we need to turn on everything to perform the output, right? To perform the logic. So I'm using the same inputs again and again, right? So let's start from AND gate now. OR gate. So this is 0, 0. Just check, this is a 0, 0 condition. In 0, 0 condition, NAND gate is giving output, NOR gate is giving the output, and can you see XNOR gate giving the output, and NOT gate obviously 0 is giving output. So this is a 0, 0 condition, okay? So next, what is the condition? 0, 1. Let's go for 0, 1. I'm going to turn on SW2. This is 0, 1. So for 0, 1 condition, OR gate is giving input, NAND gate is giving input, XR gate is giving input, and your NOT gate is not having the second input, so it is not going to influence our NOT gate. Let it be. So this is 0, 1 condition. Now 1, 0 condition. Make this off. This is 1, 0, right? So again our OR gate is giving input, NAND, XR. How about XNOR? XNOR is giving 0, right? So now 1, 1 condition. Both are on. So OR gate, AND gate. NAND gate is not giving. NOR gate is not giving. XR is also not giving. But XNOR will give. Right? So NOT gate is not giving because SW1 is open. 1. 1 means output is 0 for NAND. So what you can do means you just write the logic truth table first. I have not shown the truth table for you since it is very familiar. So you just write the truth table and check with the logic over here. Just apply. You should not write a different logic for all the 4 conditions. There should be only one logic for all the 4 conditions. That one logic should satisfy all the 4 conditions. That is this logic for OR gate. This is the universal. There is no some other logic for this. Okay. So OR should be parallel, NAND should be series. And you should also find which switch. See, for NAND gate, if you are connecting normally open contact, you cannot get the answer for all the 4 conditions. So that's what I have connected NC for both the switches. See, in NOR gate also NC for both the switches. Here I have connected the mixed combination of both NC and NO. So to get all the 4 conditions, you may get, for example, if you are not connecting these two, you may get answer for only 2 conditions. For the remaining 2 conditions, this is the right answer, right? So we have seen the logic gates, ladder logic in this session. I'll meet you in the next session with another topic. Thank you. Hello everyone. So in this session we are going to see about push buttons. So push button is like a switches. So it is used as one of the digital input in industrial automation. Then what is the difference between the switches and the push buttons? So in the previous examples and in the logic ladder logic program for logic gates, there we have used switches. So once we are turning on, it will be giving the output continuously, right? But push buttons is not like that. Push buttons are like a momentary switches. So whenever you are push, it is making a contact. So if you release the finger, it will be breaking the contact. Like I can give you the example like the calling bell in our home, or you can find the emergency push buttons in the metro stations. Even in the escalators, you can find the push button in the middle of the escalator, and you can find some emergency stop push buttons in the metro platforms. So even in our home also, sometimes to turn on a motor, we may have start and stop push buttons. So you can find the push buttons in your home itself. Even in our microprocessor or microcontroller lab and all, we will have one small reset push button, right? So it is like whenever you are pushing, that time only it will be functioning. If you release, it will be breaking the contact, right? So it can be both NC or NO, right? So if you see a push to make switch allow electricity to flow. When a button is released, the circuit is broken. It is also called as momentary switches. It can be either NO or NC. So the term for pushing of the button include, it may be pressing, depressing, whatever it may be, right? So push buttons are widely used in industries over comparing to switches because it is easy for operation, and corrosion also will not happen to the push buttons comparing to switches. So that's what in industries people are using push buttons comparatively more than switches, right? So I'll have one animation for you. Just have a look into this. So this is like a start and stop push button. So whenever you're pushing this, that time only it will make a contact, right? And this is the emergency stop push button. So just see this animation now. See, whenever the man is pressing, that time only the lamp is on. See, the lamp is on now, and when he released, it gone, right? So this is momentary on, right? Whenever you are pressing, when your finger is pressed, that time only your lamp is on. Push to on, push to off, like that, right? So I'll show one more simulation. Have a look into this. So I have one push button over here and one lamp, right? So whenever I'm pressing that time only, can you see the lamp was like a momentary on? Can you see the green color in the lamp here? Yeah. Whenever I'm pushing, that time only it will on. After that, if I release, it will go back to 0. So 0 means it will be in a red color, right? I'll show it again. It is red color now, 0. So now see, a cursor is pressing, it is turning that to green color, right? So this is push button concept. I'll explain you in software also. So in Allen Bradley, there is no specialized contact for push button. There should be only one contact only. So let's take one new page. So just go for one input and one output, right? So this is your switch 1. right? Okay, and this is your output. Fine. Just go for download. Run. Yeah. So now see, there is a specialized instruction for the push button. There is only one contact for all the inputs. For all the digital inputs, you should use this normally open only. But how to work this as a push button means you just toggle it and immediately you should go off. So now see, your output is on for some seconds. When you turn off this, immediately it is going off. So this is the way of push button. See, if it is a switch, it will be continuously on. If it is a push button, it will be immediately go off. So that is the push button concept. So whatever we have seen in the animation is like this program only. Whenever you are pressing, that time it will be giving the output, else it will not give the output. See it once again. See, if you are pressing, it will give output. If you release, again it goes to off. So this is the working of push buttons, right? So what is the condition? Like, see, in an industry, if this is the concept, how come a person can be pressing the switches continuously? There should be some logic behind this, right? In our home, if you are pressing the start motor push button, if you press the start push button, even though if you release, it will be continuously on. Your motor will be in on condition only. How they are making the logic? That is very, very important. That I'll teach you in the next session. I'll meet you in the next session. Thank you. Hello everyone. So in this session we are going to see one important topic. I'll tell the topic name later, right? So in the previous session we have seen about the push button, right? So suppose imagine instead of this is a switch, imagine this is a push button. Okay, I'll just rename this. Start push button, right? So if it is a start push button, and imagine this is your motor. Now go online. So what will happen? If you press this, it will on. After that, you need to release this button. No, that time it will go off. This situation should not happen. Once you press, it will be on. Even though you release, it will be remaining in a on condition. For that, what we need to do? That is the logic. So in an industry, people will be using push buttons more than the switches. Then how come they are maintaining the output to remain on? So that concept is called as latching concept. So let's see what is this latching concept. So latching, the term latch circuit is a self-maintained circuit in that after being energized, it maintains the state until another input is received. Okay, so it is like a momentary on is catched by the output and it still remains until it unlatch. So unlatch means what? There is some way to unlatch it. That means to turn off that. Imagine you have a start push button for the motor as we have seen in the program. You are starting it by using the latching concept. How we are going to turn off that? In some situation you need to turn off that, right? Even in our home, once the tank is get filled, you need to turn off the motor. That time you will be using the stop push button. No, then that is called as unlatching, right? So I'll just have one animation for you. Let's have a look. See, once I'm going to press, even though if I release, this lamp is in a on condition only. So I'll repeat. Just watch it. You are pressing and it is maintaining. Even though if you release, it is maintaining, right? So but in the previous session, as a momentary push button, if you press it will on, if you release it will go off, as we have seen, no? So I'll show you this. Just have a look. See, if I press, that is on. If I release, it is goes off, right? Yeah. But in latching concept, if I press, it is maintaining. So this is latching, right? So I'll show in a software how to perform this. How to perform this in a software, right? So this is my start push button. So latching means what exactly in ladder logic? Means you need to connect a parallel contact with the input. So this is the one which is going for the momentary on, right? So parallel to this, you need to connect a contact. So like this. So this is latching concept. Okay, you are connecting the contact, but what address you are going to give? And the contact should be normally open contact. So for latching, it should be a normally open contact. It should not be a normally closed contact, right? That is the first point. What is the second point? Means what address you are going to give for this? I'm having one input and one output. Apart from that, I cannot use anything here. So whether you are going to give the input address or output address? The answer is you should give the output address. So I'll tell you why. Whenever you are turning on this momentary on, no? Whenever you are turning this on a first time, it will be on for a second, right? Because of this on, this contact will also on because both are sharing the same address. See, this is also O:0/0. This is also O:0/0, right? So just check error. Go online. Run. Just check now. I'm going to turn on. It is on, right? Because of that, this contact will also on. Only because both are sharing the same address. Imagine this is the momentary on, no? I'm turning off. But still your output is, I think it is copied again. Just a minute. Okay, it's okay, fine. So just check here. Even though your input is off, your output is still in a on condition because of the power flowing through this, right? So I'll go offline. Yeah, I'm turning on. Immediately I'm turning off like a push button, right? But see, your output is still in a on condition because as per my logic, I have created one parallel path to the input which is a momentary on or off, right? So because of that, it is taking a different path to reach the output. So my motor is in a on condition. This is latching. This is the same concept they have done for this animation. See, for this animation, this is the logic behind that. If you turn on, even though if it is released, it is in a on condition. So this is latching, right? And how about unlatching? See, this is to turn on a lamp, and after that you need to have one more input to turn off that. See, I'm turning on, and this is to turn off. This is like the example I have given for the motor concept in our home, right? So there is a way to turn off this motor, right? But in my rung, how you are going to turn off the motor? One thing is you should go for offline. That's it. There is no option. So in that case, you should unlatch it. So whenever you are using the latching, you should use unlatch also. And the unlatch should be another input. That may be your stop push button. PB. That's it. Stop push button. Right? And go for download. This should be normally closed. Why it is normally closed? I think I have given explanation for this. Whenever you want to turn off something, you should use a normally closed contact. Okay. check now. I'm turning on and I'm turning off since it is a momentary on. So motor is on. Once your process is done, once your tank is filled, you can press this button. Why I'm using the second push button means, see, if I use the same thing, it is not having any influence. See, it is not going to give any influence after the latching. So once it is unlatched, you should connect one more input after the latching. You should turn on this, which will unlatch your motor. So this is the same concept behind this animation. Check out this. I'm turning on, it got turned on. If you unlatch, that will be off. That's it. Right? So this is the latching and unlatching concept. And the latching and unlatching is not only for push buttons. You can find application in examples. Just see the example here. This is the conveyor, right? Imagine a metro, you will be keeping a bag for the checking, right? Imagine that case, right? So the thing is, you will be keeping a object here. The conveyor belt will be initially in off condition because if there is no object, it will not run. If the object is placed, because of the sensor, because of this sensor, it will give signal to the motor. So because of the motor, the conveyor belt will be moving. Conveyor belt will be moving because of it is behind the screen is conveyor motor. This is conveyor motor only. Okay. So conveyor motor will be start running once the job-in sensor is giving the signal. What is the function of job-in sensor? It is detecting the object. Object is there, we should move it. Right. So when the object is moving, it will move and it will reach, imagine it will reach this place. Now there is no object below this job-in sensor. Right. That time it will give 0. That 0 will turn off your motor and your object is stuck in between. Can you guess what I'm telling? The sensor is giving the signal once the object was there. When the object is moved, the sensor will be in off condition, which will make your motor to off so that your object will be stuck in between. So in this case also, you can make use of the latching. Right? So for this, how to do the program means, same concept only. Same concept. See, this is your sensor. Right, so I'll show you now without latching. Okay, so because of your sensor, your conveyor motor is moving. Imagine like that. Go for online, go for run. Now turn on, your sensor is giving signal, your motor is running. So whenever your motor is running, conveyor belt is moving, so your object is moved. When your object is moved away from sensor, this fellow will go off. Now see, your motor is off. So motor is off means maybe your object is here. It may be here, right? So it should not happen, right? This is not a good programming. Your object will be stopped, the conveyor belt will be stopped until it reached this place, right? Or someone there to, take the object. So job-in sensor should not give continuous signal also because the object is moved. So in this case, you can do the latching concept. So what is the latching concept? So you can connect a parallel contact with the sensor and the input. And this gonna be your motor. Like this. So now see, even though your sensor is not giving a signal, the motor continue to on. Like this. See, your sensor is giving a signal, your conveyor motor is running. When the box is moved aside, a sensor is giving 0. Your motor is still running. Got it? So here how to turn off the motor? Unlatching. Unlatching maybe here also you may have one more sensor which is detecting the object. By using that sensor you can unlatch it. That may be the job out sensor. Right? So this is the importance of latching and unlatching. And why I have taken this example is, latching is not only meant for start and stop push buttons. It may also apt for sensors like this. Okay, in this case also you can make use of latching concept, right? I hope you have understood the concept. Just practice all the latching, unlatching and the logic gates in your ladder logic program, since I hope you have downloaded it, and just practice the concepts in ladder logic to understand better. I'll meet you in the next session. Bye. Hello everyone. So in this session we are going to see about interlocking. So what is this interlocking? So it is a feature that makes two input or output mechanism or function mutually dependent. It may be two input dependent or output dependent or function. Some function is mutually dependent, right? So used to prevent some undesired states. So used in industry to protect the occurrence of one process while the other process or not is happening, right? So, and there are two types of interlocking. So first I'll give one example for the interlocking. Imagine you are having two motors, right? So you are having separate switches for the motors. If one motor is running, that should not make the another motor to turn on. Okay, one motor is running, another motor should not run. If another motor is running and the first motor should not run. Imagine, this is one example. You can take one more example, like in a quiz program and all. If the host is asking a question, immediately who has known the answer, they will press the buzzer. So their light or sound will be coming, right? Maybe a buzzer or it may be a light, the table light will be coming. So once the first one is press the buzzer, even though the second person or third person who has known the answer, if they press, it will not have any influence. It is like first in response, right? So who has pressed the first, their buzzer only give the sound. So for the second team and the third team, it will not be happening. This is called as interlocking. So how to do this locking? That's what they have given in the first statement. It should be mutually dependent. If one thing is happening, another thing should not happen. If the third team has given the answer first, it should not allow the second team and the first team to press the buzzer. They can press, but sound will not be coming. It is like disabling their output, right? So how to do that is a logic, right? So we have two types of interlocking. By using input contacts, if we are doing interlocking, that is input interlocking. By using outputs, if we are doing, that is output. I'll show you in a software. This is that motor example, right? So you are having one switch for the first motor and another switch is for the second motor. Imagine if the first one is running, this is running, this should not make this to run, right? If the first motor is running, already running, even though if you press, this should not happen, right? So for that, they will be doing interlocking like this. This switch to be here and this switch to be here, like this, right? So this is input interlocking. So what will happen means, just go online and check. See, someone is pressing the first motor, okay? So my first motor is running. Can you see? It is running. But see here, because of this get closed, this get open. So what will happen? This motor should not run because the coil is open. So just check out here. If someone is pressing the motor 2 first, see, that is make the S2 normally closed contact in the first rung will go open, right? So this is input interlocking. If you are using the input contacts to lock, that is input interlocking, or else by using output you can do the second motor address in the first rung and the first motor address in the second rung. So if you are using output to lock this is output interlocking, but the function should be same. Both are going to do the same function, but address are same. See, I'm turning on this one. This one is getting open because this is on. Or else if someone is pressing this first, this will get open. So this is output interlocking, right? So you can have some more examples like automatic door opening, right? In an automatic door opening, the object detecting sensor is giving the signal. What is the mean of object detecting sensor? The people are nearby, just keep the door open, like that. So if the object detecting sensor is giving the signal, the motor should be in a off state. That means it should not close. Even though it started closing, it should open, right? So object detecting sensor is like dependent to the closing motor, right? So this is the use of interlocking. You can find the applications depends upon the requirement. I'll meet you in the next session with another interesting topic. Thank you. Hello everyone. So in this session we are going to see about the memory concept. So memory concept are one of the important logic in programming. So let's see what is this memory. So it is a bitwise memory or register used to hold or store the status of IOs. We cannot allow to use it physically, but you can use that address logically, right? So when you are in need of some extra switches, you can make use of these memories. That means we are using in a program. It is not that we need to connect it physically, right? It is not a physical devices. It's like a memories which is available in PLC programming. So it should be a digital and also it will be the analog also, right? So digital means it will be the 0 or 1 stored in bit memory location, and analog value stored in integers, real, word or double word. So I'll tell you one example for this. So where inputs are having multiple states. So just go through the tabular column now. Here we are having one switch and one lamp. So initially I'm going to turn on the switch. That means you can find a 1. You can find a 1 here. That time your lamp is also 1, right? Whenever your switch is off, your lamp is still in on condition. Got it? And when your switch is again on, the lamp is going off, right? So just have a look again. Whenever you are turning on a switch for the first time, your lamp is on. If you turn off, the lamp is still on. I think up to this condition we can do with the help of latching. In the previous sessions we have seen about the latching, right? Even though the input condition is goes off, output remains on. So up to this second one we can do. How about the third one? When the switch is again on, lamp is need to off. So that I need to use the switch in normally closed contact to turn off the lamp. But I can use only one switch. No, I cannot give another switch externally to turn off the lamp. So I'm in need of some extra switches. See, the inputs are having multiple states here, right? The input was 1 and it was 0 again. Again it was 1. So for all the for this condition I can turn on the switch, I can turn off the switch. This is fine. Again I'm going to turn on means how this turning on will going to influence my lamp to go off. That is a question here. So I cannot do this without a support of any external contact. So what is that external support? And that support is nothing but memories, right? So I'll show you how to do this in a software. See, let's take one switch and one lamp, right? So let's name this as I:0/0 S1 and this is gonna be O:0/0, right? This is fine. So whenever you are turning on, this is on. Whenever you are turning off, this should remain on. So what you can do, generally, if without memory think about it, what you will do? You will be latching it, right? You will be latching this with the output contact, right? Then again we are going to turn off this. How we are going to do that? right? Now this M1 should go off whenever I'm going to turn on S1. So it is okay to use like this. If you use like this, what will happen? This is not a correct case, right? So just go for online and check how it is working. Because without memory, I'm just telling. I told that it is not possible, no? So I'm giving justification to that, right? See, I'm turning on. Because of this NC contact, initial step itself is not happening. Which is the initial step? This one, 1. This is itself is not happening, right? So this is not possible without a memory. So what we can do means, so what we can do means, you can make use of the memories to store the conditions, right? I'll show you how to do that. So now instead of this output, I'm going to use the memory address B3:0/0. This is my memory, right? So let's take this as M0. This is my first memory and I'm going to latch it. B3:0/0. I'm latching it, right? So what is the second step? My input is going off, right? See, initial step I have stored. See, whenever your switch is on, I'm storing that in one memory. What is the second case? My switch is going off. I'm storing that in another memory. So another memory means my switch is going off. Then it should be like this, no? So use another memory. So I'm going to use one different memory. And that is next memory. I'm naming this as M1. Second memory. And here also latching is needed. Just make a latch. Just add normally open contact and put this memory over here, right? So here, this is the first step. This is the first step and this is the second step. So second step should start once the first step should get over, right? So how we are getting the reference means, you can connect this memory here so that you can tell this is the second step. If you are not connecting M0 here, it looks like it is also a first step, right? There should be some order, there should be some sequence. That's what I am taking reference from the first step end. So what is the third one? Again my switch is on. So I am getting reference from the second step for the third step. This is the third one. I am taking the reference. And here this is my switch is going to turn on. That time I am going to turn on another memory. Name it as M2 and this is the third memory. Okay. So I am having 3 steps. I have stored all the 3 steps in one memory. Right. So here also you do the latching. But the thing is, for the last step there is no need to go for latching. But still, since we have followed this procedure, let's go for latching. Now, in the last rung, you can connect your output actually. I'll just connect our output O:0/0 and we'll name this as output, right? Yeah. So, what is this output? What we need to connect directly? When the output is going on for the first time, when this memory is coming, right? So just connect M0. So when M0 is on, output will be on, right? When it is going off, when M2 is on, this will be going off. So this is the use of memory. So by using this memories only, we can able to do the logic. Now I'll go for online, I'll show you. Just run. Now see, I'm turning on the switch for the first time. My output is on because my output is connected with this M0, right? Now I'm going to turn off. This is a switch, okay? I'm going to turn off. My output is still in the on condition. Now I think you get to know what is the use of latching. Because of this latching only, this output remains on. Now I'm going to turn on for the second time. My output is off because M2 will make the contact to get open. So this is the use of memories. So memories are used to reduce the space also. How means? Like start push button and stop push buttons are there in a project. Okay, so what is the use of start push button? That button you need to include in all the rungs of your project so that it will on, then only all your process should on. This is for start. And same for stop push button also. Stop push button is like whenever you are pressing that, immediately all the process should go off. So these two buttons you need to include in all the rungs, right? So if you are using two contacts in all the rungs, it will take more space. Instead of that, you can save this in one memory, and that memory, if you are using as a single contact in all the rungs, it will be reducing the space, right? So for that also you can make use of memory. So whenever you want to save some condition in one place, you can make use of the memories like I have done. So what I have done, I have saved this condition in one memory, and this is in another memory, and this is in another memory, and in the last rung I have put together all the memories to perform the output when it is turned on for the first time for this memory. And for this memory also it is in a on condition only. That's what I didn't include this M1. You may ask me why I didn't include M1 here. You can include, but that should be in a parallel. Okay, because this is not having any influence. But this is the second step. Second step is needed for the third step starting. That is a thing, right? So we can make use of memory contacts whenever we are in need, right? So that's it about the memory concepts. I will meet you in the next session with another topic. Thank you. Hello everyone. So in this session we are going to see about timers. So what is timer? So timer is used to create a time delay between the operation or activate and deactivate a device after a preset interval of time. You can set the time for some particular operation. Let's take an example of a washing machine where we can give the spin option, right? So for that spin operation, we can set a time like 7 minutes, 10 minutes, like that we can set. That is for the complete operation. And what is this activate and deactivate? Like after some time, this need to on or this need to off. Like that also we can create a time, like how we are keeping an alarm in our mobile. After some time, it will be giving some alarm, right? So that is also like activating the alarm. After some time delay, it is activating the alarm or deactivating some process. So this is the use of timer. This is actually the timer. So what is the time delay means? We can call this as preset, right? So this is a preset. Preset is like how I have mentioned for the spin operation, there is a 7 minutes. So that 7 minutes is the preset interval. So how long you want to create a time delay? That is a preset value, right? And we are having three types of timers. One is on delay timer, another one is off delay timer, the third one is retentive timer. So before getting into the timers, you need to know some timer parameters. Specification. Let's see what is that. The first one is timer number. So timer number is nothing but a timer address. So all the timers, maybe we may in need of some 3 to 4 timers in our project, means how we are going to differentiate the timers by using the timer number. You can start the timer number from 0 and up to 256. 256 timers you can make use of. In a project you can maximum you can use 256 timers. That is will be starting from like T4:0 to T4:255 in Allen Bradley, right? So the next one is preset value. As we have discussed already, what is this preset value, right? How long you want to create a time delay, that is preset value. And we are having an accumulator value. So accumulator value is like the running value, right? So take the example washing machine. You have turned on the spin operation. So it is started with a 0 minute, right? 0, 1, 2, 3, like that. It is increasing at, or it may be decreasing also, 7, 6, like that. Count down also it will happen, or count up also it will happen, right? So that counting value or the running value is stored in the accumulator, right? And the fourth one is a time base. So how we are going to start counting, like whether it is in a seconds or whether it is in a millisecond. So it depends. So timer, Allen Bradley is having a time based option. So time based is related to the resolution of the timer, right? And the last one is enable bit, done bit, and timer timing bit. So these three bits are available in Allen Bradley. So enable bit is like whenever your run condition goes on, your enable bit will also be on. Okay. So done bit is like whenever your done function is done. Your function is done, that time this bit will be on. Right. For example, the spin operation is completely done. After 7 minutes, done bit will be on. And enable bit will be on for the 0th minute until your run condition, until you turn off your main supply. Enable bit will be in the on condition only. And what is this timer timing bit? It is like it will start at the first second till the 7th minute. So it is like a running, no? The running seconds are displayed by using the timer timing bit. If the timer timing bit is on, we can get to know the timer is running, right? So that we can get to know from timer timing bit. So that's it about this session. In the next session, we'll see how to use the on delay timer and what is a practical example we can relate with the on delay timer and how to use that in a software. Yeah, I'll meet you in the next session with another timer topic, right? Thank you. Hello everyone. So in this session we are going to see about on delay timer. What is this on delay timer? The name itself is telling it is delaying the on condition. Just have a look into this statement. So when the run condition becomes true, the timer will be start running. So usually we will be connecting the output after to the timer. That means whenever the timer output is on, that time only your output will be on. Timer output is nothing but it is having more outputs. We have seen in the previous session timer specification like done bit, enable bit and all. So done bit is the exact output of the timer. So after some time, that means maybe the proper interval or we can call that as preset. After the preset time, the timer's done bit will be on and by using that we are turning on a output. Let's take an example. In our home, if we turn on a switch, automatically fan will be on immediately, right? So if you want to have some delay in turning on of fan, so you are turning on a switch, it will take some time to turn on a fan and that time duration is, if you want to give, then you can use on delay timer. It is delaying the on condition. So you can find example of air conditioner. So in air conditioner, you will be turning on the main switch. So it will not immediately on. You cannot able to use the remote immediately, right? After some time, it will give some beep sound. Then you can reduce the temperature, increase the temperature. You can do, right? So in that particular duration, it is delaying the on condition. That is a perfect example for on delay timer air conditioner, right? So we'll see how to do this in a software. So just have a look into this. I'm having one input. Let's take timer here. Can you see TON? Yeah. So let's take this TON, keep it over here. So timer address we have seen, no? This is the timer number. So you need to give T4:0. This is the timer number. And the next one is the time base. Fine. And this preset should be 10 or maybe whatever according to your application you can give. Let it be 10. And that's it. And what is our timer output? You can take timer's done bit first. So timer is having actually 3 outputs, 3 bit it is having. Enable bit, done bit, and another one is timer timing bit. If you want to have a look, you can check out this. Enable bit, timer timing bit, and this is done bit. Fine. So let's take timer done bit first. So how to give a done bit? So first you need to give the timer number T4:0/DN. So if you want to take enable bit, you can go for EN, right? So this is the timer's done bit. So if you are not able to, remember that, means you can get help from the data file. In the data file, just look out here, just click on this DN. Here it will give the address T4:0/DN, right? Fine. So I have given T4:0/DN. Already description is there as done bit. Fine. So let's go for one output. Just give any output. So let it be as pump. Right. So this is the input to the pump. Whenever you are turning on this, after 10 seconds, this pump will be on. Let's check out. Go for run. Yeah. So just turn on. Whenever we are turning on this, the timer accumulator value will be started running. Just have a look. Yeah. Can you see? It is started running and enable bit is on. Enable bit is nothing but it's like a run condition. Okay. Yeah. So after 10 seconds, this done bit is on. That means timer has done its work like that. So when the timer bit is connected to the second rung with the output, it is turning on. Fine. If you want to start from beginning, you just turn off this. Yeah. All the bits are reset and even accumulator value is back to 0. Fine. Right. So this is fine. We are delaying the on condition. What if this input condition goes false in between? Let's see what will happen. Just turn on it. It is started running. Suppose if it is turned off immediately, after some time or immediately, can you see? Run condition making enable bit to off, even accumulator value is back to 0. That means what? On delay timer requiring the input condition to be on continuously. If the input condition goes false, on delay timer will not work. This is the conclusion. Fine. So input pulse is much needed. Then only it will be turning on the output after some time. Okay. And even accumulator value is back to 0. That means what? It automatically getting reset. Yeah. Right. So let's see about this enable bit and done bit in a separate rung. So just take 2 more rungs. Take one input, one output, and same here. Right. So here what we need to give, like enable bit will give EN, and this gonna be the timer timing bit TT, right? So let's give some output for this O:0/1, that is pump to O:0/2 fan. Fine. So let's check for error. Now enable bit means what? It's a run condition. That's fine. If the run condition goes false, enable bit will go off. What is timer timing bit? Timer timing bit is like whenever the accumulated value is running, it will be turned on. Fine. So done bit is after 10 seconds it will be on. So let's check out. So I'm turning on. Now enable bit and timer timing bit is immediately on once the run condition goes true. Because accumulator value is running. Can you see? It is running, no? Once it is stopped, can you see? Our timer timing bit is off. Fine. Done bit is on now because it has done its work. Right? So this is on delay timer. Fine. And you can make use of this timer preset value or timer accumulator value for some other purpose. In the next upcoming sessions and all, we will be seeing the comparators and counters and all. So in comparators or some arithmetic operation and all, if you want to compare your timer accumulator value to some other number means you can make use of the accumulator address. So like how we have taken done bit, enable bit address, no, like that you can take timer's preset value address and timer's accumulator value address. If it requires, if your application requires your accumulator value to compare with something, you can make use of this address. Fine? Yes. So this is about on delay timer, and there is no special reset needed required for this because input condition should be there for its operation. If the input condition goes false in between, automatically your accumulator value is going reset. I mean it is going back to 0. You can start from first, right? So just practice this on delay timer in the software, and you will be having some exercise problem also. So just practice all the exercise related to on delay timer. Fine. So I'll meet you in the next session with off delay timer. Hello everyone. So in this session we are going to see about off delay timer. So just go here and you can check for TOF. So let's see what is this off delay timer now. So on delay timer is like delaying the on condition, right? So what will be the off delay? It will be delaying the off condition, right? So while turning on delay, it will not create any delay. Okay, you should be very clear about this. Fine. So off delay timer is not having any business with turning on delay and all. It will be turned on normally, but when it goes to off condition, it will take some time to turn off. Okay, so you can read out this, and the perfect example for such timer is sleep option in TV or induction stove. Fine. So in an induction stove, you can set some time. So if you set some time, after that particular interval, the induction stove will turn off automatically. It is off delay timer, right? So you are setting a time to turn off that particular output. And even sleep option in TV also you can. Sometimes you feel sleepy in the night, you'll be you can set this sleep option in TV. That may be some options like 20 minutes, 40 minutes or 1 hour or 1.5 hour, like that. It is having some options. After the 20 minutes or particular duration, automatically TV will be off even though you are not turning off your stove, right? So that's it about this off delay timer. So let's see how to do this in a software. Yeah. So TOF is a off delay timer. So this is a shortcut TOF. So I'm just going to change the name here, TOF. Fine. So it's gonna be the same timer number. Here it is changed, timer off delay. So let's see what it is going to do. Check for errors. Go for download. Run. So now check. I'm turning on. Immediately pump is on. Fine. Can you see timers enable bit and done bit both are on? Fine. This is common because whenever you are turning on something, it will not create any delay. Fine. Now the actual function is if you turn off, can you see enable bit is off, done bit is still on, your accumulator started running. So this particular timer will be started functioning once your input condition goes off. It will started counting and it reached 10. After that it is making your pump to turn off because done bit is going off. Fine. So I'll repeat it. Yeah. So whenever you are turning on, both the bits are on. Because of done bit is on, your output is on. Fine. Timer instructions are output instructions. You cannot connect output here. You should take your done bit in a separate rung and you need to connect. Fine. So now if you turn off, the timer started running. Fine. After 10 seconds, your pump will go off because done bit is off. That's it. Got it? Fine. And as like in on delay, this accumulator value will automatically reset. Fine. There is no special reset for this. Can you see? If I turn on again, can you see? Accumulator value is automatically getting reset. Fine. So this is off delay timer. So here also we can see enable bit and timer timing bit. So let's see that. I'll just change the name here. Yeah. So here we are having enable bit, timer timing bit. So let's work this. Fine. Just turn on. Enable bit, done bit. Both are in a on condition. Fine. So enable bit is here also it is a run condition. If you turn off your run condition, automatically enable bit will be off. Turn off. Enable bit is off. Timer timing is running because accumulator value is running. After some time, everything is going off. When you turn it on again, automatically accumulator value back to 0. Just check it out. Can you see this one? Yeah, that's it. So this is off delay timer, delaying the off condition. Fine. So just practice this in the software. I'll meet you in the next session with RTO, which is retentive timer on delay. Got it? Yeah. Thank you. Hello everyone. In this session we are going to see about retentive on delay timer. So the name itself is having some on delay timer, right? So this RTO somehow works as on delay timer. Okay. So you can find the function of on delay timer here also, but what is the difference? There is a word called retentive. Retentive means what? It is holding something. Got it? So let's see what it is holding. So you can read here that on delay timer operates such that when run condition contains the timer is true. So when the run condition is true, the timer will be started running. After the particular duration, it will turn on the output. It is said to have like same like on delay timer, no? But even though input pulse goes off in between, timer retains to hold the accumulator value. So this is making the difference with on delay timer. So in the on delay timer, if we turn on the input condition, automatically your timer is going off, correct? But here, that accumulator value will go to 0. But in retentive timer, accumulator value will not go to 0. It will be retain its value. So whenever the input condition comes again, it will start counting from the place where it has left, right? So we'll see it in the software. Yeah, so you can see RTO here. So I'm going to change the name here as RTO. Fine. So just make the preset value to 20. Just go for download. Go for run. Right? So let's see what exactly it is working as on delay. Let's see that first. After that, we'll see the retentive part. Yeah. So it's not turning on your output immediately, right? So timer is started running. After this 20 seconds, automatically your pump will be on. Just have a look. Right? So this is exactly as on delay. Got it? Now, suppose if you turn off, on delay will make your accumulator value to 0, right? Now see, I'm turning off the input condition, but still accumulator value is not getting back to 0 and even your output is also not going to off because done bit is still on, right? So this is making the difference. First one, the point I have told is first one. Still we are having, I'll show you that also. So just go online again. Now start it. Now immediately after some time or stop it. Can you see? Accumulated value is still here. Fine. If you turn it on again, it start counting from that 6. Got it? It's not starting from beginning. So this is the second point. This is the second difference. Okay. I'll do it again. Can you see? It stopped at 15. Right? It stopped at 15. When you turn on it, it will start counting from 15. Correct? Yeah. So this is the point number 2. Now if you turn off, it is not going. Then how to get this timer to start working from first? How to reset it? Because reset is not happening, no? Right? So this makes difference with on delay and off delay. So in on delay and off delay, there is no particular reset, right? Whenever the input condition goes off, it will automatically reset. But in retentive timer, you should have a reset coil separately. Fine. So this is the third point. First point is, at last it will not reset. Second point is, even though in between your input pulse goes off, you need to turn on again your input condition so that it will continue from the place where it has left. Third point is, reset coil is must. Because if you are not reset, in this program you are not having reset. So what I need to do, I need to go for offline. Then again I need to come back so that accumulator value will be starting from 0 again. That is one point of reset, but that is not advisable, right? In a program itself, I should have that reset facility, right? So just go offline. Take one more run. Take one input and you can find reset coil here. RES, that is reset coil. Fine. So just give one input for reset. I'll just type that as reset. And this reset coil address should be your timer address, because that is the one we are going to reset, no? Like that. Got it? Check for errors. Go for download. Right? Turn on it. Let's see this. After some time, after this 5 seconds, it is started counting. After 20, pump is on. Now you just turn off this. Now reset. It will going back to 0. Got it? Because of that, your done bit is also off. Fine. Now turn off this. Again you can start from beginning. Right? So this is the way to reset the timer and start from the beginning. Correct? Even though if you off in between, you can reset again. This is also way. Reset is always used to start from beginning. Fine. That's it. Got it? So this is retentive on delay timer. You can work with enable bit also. Enable bit is a run condition, and timer timing bit is whenever the accumulator value is running, that time only that bit will be on. Fine. So just work with this timer in the software. I'll meet you in the next session with another topic called counters. We'll see counters in the next session. Right? So bye. Hello everyone. In this session we are going to see about counters. So what is counter? It is used to count up or down or both any function until it reaches the limit. Right? So imagine in a conveyor some boxes or some products are moving. You want to count how many products are over there. right? So you can put a sensor over there which will be giving one pulse whenever the product is crossing across it, right? That pulse we are giving to the counter, and automatically PLC program will be started counting whenever the product is crossing. Like that we can make use of these counters. And it also used to count from 0 to the limit and the limit to 0, both are there. The perfect example for this kind of counter is car parking, right? So you can keep one sensor in the entry location and you can keep another sensor in the exit part, right? In the entry one sensor and the exit another sensor. So in the entry it will be count up from, it's from 0 to the limit. Maybe your car parking limit is 5 or 10. So that 5 or 10 will be the limit. So it will be started counting from 0, 1, 2, like that it will be started counting, right? So when it reached the limit, it will be giving some indication like count is done or parking is full. Like that we can give the indications also, right? And the same thing in the exit side also, one sensor will be there which will be giving one pulse whenever the car is exiting. That time it will be count down from 10. Already 10 car is inside, okay? So one car is going out means it will be reduced to 9, 8, 7, like that. For each and every car exiting, it will start decreasing. That is count down, right? So this is the perfect example to understand the working of counters. So as you have seen, there are three types of counters: up counter, down counter and up down counters. So usually in some PLCs you can find all the three counters, but in Allen Bradley there is only up and down counters only. Okay, only two counters are there. There is no up down instruction specially for that, but we can build this up down counter instruction by combining these two. By combining these two we can get up down counter, right? So before getting into the software, let's see some specification of counters. So we have counter number, as we have seen for timers. Counter also having numbers. And the second one is preset value. What is the preset value? It is a limit, right? We have told 10 or 5 car, which is the parking limit is 5 or 10 maybe. Let's take it as 10. If 10 is the limit, means that is my preset value. And accumulator value is like number of cars currently inside the parking slot, right? So these three are the specification we have in counter. So let's see how to do this in a software. So this is the pulse, okay? So this is the pulse which is going to give input to the counter. So let's take that conveyor example, right? So conveyor is there. Whenever a product is moving, it will be giving a pulse, right? So this is the sensor which is going to give pulse to the counter. You can find the counter here. This is timer bar counter. You can find CTU. The CTU is the counter. Click on that. When you click on CTU, the block will be like this, right? And in the counter, you can give the name like C5:0, right? C5:0. Because counter address is C5:0. We have seen the counter number now. So in the data files, just click on the counter and you can see here C5:0, right? So this is counter. Once you have given the counter number, you can give the preset value. So for time being, I'm just giving 3, right? So 3. I mean, only 3 products can cross. Once the 3 product crossed, it gives some lamp indication to us. That's what I have taken the output as lamp, right? So you are going to count 3 products. For every 3 products, it should give a lamp indication. So what bit I can take here is counter's done bit. So as like timer, counter is also having some bits. This is counter enable bit. Whenever the counter is on, this CU will be on. And this done bit will be on once accumulator value reached the preset value, right? So let's take counter's done bit. So what is the address for that? Means C5:0. This is the counter number /DN, right? So DN is for done bit. Fine. So check for errors. Go for online. Fine. So now one product is crossing. So this is giving pulse. Fine. So see, one accumulator value is 1 and CU is enabled. Now after the product got crossed, it will be off. Now see the CU. CU is off. Right. Now turn on again. Again CU is on, accumulator value is 2. Now the third product is going to cross. Okay. The third product is crossing. So can you see? Now the third product is crossed. So done bit is on because accumulator value reached the preset value, and because of the done bit our lamp is also on. Got it? So this is counters done bit. By using counters done bit we can able to turn on the lamp. It is like counters done bit is like the process is done or the counting is done. However, preset value we have set no. So accumulator has reached that value. So my work is done, like that. Counters done bit is giving. Fine. So how to see, if I turn on again, what will happen? See. Can you see accumulator value is still increasing? Can you see? It will be increasing. So it will not stop up to 3. Accumulator value will be increasing if you are giving pulse. But done bit will be on at exactly 3. Okay. So what is the accumulator limit means? It will go up to 32767 and it will roll back to minus 32768. Because the counter limit is minus 32768 to plus 32767. So accumulator, even though you are giving pulses, it will be started counting. It will keep on increases up to 32768, 32767. After that also you are giving pulse, it will roll back to minus 32768. Again it will start increasing from that place. I'll show you that. Now see, imagine the counter is reached 32765, or I'll just give 7 now, 6. Okay. Now find, I just want to show you the rollback. So now the done bit will be on. See, the done bit is already on because our accumulator once reached 3, right? So that time itself it was on. Now see, I'm increasing the pulse. It is increased to 32767. Now see, if I give the another pulse, yeah, it rolled back to minus 32768. So this is counters rollback. See, if I give another pulse, it will be started increasing from this place. So whenever the rollback is happening, you can find the counters overflow bit is on. This is counter overflow, OV. So this bit is on. Can you see? 1 is there. So this is counter overflow. Right? So until reset, it will be happening like this only. If you are not resetting the counter and giving the pulse, it will be increasing because it is up counter. If it is a down counter, it will be decreasing. I will teach you when we are seeing the down counter, right? So obviously, reset is the main thing. If you are not doing the reset until you are giving pulses, it will be counting only. So reset, how to do that? You can get one separate input for doing the reset. I am taking the reset coil. So let's give I:0/1. I'm going to give this as reset. And this one should be our counter address, right? C5:0. Same we have done for return to timer, no? Like that. So go for download. Go for run. Right? So now see, we have not done the reset before. So it will be maintaining the same value. So once you press the reset, counter accumulator value turns to 0. Now you can start from beginning to, it's like a fresh start. You can start from beginning. See, 1. In between, if you want to do the reset, you can. So reset is mandatory one for counters, right? I'll meet you in the next session with down counter. Until then, bye. Hello everyone. In this session, we are going to see about down counter. So in the previous session, we have seen about this up counter, right? So what will be the down counter? Let's see that. So for down counter, you can see the instruction here, CTD, right? So you can click this and you can get this counter, or you can just type the name CTD. So like timers, counters are also output instruction. That means you cannot connect anything after this counter. Fine. So let's see what down counter will be doing. So here reset matters. Reset coil matters because without using reset coil, you cannot able to make the accumulated value back to 0. Fine. So I'm going for download option. Let's go for run. Yeah. So once done is happen, run is happen, go for toggle bit. Can you see when I give the pulse, it was 0, accumulated value was 0, minus 1 is now, right? Because it is count down. Can you get the point? This is count down. If you do it again, see, if you do it again, what it will happen? Again it will be minus 2, right? So from 0 it is started decreasing. So you cannot use the down counter like this. One thing is you can make accumulated value of the down counter to 3 initially. Like that it is possible. I'll show you how to do that. Just go for the reset button and turn off this. Turn off this also. Go for offline. In this case, just make accumulated value to 3 first. If you are using down counter separately, just make the accumulated value to the preset. Now go for download. Go for online. Run. Now just run. Can you see done bit is on now? Counters done bit is on. Because accumulated value is equal to preset value. So it is the same function for down counter as we have seen in the done bit is common for both up counter and down counter, right? Now if you give the pulse, down counters done bit is gone because both are not equal. It started decreasing. So 3 to 2 like that. Now see, if I give the pulse again, it will be 1. If I give again, it will be 0. Then it will be minus. It will be decreasing until you are giving the pulses. So how long it will go? As we have seen in the previous session, what is the limit for the counter? It is minus 3 to 768, right? So just see. Suppose if the value is minus 3 to 767, let it be like this, right? So just go online and check. Yeah. Just go download, run option. I have given 3 to 567, right? I'll just try to change 3 to 767. Now just give the pulse. Can you see? It is reduced to minus 3 to 768. In this stage, just check the counters data file. So this is overflow bit we have seen for up counter, right? And this one is underflow bit. So this is 0 now, right? Just watch this bit. This is 0 now. Now if I give the next pulse, let's see what will happen. It is rolling back to plus 3 to 767. Can you see? This bit is on. Right? So this is counters roll back. So if it is a down counter, once it reached the minus limit, it will roll back to the plus limit. See, if you are giving again, it will be reduced to 32766. Then it will be reducing to 0, then it will reduce up to minus 32768. Again it will roll back until you press the reset, right? So once this rollback is happened, this underflow bit will be on only. See, once I have pressed the reset, it is also 0, right? Then you can start again from the beginning, right? So this is the way to use the down counter and how to make use of this down counter in a function. For example, take that car parking example, right? How we are going to use this? Let's see that. So just take a rung, okay? I'm just taking a rung. I'll take up counter. So this is the entry side, okay? So I colon 0/2. I'm just giving this as entry sensor. Fine, this is the entry sensor, and this gonna be the exit sensor. So the entry sensor will be detecting how many cars are getting inside the parking slot, and this exit sensor will be giving how many cars are exiting the parking slot, right? And since you are going to use the counter for the same project, you should use same counter address. This is matters. If you are giving some different counter name for different, maybe it is we have already used C5:0. Here you are using C5:1 means then you cannot make use of it, right? So both should be sharing the same address. And this one no. So let's take this as if the car in a parking we can able to park only 5 cars. Let's imagine like that. I'm going to give the preset value as 5. So once if you give, it will also update because both are same, right? But this is count up, this is count down, right? So once 5 cars are entered into the parking slot, I just want to give the indication like parking is full, right? Got it? I have given like this, and I'll take one more rung, and I'm giving the same counter address here, and I'm giving one output, separate output. Parking is free. I have 2 indication, okay? One is parking is full, another one is parking is free. So let's go for online. Now see, accumulator value, no? Accumulator value is 0 or below 5 means parking is free, correct? Accumulator value is the one which is telling how many cars are inside the parking slot. Just check out now. 1 car is entering, okay? 1 car is entering. So now 1. Still parking is free only, right? Because 4 more cars we can park, right? Then second car is entering, right? So 2 cars are inside. Suddenly a man who already parked a car, he is exiting. So exit sensor is on. Now see, the accumulated value is 1 in both the places. That means what? Only 1 car is inside, right? So let's give a shot for all the 5 cars. So third car is entering, fourth car is entering, and fifth car is entering. Just watch out this. When the fifth car is entered, parking is full indication came. Parking is not free now because all the 5 cars are occupied in the parking garage, right? So now parking is completely full. Can you see? Accumulated value is equal to preset value. Now suppose if 1 car is exiting, just watch, parking is full is disabled and parking is free is open because 1 car we have a space. Again if you are turning on this, parking is full again. It's full, right? So like this, by combining both the counters as a separate instructions, you can make the third counter which is up down counter. Fine. So for this you should have two sensors. One is for counter up, another one is for counter down, right? So when this is counting from 0 to 5 and this will be from 5 to 0, right? So this is a way to use the up down counter. Once you reset, to reset means you should have, turn off both. Just turn off both the inputs. Just reset. Now accumulator value is back to 0. Again your parking is free now, right? So this is the logic I have used. I have used the normally closed contact of C5:0 done bit. So done bit means what? It should not be equal to preset, right? If I used a normally closed contact, it's like it's not equal to preset. That's what I have used the output called parking is free, right? So just practice this in your software and I'll give few more example in the exercise portion, right? So I'll meet you in the next session with bit instructions. I'll see you. Bye. Hello everyone. In this session we are going to see about bit instructions. So you can find in the bit option, in the bit menu, you have seen this one shot rising and one shot falling. So let's see what is the function of these instructions. So let's start study about this one shot first. So what I'm going to do means just delete this in a rung. I'm just going to take this. So see, if you have taken the one shot instruction, it is coming over here. So this one shot is not an output instruction, right? So this is not a output instruction. So you can connect one output after this, right? So I'm connecting one more output here. I'm just giving the description as lamp. Fine. So what is this one shot? What exactly it will do? I'll tell you. So for that I'm going to have one more rung. Let's put this. Put this here. Just take one input. Just give any name. Right. And let's take one more output here. Lamp 2. So one shot is asking a question mark. So just give a memory address like B3:0/0, right? Just give on memory address and the description is already there. It is as M0, right? So for this one shot, I'm going to have one input. So let's take one more different input, right? So that's fine. So why I have taken two rungs is to explain you what is the difference between this rung and this rung. See, this input is directly connected with the lamp, but the second input is connected with one shot to the lamp, right? There is one shot in between input and output. So what exactly the name one shot? What exactly it is going to do means, instead of giving the continuous pulse, it is going to give just single pulse. Right? What is a single pulse mean? Just only once it will give. So I'll go online and I'll show you. Just watch here. So if I turn on, this is continuously on, right? This is normal. Whenever you are turning on an input, this output is continuously on because this is continuously giving pulses to this, right? But check out this input. Can you able to see the turn on of lamp 2 was on for the second? So just check out now again. Yeah, you have seen now. Yes. So it is because of this one shot instruction, the input you are giving through this, right? So it is exactly giving only one shot to the lamp, right? So just check it again. See, only once it happened, right? So this is one shot instruction. Instead of giving continuous pulses, it will be just giving only one shot, right? So you can find application of such instructions in laser cutting. Okay, you are cutting some hard component, okay, or maybe it may be anything. All right. So instead of giving continuous pulses, if you are giving single pulses, it will not make a deep cutting and all. It should be exactly how you required, right? So like that, it is giving only one pulse. So you can also check how it is giving pulses by using a counter also. So I'll just take a counter, and for counter this one shot is the input. Fine, just see, I'm just giving counter address and I'm giving 3 as a preset. Fine, I'm giving 3 as a preset. Just go online and check. Just check, the counter accumulated value will be increasing. See, I'm giving the first one. See, accumulated value is increased because it got one pulse. No, counter is not that whether it is continuous pulse is not needed for the counter. Counter need just one count, means just one pulse happened. That's what it counted one. Can you see? It counted one. See, if I turn on and I'll give again, it count 2. That's it. Even I think you can find this fellow is also turning on, because run condition goes on for that 1 second. No, see, yeah, it is 3. So done bit is on. So like that you can use one shot in between the instructions. So obviously, since it is not output instruction, you should connect the output after this. That may be a coil, or that may be a counter or timer, anything, right? Fine. So this is one shot. So what may be this one shot rising? So the name itself is telling, no, one shot rising is like whenever the input is turning on from 0 to 1, whenever it's going to change from 0 to 1, it is rising, right? So that's what it is, rising edge. So whenever the input is changing from 0 to 1, that time it will give one pulse, right? So this one, no, this one shot rising, right? That is the output instruction. See, if I take, it will go this side. And moreover, the block is asking 2 question mark. One is storage bit, another one is output bit. For both, I am going to give the memory address. So I'll give B3:0/1 also, right? So I'm giving 2 address here, one for storage, another one is for output bit. So this bit, no, this output bit I'm going to give input as a timer, counter. So for counter, I'm giving one shot rising's output bit, right? So just check, whenever it is going on, it will give pulse. It is somehow exactly equal to one shot. See, I'm going to turn on this, it will give one pulse. Can you see? If I turn off, nothing will happen. If you again turn on, because now it is 0, it is going to change to 1. Yeah, okay, it gave 2. Now again see, that's it, 3, right? So this is one shot rising. So 0 to 1, it is rising, no, the slope is like rising, right? That's what it is, one shot rising. If the same input is, let's take a branch, right? Let's take a branch and take one shot falling, the next instruction. This is also output instruction. Just give here. So give some other memory address, B3:0/3, 2 and B3:0/3. I'll give this, and let's take one new input with countdown. Let's take a countdown, okay? So I'm going to give the output bit of one shot falling, 3. So what it will do, this instruction will do, it will give pulse when it's changing from 1 to 0. The curve is coming down, right? That slope is coming down from 1 to 0. That's what it is called as falling edge.
Yeah, I have taken the down counter and I'm giving the same counter number and I'll give 3 here, right? Fine, got it? Let's go online. So for understanding, I have taken the counter up and counter down. You can use anything as per your project requirement, right? See, this fellow, no, this fellow is connected with one shot rising and a one shot falling. So one shot rising is connected with counter up and one shot falling's output bit is connected with down counter, right? So I'm going to turn on from 0 to 1. So this fellow will give pulse. So it will change to 1. See, can you see? It is changed to 1. Now I'm going to turn off this like 1 to 0. So now this will be giving pulse which will make the accumulator value back to 0. Just check. Yeah, that's it. Right. So this is giving pulse from 1 to 0. This will be 0 to 1. Just check again. Now we cannot increase the counter value more than 1. It will be 1 only because I am using both the counters, right? So this is the bit instruction. This is one shot rising, one shot falling, and we have seen the one shot instructions also. These 3 are the bit instructions. Fine. So I'll meet you in the next session with latching and unlatching coil. Until then, bye. Hello everyone. So in this session we are going to see about latching and unlatching coil. So in a bit instruction menu you can see latching, unlatching. So what exactly latching and unlatching will do? I mean the coil. We have seen in our previous session about latching and unlatching, right? So the same function only it is going to do, but it is a separate instruction in Allen Bradley, right? So latching, what we have done, to maintain the output to remain on even though the input condition goes off, we will be connecting the parallel contact, right? So just see, I'm going to do the same thing now to make you understand what is latching. So just take like this. So this is gonna be your output address, right? The same output will be here. And this is your input. Just give the input instruction name as start PB, push button, right? So this is what we have done in the latching, right? Now instead of using a parallel contact like this, they have given a coil itself, that is this coil, output latch, right? So I'm going to take one more input, push button 2. Let's take this as push button 1. Right? And output, let's take one more output. Let it be lamp 2, right? So now see, I'll go for online. Yeah. Now what exactly it is going to do? If I turn on, it will on. If I turn off, it will remain on. This output will remain on because I have given the parallel contact. So this is latching concept. Without this concept, without this parallel contact also, we can do the latching, and that is by using this latching contact. See, I'm turning on this push button. Your output is on. This output is on, right? Even though if you turn off, this will remain in a on condition. See, O:0/0 is remain on, right? Because this is a latching contact. So for unlatching, what we have done, we will put one stop push button here as a normally closed contact. But even though if you put a normally closed contact in this rung, it will not listen because it is already latched by using a latched coil. I'll show you that. Now see, this is the stop push button. Let's take like that. stop. And the same thing I'm going to put here. Yeah, like this. And put it in this place, right? Now go online, run. Now see, if I turn on, lamp is on. If I turn off, lamp is off. Lamp is still in on condition, right? Because this is a latching. Now I'm going to repeat the same thing here. Even though if I turn off, this will remains on. That's fine. This is up to this we have seen already. Now this is the stop push button, no? So if I turn on, your normal latching concept is unlatched by using the stop push button. So latching is possible in this case. But see here, I made the rung to false by opening this. But still, this latching coil is in on condition only. Right? So whenever you are using the latching coil, you should use unlatched coil separately. Fine. So that's what it is not turning off. So to turn off the latched coil, you should use unlatched coil also. So I'll show you that. So now I'm going to take one more rung. Let's take one normally open contact and give the same address. Now put a unlatched coil and give the same address of your lamp. Which one you want to turn off? The same coil name you should give, right? Go for online. Now check if you turn on, that is fine. I'll do for this. Yeah. Your lamp is on. And this coil will also on because both are sharing the same address. Don't confuse that why it is also on. Because both are sharing the same address. So unlatching, shall we do the unlatching? So yes, if you turn on, it will off now. So unlatching is possible for latching coil is by using a special coil called unlatched. You cannot put a same as normally closed contact in a series with lamp, right? So this is latching and unlatching concept. So what will happen if you have done the unlatching before latching? Since both are in a different location, no? So let's go for online again. Yeah. Now turn on the unlatching first. Can you see what is happening? Nothing is happening, right? Because the coil is not yet latched first, right? See. Now latch it first. It is happening. Now press unlatch. It is gone, right? And if you turn off again it will on. Why? Because this is, I have not turned off this. Can you guess? See, it is giving priority to unlatching. See, unlatching is happened. Even though the latching coil is on, it is giving priority to unlatching. It is off. Once you have done this toggle, it will again on because latching input contact is remaining in the on condition. So this is latching and unlatching. Whenever you want to do latching, you should always use unlatching. Point number 1. Point number 2 is always turn on the latching first. If you are turning on unlatching initially, then it will not have any influence, right? So these are all the latching and unlatching concept. So instead of using the first rung, you can prefer rung 1 and rung 2. Separately you should use, right? So here this is the latching or seal in contact. This is seal out contact, which is unlatching. But here instead of in a single rung, we are using multiple rung but with different coils, right? So this is in Allen Bradley. You cannot find same latching and unlatching contact in all the PLC. Fine. I'll meet you in the next session with another topic. Bye. Hello everyone. So in this session, we are going to see about comparators. So comparators are used to compare any two integers, or it may be double integers, real, word, like that. You can compare any two analog values, right? So you can find the analog, the comparator functions here, comparator option. In this you can find equal, not equal, less than, greater than, less than or equal, and greater than or equal, right? So let's see that. So here comparator, these instructions are input instructions. So what does that mean? You're supposed to connect one output here. See, I'll just take this equal block. Can you see? It will be coming over here. That means what? You're supposed to connect the output coil. Because the decision of this or the output of this instruction will be reflected in this coil. Whether it may be true means the coil will be on. If it is false means the coil will be off. So let's give any output address for this lamp, right? So just check out this equal instruction. It is having source A and source B, right? So what is this source A and source B means? You need to compare any two values, right? And that value is supposed to give in this location. Fine. So what address you supposed to give here is, you can find the data files here. In the data files, this is the integer. So for all the integers, you supposed to give this address n7:0, right? N7 is a format. If it is the first integer you are using, you can use n7:0. For the another integer, you can use the next address n7:1, right? So just see, I'm giving n7:0. And this one is n7:1 I'm giving, right? Yeah. Check for error. You are not having any error, right? So just go for download. Go for run, right? Can you see your output is on? Output is in on condition. Why? Because both the values are 0. Both are equal. That's what output is on. So just change the value to 45. Your output is off because 45 is not equal to 0. Your lamp is off. You can turn this also to 45. Your lamp is on. So source A and source B, I'm giving address here. Do we give a constant for this? Yes, it is possible. We can give constant value also. See, instead of source B address, I'm going to give constant value. 45 I'm giving, right? Check for errors. So it is not having any error. So the problem here is this should be constant. Only if n7:0 is 45, then only lamp will be on. Else it will be off condition only. And there is no option to change the runtime value of source B. Check. I'm going for runtime. Now check, this is 45, right? So this is 0. So 0 is not equal to 45. Output is off. Now make this to 45 again. Your output is on. Now if you are just change the value of the source B. I'm just changing. See, I'm just clicking, but it is not happening. If you just change here. If you change in this place, it will not happen. Just click on this. Just give any other value. I'm just giving 65 and click enter. But it is not updating, right? It will not take the new value in runtime since it is a constant value. Correct? So if you want to change the source B, you should go for offline and change. So this is important one, right? And moreover, shall we give constant to source A also? Let's check out that, right? So I'll give 75 here. So both are constant now. Can you see, once I have given 75, it is telling operand cannot be constant. Right? Operand cannot be constant. Just go for error, and yes, there is error. What it is telling the same, operand cannot be constant. So source A cannot be a constant value, right? So it should be address. Source B can be a constant value, right? And both cannot be a constant. both cannot be a constant. That means source A always should be the address. You cannot give constant value to source A. There are two options. One is source B can be constant or source B can be any address value, right? So like this only we need to use the equal instructions. And for equal instruction, you can give one input also, because as a rung you can give so many logic over here, right? So I'm just connecting one input here. Yeah, like this I'm giving. Go for online and just download, run. Now change the value of n7 colon 0 to 45. Both are equal but your output is off. Why? Means the rung condition is not true yet. So turn on this, automatically it will be on. So as a rung, it will be, we need to satisfy all the instruction to go on. Then only the rung will go through, your lamp will be on, right? Else it will be not performing the function. Now see, if I change the value now, your output is off because 89 is not equal to 45, right? Now check, just toggle this. Now change the value again to 45, your output will not be on. Whenever you are making the rung condition to go through, then only your output will be in a on condition. Fine. So this is one important point. This is equal instructions, right? Comparing two value whether both are equal or not. Like that, we can take a branch first. Branch will be in this user, okay? Take a branch and just give not equal, okay? So not equal also you can give same value here, and this one is anything, right? Anything you can give. Not equal means if both are not equal, then it will make the lamp to go on. So since you are connecting two instructions in a parallel, if this is true, this will on. If this is true, this will on. If both are true, this will be in a on condition. It's like a OR gate, right? We have seen the logic gate. So just turn on this first. Now your lamp is on because 0 is not equal to 67, right? So just give 67. Now your lamp is off because this is also false, this is also false, right? 0, 0, 0 only. If any one is true, this will go on. Correct? So this is the way to use the equal and not equal instructions. Not equal means whenever both are not equal, that time only it will give pulse, else it will not give, right? So this is not equal. And in the next session, we'll see about less than and less than or equal, right? I'll meet you in the next session. Bye. You just practice this in a software. You can take the instruction and you can give this, right? So yes, I'll meet you in the next session. Bye. Hello everyone. So in this session we are going to see about the comparator instructions, less than and less than or equal. So what is this less than and less than or equal? Let's take the instruction. So less than, can you see the equation here? So it is comparing A less than B. So source A, whatever you are giving in a source A is comparing with B. If A is less, then it will give the output. If B, A is not less, it is big, means lamp will be in a off condition, right? So let's give some address for this. I'm going to give address for this also. And let's take another instruction, less than or equal instruction also. Just give same input. I'm giving the same input, okay? For both the instruction, the inputs are same, right? The source A and source B are same. Yeah. So now both are 0, 0, 0, 0, right? So which rung will give the output? This is less than 0, less than or equal, less than B. This is not true, right? So this fellow will be in off condition. But see here, 0 less than or equal to 0. So this will be true. So let's see, if I turn on the rung condition, this lamp will be on. If you turn on this one, this will not be on because this is not less than. So now this increase the value. Just give 8. Now your output is on. Because this is less than or equal to, this is also less than or equal to. Correct? Now give 8 here. Now again, this fellow will go off, this will be on. Because this is both are equal. Here the equal part is there. A should be less than or equal to B. So 8 equal to 8, that's what it is on. But 8 not equal to 8. So this is in a off state. Right? So this is the way to use such instructions. So same as in a previous session, you can give the constant values also. Let's see. You can give different values also. See, for this I am giving, let's take 10. 10 as a constant value, and I am going to change this to n7:1, and this fellow is constant value 89. Right? Just check the errors and go for online. Right? So just make the rung condition true first. Fine. So both are now on. 0 is less than 10 and 0 is less than or equal to 89. So that's what both the outputs are in a on condition. Now just increase the value to 5 and this gonna be 87. Still it is on because condition is still true. Now change the value to 67. So this is off. If you are putting 89, it will be on still because both are equal yet. Right? So just increase, it will also be off. Right? So this is less than and this is less than or equal to. Right? So the same instruction will suitable for greater than or equal to. Just change the name here. This one gonna be the GRT. Now you see the instruction. A should greater than B. The equation is changed, right? And this gonna be GEQ, right? Now it will check for A should be always greater than or equal to for this instruction, and it should be only greater than for the first instruction, right? So just make the rung condition true first. The rung condition I have given is the option only. This is the option 1 and this is also the option 1. Yeah, so now both the outputs are off because 0 is not greater than 10 and 0 is not greater than 89. So just increase, it is on and this is also on, right? So this is greater than or equal to instruction, right? So for these 6 comparators, I will just give one example in the exercise. We just practice that. Fine? Right. So I'll meet you in the next session with the limit test. Bye.
Hello everyone. In this session, we are going to see about limit test. So in our previous session, we have seen about the comparators. So let's see about limit test. So you can choose the block like this. This is also an input instruction. So you can connect one output after this. So what is the use of limit test? Let's take an example of tank level control, right? So you are in need to turn on a pump when the water level is above 20 and when it will be below 50, right? So it will be above 20 and below 50. This is the
case, you need to turn on a water pump in this duration, in this level range. Fine. So by using comparators, you need to use two comparator, right? One is greater than or equal to, another one is less than. Greater than or equal to 20 and less than 50, or less than or equal to 50. So it will be like that. Correct. So you will be using two comparators. But by using limit test, you can perform this operation. So without using two blocks, with a single block only, you can make use of this situation, application, right? So just in a lower limit, I'm just going to give 20, and here it's gonna be the 50, right? So this is your process variable. This is your level. So it is coming from the field. So just check. I'm going online. Just go for run option. Yeah, so just turn on this. Now see, the pump is in a off condition because your level is 0. Just increase the level 10. Still the pump is not on because it should be greater than or equal to 20 and less than or equal to 50, right? So just give 20 now. The pump is on. So for 25, for every value below 50 or equal to 50 will be in on condition. Just give 49. Still it is in on condition. Give 50. Now also it is in a on condition. Just go for 51. It will go off because it is greater than 50, right? So limit test is used to do the comparator function. That's it. Okay. So here you can give two limits. One is lower limit, another one is higher limit. So here limit test is like less than or equal to block and greater than or equal to block. It is not that less than and greater than. In this limit test, it will take a 20 count and also 50 also it will take a count, right? So for 50, see again I'm just giving 50. Now it is in a on condition, right? So this one I have given as a constant. You can give, see in a normal comparator, the two values should not be constant, right? But here in limit test, we can give this as a constant. Fine. And even you can get this as a running value also. You can give, I'll just show you. See, I'm just giving n7:1 here. Like this also you can give. It will accept. Now just download. Go for run option. Yeah. So I'm turning on my switch. Now see, initially the pump is on because your lower range is 0. So it is like greater than or equal to 0, less than or equal to 50. Now change the value now. Let's just give 7. Now see, the pump is off. So whether it should be a constant or it can be the variable, right? So I'll meet you in the next session with this instruction, which is masked comparison for equal. Thank you. Hello everyone. So in this session we are going to see about this masked equal, right? So in a comparator, this is the last instruction. So this is also an input instruction. So I'm going to prefer over here, right? So here it is having three parameters. One is source, another one is mask, another one is compare, right? So source is the one which value you want to compare. That value you need to put here, right? And comparator value is the reference value. So whatever reference you want to give, you need to give in this. So this source are going to compare with the value which is in this compare parameter. Fine. And what is this mask? So let's see. I'll just go with the address over here. So B3:0 I'm giving here. So I'm just taking the complete 16-bit, right? So this is also I'm going to use B3:1. And this is gonna be B3:2. Fine. So this mask should be, you can give anything like binary you can give, hexadecimal you can give, decimal you can give, integer you can give, whatever you can give. But always it will take the whatever, value you will be giving over here, it will be converted to hexadecimal, right? So just, there is no error. Go for
online yeah, just turn on this. So now your pump is on, right? See, both are equal, so pump is on. It looks like that. Let's see now. I'll just change the value here. Let's change this to 1. See, now both the values are not equal, but still your pump is on. Right? So, what is this masked equal means? If you are not turning on, if you are not activating your mask bit, whatever value you are giving in a source and whatever value you are giving in a compare, both will be looks like equal. I mean, how we are getting the equal? Like pump is on, right? Why the pump is on? Because masked equal bit, I mean, this instruction is giving output. It looks like that, right? So, if you want to get the exact output, for example, these two are not equal, but still this is giving output. For that, to get the exact output, whether it is true or false, to get that, you need to activate your mask bit. So, I'm just activating my mask bit. I'm just giving 1. Now see, pump is off. So, what is this 1 means? I'll just open the data file of your binary. Just see here, I'm activating the mask bit. This is my mask data, right? So complete 16-bit is dedicated for mask. Here the first one is on. So what it will do? No, it will compare the first bit of B3:0 and the first bit of B3:2. If both are equal, it will be giving output. If both are not equal, it will not give output. Fine. So that's what now the pump is off because 1 is not equal to 0. Fine. So now see, I'm changing this value to 1 again. Let's see, now your pump is on, right? Because this mask bit is on. So if you want to have the exact comparison, if you want to have an exact output, then you should activate your mask bit. In some cases, even though your source and comparators are not equal, but you want output need to turn on, you can deactivate this. See, I'm deactivating this. I'm making everything to 0. Now change your data. Just give 1 somewhere. Yeah. So now see, in source and comparator data are different, but still your output is on. Sometimes you may have a case like this. In that case, you can make use of this output for some other application. Even though both are not equal, I want output. In that case, you can make use of this masked equal. Just practice this instruction with some data. Like you can give some extra data. I just give very few. Only 2 things I have given, right? So I'll just go for the third one. Now see. Yeah. Now see, still the pump is on. Right? Both are not equal. Now see, I'll just change this also. Now both are equal. Now source value and comparator values are both are equal, but your pump is still in off condition. What I need to do means I need to activate the respective bits. So first I'll activate this bit. So that will be 3. And how about this one? So this is 2, right? So the last 4 bit are 2. So now see, I have activated the respective bits. Now your pump is on. See, you can see the activation here. The respective bit is on. See, that's what it is doing the comparison. If you are not activated this bit, it will give negative only, right? So it will not give the exact output. So masked equal will be taking the output only if mask bit is activated or not. According to that, it will be giving the output, right? So just practice this instruction with some different data so that you can understand in a very better way, right? So I'll meet you in the next session. Bye. Hello everyone. In this session, we are going to start arithmetic instructions. So, arithmetic instructions means you can do some math operations like add, subtraction, multiplication, division, square root, kind of, right? So, let's see where is the instruction. So, in the list, you can just move forward. You can use this arrow mark, just press that, it will move, right? So yes, here you can see compute bar math. So here you can find some arithmetic instructions like add, sub, multiple, division, square root, negate, converters, and these three are converters. So it is in a compute function. Fine. So let's see about math functions. After that we'll go for this conversions, right? So if you see the math instruction, what it will be doing, it will be doing operation. If it is addition, it will do the addition operation. For that, it will require inputs, right? So here math instructions are output instructions. So previously we have seen comparators or input instructions. No, now it is a output instruction. Just see, if I click this add, can you see it is coming at the end? So you cannot connect any output after this. It will be giving the error. Fine. So both all the compute and math, all the instructions are output instructions. Fine. So let's see this block. It is having source A, source B, and destination. Fine. So whatever value you are giving in source A and source B is added and store the value in destination. So destination should have a address. So let's give the destination value as address. Let's see, in a comparator both the values should not be constant, right? So let's see whether this math instruction is accepting constants or not. Let's see that. Go for errors. Yeah, can't program, both arguments are constant. Okay, see, it's not like a calculator, right? Like fixed value, it will be something like which is changing. So it should be the varying. Okay, so A should be always some address. Fine, because A is the one which is like coming from some other place. Source B can be a constant or it can be any other constant value. Okay, some other constant or any other some value which is coming from some address. Okay, even you can put timer's preset value or timer's accumulator value, like that you can give. Fine. So let's see, now check for error. Yeah, there is no error, right? So let's go for download, run, right? So let's see, just turn on your switch. Now the answer is 78. If you change the value of n7:1, the value will be changing. Correct. So if you turn off and just now it is 167, no? Now again I'm giving 0. So the answer should be 78, but it is not performed because your run condition is false. So make your run condition true. The answer is 78. Fine. So now this is the way to use the add block. The same way you can use the subtraction block, addition, multiplication, division. So like that we can make use of it. So let's see that. Just give subtraction, multiplication, division. Fine. So let's see one branch. Let's take one branch and just keep it over here. Just put subtraction block in this place. Take one more branch, keep it here, put a multiplication. Multiplication I have not taken yet. Take multiplication. Below to that we'll have a division. Take the division block. This one is extra, just delete that. Yeah, so I think it's not in a perfect order, no? So
It should be now. Like, see, it is not in a order, right? It should be exactly parallel. It should be looks good, no, when we are seeing. So for that, just click on this place and put it in this arrow mark. Can you see? Can you see one green color over here? If you are putting here, it will be, see, it will be merging both the ranks. It should not be like that. So once you are dragging, put it in this small box. So it will be looks good now, correct? Fine. So what it is going to do, it will be performing the respective functions. So what I'm going to do now, for source A, I'm going to give the same value n7:1. Let's, if you want, you just give source B as any value. So let's change everything as n7:1. Or just give some value here. 10 will give 10. And destination is n7:2, and some comment is coming, just delete that. Yeah, n7:2, and this n7:2 is going to do multiplication, or let's change this one. n7:2 is multiplying with 2, and that address is n7:3. And n7:3 is divided, I just use the repeater address, okay? This should be divided by maybe 5 or something, okay? And the destination I'm giving as n7:4. Fine. So I have repeated the same addresses here and there. See, n7:1 I have used here. So here I have given 10, and this n7:2 is given as input to multiplication block, right? Check for errors. Go for download, go for run. Yeah, so I'll just reduce the size so that you can see all. So just make this first toggle bit. Yes, can you see? Add, we have seen already, 0 plus 78, 78. 0 minus 10 is minus 10. Can you see? It is giving a sign also. So minus 10 by 2, minus 7 into 2 is minus 20. Minus 20 by 5 is minus 4. Can you see? Right. So now let's give the value of n7:1 as some value, you just give 20. Right. So now see, 20 minus 10, 10. 10 into 2, 20. 20 by 5, 4. Right. So it will be doing the respective functions. And you can give only 2 values. And here also, in addition also, in some PLCs you can find more inputs. You can add multiple inputs. See, add block is what? It will be doing the addition of some inputs. In Allen Bradley there are only 2. Okay, in some other PLC you can add more inputs. Input, that line will be there. You can add some by using some options you can add multiple inputs. But in Allen Bradley we cannot do that. There are only 2 inputs. If you want to do the further addition, use the address of this with another address, right? You can combine this add block again and again to perform the multiple additions. Fine. And as I have already told, for source you can give some timer address also. Fine. I mean timer, not timer's address, timer's parameters. So I'll tell you how to do that. Now take one more rung. In that rung, I'm going to use the same input with some timer, okay? I'm just going to get one timer, and the timer number I'm just giving in. Fine. And this will be 1. And preset I'm just giving us, let's take 20. Fine. So if I give 20, what will happen? Whenever I'm turning on the switch, accumulator value will be running. Correct. It will be started counting from 0 to 20. What I'm going to do, that accumulator value I'm going to give for source A. Yes, not only integer, we can give some address of timers and counters preset also, or counters accumulator value also. You can make use of it in your addition or subtraction block. Fine. Even in comparator functions also, you can compare the timer's accumulator value. Fine. Instead of giving n7:0, or N7 colon 1, you can give the timer's accumulator address. What is timer's accumulator address? T4 colon 0 dot ACC. Got it? So this is N7 colon 0, no? I'm giving the address to this. Fine. And this address I'm going to give here, and this address I have already given here. So all the blocks are interlinked. Okay, according to your timer value, all the address will be changing. Got it? I'll go online. You can see. So all the values will be running now. Let's see that. Turn on. Now see, the value is 0, correct? Now the value is 0, 78. So just I'll turn on this. Immediately everything will be started running, because timer will also start running, no? Whenever I'm pressing this I colon 0 slash 0, your timer will also start running. So just turn on your input. Yes, can you see this value is running, this is running, all the values are changing. See, according to this, yeah, this is also changing, correct? So it will be so the last value should be like timers 20 plus 78, 98. Yes, that's it. 98 minus 10, 88. 88 into 2, 176. 176 by 5, 35. Right. So input parameter can be timer's accumulated value also. Like that you can give preset value. Maybe in your operation you are supposed to do some function with the timers. According to the timer's preset value, you need to calculate something. In that case, you can make use of these blocks. Same thing, instead of timer, you can use counter's accumulated value or counter's preset value. Fine? Yes. So I'll meet you in the next session with the remaining topics like square root and negate. Fine? Yes. Thank you. Hello everyone. So in continuation with the previous session, we are going to see the remaining two instructions, which are all the square root and negate function, right? So yes, I'm going to choose this. This is also the output instruction. So if you see, the square root is having only one input. Fine. So for which value you want to find the square root, that we need to give in the source, and destination should be some address. So I'll just give N7 colon 0, and here I'm giving N7 colon 1. Right? Check for errors, go online. Just turn this on. So I'm just giving square root of 100. It is giving the answer. So it is giving 9. Square root of 9 is 90 is 9. So let's see, square root of 75. It is again still, it is in a 9. Just give 45. It is changing. Okay, so it is rounding off the value and it is giving. When it is not giving the exact answer, it is rounding the value and it is giving. Fine. So for this we can, let's see, for that we are having a float type of data type, correct? So let's see whether this block is accepting or not. So what address we need to give means F8 colon 0. Just give here F8 colon 0. F8 colon 0. Check for errors. Yes, it is accepting, right? So if you want to have the exact answer, you can make use of this data type. Okay, if you are using normal integer, it will be rounding off and it will be giving. Fine. So go for download, run. Yeah, fine. We'll give 90. Can you see now? In prior it was 9, no? Now it is giving 9.488. Now if you give 75, yeah, it is changed. See, it is 8.666. But previously when I was using N7 colon 1, it was giving N7 colon 1. It was giving 9. It is rounding off this 8.66 to 9. If you want to have the exact answer, use the float data type. Fine. So this is square root. So like that we are having one more instruction, which is negate. You can see negate here. Just click on this. Oh, it is in a runtime. Just turn off. Let's see about negate function. So just remove this. I'm going to take NEG. So for this also it is having only one source and one destination. So for source I'm giving one address, and for destination we'll give another address. So destination should be the address of the next one or any other thing, right? So what is the use of this negate function means? If the input is in a positive, answer will be in the negative. If input is negative, answer will be positive. So it will negate the value which is in a source. Now see, for 0 it will not matter, right? For 0 it will be common. So just change this to 12. The answer is minus 12. Correct? So if you give minus some value, it will be changed to plus. Minus 8 means 8. If you give only 8, it will be changed to minus 8. So this is negate function. So whatever value you want to change the sign from minus to positive or positive to negative, you can make use of this function, this instruction, right? So just practice all the math instructions in the software. I'll meet you in the next session with the converters. Thank you. Hello everyone. In this session we are going to see about these converters. BCD to integer converter, and this is TOD. That means convert to BCD, right? So it will be converting an integer value to the BCD number, and this FRD, which is convert from BCD. That means it is converting BCD value to integer, right? So let's see both. So I'm going to take a branch for this. I'll just take this, and after I'll take a branch. Just put this here because both are output instructions, so we need to put it in a parallel, right? So for source, this is to BCD, so the input should be integer, so I'm giving N7 colon 0, right? And this destination is BCD, so I'm giving binary address, and this one FRD, it is from BCD to destination. So what I'm going to do means I'm going to give this destination address as source address here, and here I'm going to give integer address, right? Just go for error check. Run. Let's give one number, let it be as 4, or let's give 8. Fine. So what is the corresponding value of 8 in binary? So it will be like the last 4 digits are like 1000, right? So let's turn on this and check. Yeah. So here the block is giving the answer in hexadecimal. Fine. Here it will not show the binary value completely, I mean BCD value completely. If you want to have a look, you check here in the data file. just check in this place. This is no BCD B3:0. This is the same address I have given here. So for 8, can you see 1000? So this is 8, right? So it is converting the integer value to BCD value, and this block is converting the BCD to the respective integer value. So let's change the number. Fine. Let's just give some other number. We'll keep it here. I'll just give 14. So just check the number here. Yeah, so this is 4. The last 4 digit is 4, and here you can see 1, right? So 14. So let's give some 888. Can you see? 1000, 1000, 1000, right? So this is the way to convert to BCD and from BCD. Fine, you can give any number, or else you just change here. This one we cannot change because this is the destination. So even though you are changing, it will be taking whatever value you have given in this place, right? So these two are the converters from BCD to and to BCD. Fine. So let's practice this in the software. I'll meet you in the next session with another topic. Thank you. Hello everyone. So in this session we are going to see about move and move with mask instruction, right? So let's see what is this move. Generally, move instruction is used to move a data from one address to another address, right? So it is having source and destination. Whatever value you are putting in a source address will be moving to destination address once the run condition is going true. Fine. So let's give the source addresses. You can give integer address, or you can give binary address also. I'll just take one more branch for binary. Can you see? Both are acceptable. Okay. So let's go for online. Fine. So let's give some number before making the run condition on. I'm just giving 89 here, and here let's give So I have given 80814, right? So let's make the run condition on. So once the run condition is true, the value you have put it in the source is moved to destination. Fine. So usually move instruction will be used mostly when we are using the analog IOs, right? So whenever we are getting analog from the port, analog input module, no? So that address, the data which is stored in that address will be moved to some memory address for processing inside the ladder logic. So in that case, move instructions will be very useful. Same like output side also, after processing you need to put the data in the memory address to the output port, analog output. So for that cases you can make use of move block. Also you can put timers accumulator value, timers preset value, counters preset and accumulator value also you can use for anything. Maybe it may be a destination or it may be a source. You can use that, right? So this is the use of move instruction, and this is the way to use the move instructions. So along with that, we are having one more instruction, which is move with mask, right? So let's see what is this move with mask. I'm just going to change the name MVM, right? So I'll just change here as MVM. Here also MVM. Fine. So let's go with the same address. Fine. So what exactly it will do? So here it is showing some error. What is the error? We have not given the destination because move address, no. Move block is having only 2 parameters, but move with mask is having 3 parameters. So let's give a destination addresses N7:2, and here I'll give B3:2. So what is this move with mask means? If your mask bit is not activated, it will not perform the move function. Got it? So let's see. See here B3:0. Imagine you are having some number. So I'll just take one small example. Like I'll give like this. It is 4, no? This one is 4, correct? So I need to give 4 here. What does that mean? The 4th bit. I mean 4 means what? It will be looks like this one, 0 1 1 1 0 1 0 0 0. So that means if the respective bit is activated in mask, then only it will do the move function, else it will not do. So I'll show you over there in online. See, I'll just make this as 0 first. It will be in a hexadecimal only. So here I'll just give some 89, same value I'll give. Let it be a 0 here, okay? So let's turn on. Yeah. So can you see here also it is 0 because it is not doing the move function, correct? So here you need to activate the respective number. So I'll just give 89 here. Yeah. Yeah, it is taking in a hexadecimal. Okay. So here it is transferred as 89. See here nothing is happening because this mask bit is not activated. I'll just show you here. So better for move with mask, you can go with this binary numbers. More than integers, use this binary so that you can understand better. Now see, the third bit is activated, correct? Because I have given like this, third bit is activated. But can you see here the third bit is not activated in the mask bit. This is mask, no? B3:1. That is not activated, so it is not moving. Shall we activate this now? I activated, immediately it is moving. Can you see? Right? So I'll do one thing. I'll just change the 5th bit to 1. Here I cannot change. I need to change here. Yeah. So now see, I have activated one. I have given one more data, but that is not moved because the respective bit is not in on condition. So let's turn on that bit also. Turn on this. Automatically that is moved. Yeah. Can you see? It is moved. Got it? So like that only it will be working. I'll just give some data. See here. Yeah, so this is my data. Fine. So the respective bit, only this 5th bit is on, so it is transferring. Can you see? Remaining bit is not at all in on condition. This is 0, so it is transferring 0. Remaining and all, it's not at all transferring, right? So let's change this to 1. Just give enter. After clicking 1, give enter. Yeah, so it is transferred. And this is also transferred. This is also transferred. Here 1 and here also 1. Fine. So exactly it is performed the move function. Whatever value you have given in the source is exactly moved to destination. only if your mask bit is activated, respective bits. It is not like mask all bits are activated. Yeah, it will be activating all, but still the respective bits are activate should be in the activating stage. Then only it will exactly transferring the data which is in a source to destination. Got it? So this is move with mask instruction. Fine. So just practice this in a software. I'll meet you in the next session with another topic. Thank you. Hello everyone. So in this session we are going to see about the logical instructions. In the previous session we have seen move, and today and in this session we are going to see logical. Fine. So when it comes to logical, we are having 4 gates and OR, XOR, NOT. Fine. So let's do AND first. So it is a bitwise AND. Fine. Bitwise means what? It will be binary. So you need to give the binary address. Let's give B3 colon 0. And it is having 3 parameters. One is source A, source B and destination. So whatever data we are giving in source A, it will do AND operation with B3 colon 1 which is in source B. Correct? So these two datas are doing the bitwise AND operation and storing the result in destination. So let's go for the destination addresses. B3 colon 2. Got it? So let's go for it. So exactly it is the bitwise AND. Fine. So see, if I go for run condition on, it is giving 4 as the answer. Already I have some data in B3 colon 0 and B3 colon 1. 4. Can you see? That's what it is giving 4. So to see the exact bitwise, you can go for the data files and click on this binary. Check out here. I'll just zoom it. Yeah. Can you see? Everything is 0. Here only 1. So it will do bitwise AND means, right? 0 0 0 1 1 1. This is AND, no? What is AND gate? It should be giving 1 only if both are 1. If any one is 1, it will not give. See, this is 1, but 1 0 0. Suppose if you are making this also to 1, it will be 1. Correct? So this is bitwise AND. Fine. So I'll just change some value here. Even we can change here also, but once it is pressed, just click enter so that it will be. So if I give 1 here, it will doing the 1. Correct? Fine. This is AND gate. Got it? Fine. AND gate. This is AND gate. Bitwise AND. So first bit, 0th bit is comparing with another 0th bit. So it will be both are 0 0, answer will be 0. Both are 1, it will be giving 1. If any one is 1, another one is 0, answer will be 0, because that is AND gate. Fine. So let's see the same thing for OR gate. Let's take a branch. I'm just copying the same instruction and putting over here, and I will just change the name because I'm going to use same source address, same datas, but I'm going to change the destination address because B3 colon 2 is having AND gate output and B3 colon 3 should have OR gate output, right? So let's check for errors. Go for online. Fine. Let's turn on this. It is also giving 4. So let's see in the data file. So B3 colon 2 is for AND, this is for OR. So I'll just change this to 1. See, OR gate is giving 1. This is OR gate, no? Because any 1 is 1 means OR gate will be giving 1, correct? So if I make this also to 1 and the gate will also give 1. Fine. So this is the way to perform the OR gate. This will be happening only if your rung condition is true. Fine. So this is OR gate. If you are turning off your rung, see, I am not making the rung condition on. Okay. Now, if you are changing something, it will not work. See, your output is not updating, right? Because to perform, to make that instruction, to make that AND and OR instruction happening, you should make the rung condition on. Fine. So let's do that. Yeah. So it is updated. It is updated. Got it? If you make this also, it will be on. So this is AND and OR gate. We are having 2 more gates. Let's see that. So let's make this to XR. XR is there, and this one is NOT. So for NOT, I think only 1 input and 1 output, right? Because NOT is the instruction like whatever you are giving in the, if the input is true, it will be giving false, like that. So in the NOT gate, whatever data you will be giving in the source A, it will be reverse in the output. If it is 0 means it will be 1, or 1 means it will be 0. So that's what it is, having only 2 parameters. See, source and destination. So let's see. Yeah. Turn on. So what is XOR gate? 0 0 0 0 1 1. Correct? Can you see? 0 1 1. So here everything is 1. Okay. See, here we have given B3 colon 1 as destination, no? That is taken as input here. We have given the same as on source address. So that's what, can you see here? This B3 colon 1 is the answer of our NOT gate. Correct? So, yeah. So 0 means 1, 0 means 1, 1 means 0, 0 means 1, like that. It is happening. It is giving the exact inverse. Where n all was 0, it was 1. Here only 1 is there, that is changed to 0. So let's change the value of B3 colon 0. So I'll just give 8. A 15 1. Yeah. See, now 8 I have given, so it is changed to 0 0 0 0 1 1 1 1. This is exactly opposite. Got it? So B3 colon 1. So if you find the XOR gate of B3 colon 0 and B3 colon 1, that is stored in B3 colon 2. So let's see that. 1 0 1 1 0 0 1 1. If both are 0, then only the answer will be 0. I think we are not having any option like 0 0. So XOR gate will be like 0 0 0 0 1 1 1 0 1 1 1 is also 0. Correct? So let's change this to 1. Yeah, can you see? This is changing to 0. Okay, fine. Again 1 0 1. Got it? So let's do one thing. I'll just change the address. I'll give this as 3. Okay, here no confusion, no? Yeah. make the run condition true. So it is completely inversing. This is fine, correct? So if you give some different value, yeah, it is completely changed. NOT gate is not an issue. Just inverting the source to destination. Got it? So let's see about this XR now. So XR is doing B3 colon 0 XR of B3 colon 1 and storing the result in B3 colon 2. Let's see 1 0 1 1 0 1. So 0 0 0. Can you see 0 0 0? Got it? Let's change something to 1. Here also I'll give 1. So it will be 0 now. Can you see? 1 1 0. This is XR gate. Got it? So it is doing the bitwise XR operation. 0th bit of source to 0th bit of destination. Correct? And storing the result in 0th bit of B3 colon 2. Fine. And 1 means 0 here. 1 means 0 here. So this is not a gate source address. This is not a gate destination address. Got it? So this is logical bitwise operation in Allen Bradley. So just practice this in software. I'll meet you in the next session with one more instruction is pending, that is this clear. Let's see that in the next session. Bye. Hello everyone. So in this session we are going to see about clear instruction in move and logical. Okay. Can you see CLR? So I'll just take one more new run. Just take this instruction. It is also a output instruction. So what is this clear instruction? Exactly what it will do? See, if you see the instruction, it is having only one parameter, which is called as some destination. So you need to give some address to this destination. Whenever the instruction is getting true condition, it will be clearing the data which is in that, whatever the data you have put it in that address, that will be cleared. Cleared means what? It will refreshed back to 0. If the data, maybe imagine the data is having some 100. It is, when the instruction is going true, whenever making the run condition going true, it is making that 100 to 0. Fine. It is not only for integer. You can go for timer preset value or accumulator value, or you can go for source, whatever it may be. Okay. Normally this address B3 colon 0 we have given for source, right? And this one we cannot change because this is the output of your NOT gate. We cannot change that. But what are the input you can give? B3 colon 0, B3 colon 1. These are all you can give in clear instruction. So let's see that. So to make this true, I'm going to have one more input. Okay. So this input address I'm just giving I colon 0 slash 1. So whenever switch 2 is on, our clear instruction is gone. Okay, let's take that. So in this I'm going to give, let's give B3 colon 0. Okay. I'll just give this, check for errors, and let's give some big value here, 8884. Let's give like this. Okay. So see here, can you see it is updated here also because the same address I have used. So let's go for download, run, right? So let's turn on this. It will do the XR function. That is fine, right? It is doing the regular XR functions, right? Now, if it is on, what will happen? Clear. Clear means what? Whatever data it is over here, no, 8884, this is going to be 0. I'll just take this also. See here, it is completely filled with 888 and this is 4, correct? First B3 colon 0, right? So let's turn on this fellow.
turn on this, yeah, can you see? It is cleared. Can you see it is updated here also? Updated here also. And even if you want, you check the data file. Yeah, can you see? Yeah, can you see? 0, 0, 0, 0, everything is cleared. Now you can give some new data here. But before that, it should be in off condition. Just give some new data. Fine. Yeah, new data came, or I have given the same number. If you turn it on again, it will go back to 0 again. So whenever you want to refresh the data, like you want to make the data to 0, in that case you can use this clear instruction. And this one is not only taking this b3 colon, not only binary value, you can give integer address also. So for that, I'll take move instruction here. I'll just take a move instruction. For destination, I'll give this source. I'll just give one integer address. For both, I'm giving integer address. Fine. I'll just give n7 colon 0 here. Fine. Let's make download. Fine. So now just give any value. It is moved. That's fine. If you turn on this, that will back to 0. Got it? That's it. Right? Shall we try for one time more? Yeah. Let's try this. Oh, I have not changed it here. I just give n7 colon 0 only. So I need to give timer's preset address here. So before going online, just check whether you have updated everything. I have not checked now. That's what it happened. Fine. Can you see? Preset is changed to 0 immediately and your done bit is on. That means what? Accumulator value is equal to preset value. Correct? That's what the done bit is on. When the done bit will be on, like preset is 10, accumulator value is reached also 10. That time your done bit will be on. But here both are 0, 0. So accumulator is on. You can turn off this and you can give some new preset value. You need to give the trigger again. Then only it will start again. Yeah. If you again turn on, it will go back to 0. That's it. Got it? So this is the clear instruction. You can make use this clear instruction for some comparator instructions also. If you want to make something to 0, you can make use of this clear instruction. So just practice this in a software. I'll meet you in the next session with another topic. Thank you. Hello everyone. So in this session we are going to see about scaling function. So let's take a scaling instruction first. You can find the scaling instruction in advanced math. You can find SCP, that is scale with parameters. So what exactly the scale with parameters will do? Just look at the parameter list. It is having input, input minimum, input max, scaled minimum, scaled maximum. It is like scaling function, no? So whatever input you are giving, according to the input range, it will convert that to the scaled value, right? For example, you have 0 to 10 as the input. It may be any number between 0 to 10. The same 0 to 10 should be seen in a scaled value like 0 to 100. In that case, input minimum and maximum is 0 to 10. Scaled minimum and max is 0 to 100. Right? So you can see some input value to the scaled value, right, by using this instruction. So let's take one more example. Let's take a level controller. Fine. So you are having a tank. You are going to control the level in a tank. So for that you are placing a level transmitter, and when the level value is 50, or when the level value is below 20, you need to turn on the pump, right? So valve of the pump, I mean the valve which is giving water inside the tank, no, that will be changing according to the range. For example, if the level is below 20, the valve should completely open. Fine, the control valve should be completely open. So when the tank is getting filled, when it reached 50, the valve should partially open. So it is not like before. It was completely open, no? Like completely 100% open. Right? Now it should be 50% open. When the tank level is reached 75, it should be 25% open. When the tank level is 100, it should be 0% open. Okay, that means it is completely closed indirectly. Okay, so this is the example. So for this, in a ladder logic program, we need to compare, correct? We need to compare our tank value. Oh, when it is 20, we should be completely open. We need to send a signal for that as an analog output. Same, 50% open means we need to give, 50% open when the tank value is 50. When the tank value is 75, like that, here we need to use the comparator functions. Correct. So for that comparator function in the ladder logic, we cannot give 4 to 20 milliamps directly. For that, you need to do the scaling function. So let's take level transmitter value as N7:0. Fine. So this is the value which is coming from field. This should be any value between or from 4 to 20 milliamps. So input minimum should be 4 and input maximum should be 20, right? And scaled minimum should be 0 and scaled maximum should be 32767. Got it? And output will be another integer address. Fine. So let's check for errors. Go for download. Right? Just go for online. So first check your level transmitter is giving 4. That means what? Your tank level is 0. When your tank level is 0, your transmitter value should be 4. So that time your scaled output is also 0 because you have scaled up to 32767, no? So when your transmitter value is slowly increasing, let it be 6. So your scaled value is 4096. Correct? So when your transmitter value is 12, that means 50% of the water, it is 16384. Fine. So let's note down this number in some place. One 6384, right? Right. Fine. So now when it is 16, it is 24575. 24575. This is 75%. Okay. So when it is 20, it will be obviously giving 32767, correct? So this is the scaled one. Fine. So why I have noted the number for 12 and 75 means I'll just tell. So just go for offline. Now you are writing a program for that level controller. Okay. So in this, let's take a comparator. So in this comparator, you are having, let's take greater than, let's take a limit test. Okay. So in this, your output should be N7:1. So this is the one which you are going to compare. Okay. That should be this value. Let's take this 16384, 16384. Just type 16384. Fine. And this, and here you can just give, which is maybe the value of 9, 10 or 8. It may be, just give some random value which should be below to this. I'll just give 12,000. Let's take like this. Okay. When this is the case, you are turning on some output, and this output is like val 50% open, like that you are giving. Okay. So you are giving some indication. So just go for online. Just turn on this. Now check, just give 4 or 5. So it is giving this value. Okay. So that in this case, the val may be 100% open. You can write one more limit test and you can write like that. So now just give 9 or 8, 9. Okay. Still it is not reached our 12,000. So let's give 10. Yeah, it is reached 12. Okay. So that means what? In this case, your val should be 50% open. So like that, by using this PLC number, you can able to do the comparator function. Okay. So this is what I have told. You can process this. Fine. So same thing for 0 to 6,000. You can give val 100% open. So 6,000 to 12,000, you can give the val is 75% open. Like that you can give. Right. So let's do that also. Copy and paste this. And here you just type when it is 0 to 6,000. Okay. And just change the address, which is 100% open. Right. 100% open. Yeah, it will be changing when it goes to online. So just go for one more paste, and here just give 60012 some 11,000. Let's take 11,000. Okay. So in this you are giving 75% open. Just take one more different output. Here you are giving 75% open. Fine. Got it? So now let's go for online. Fine. So now the value was 0, no? So it is 100% open. Now give 5. So still it is 100% open. You can see here. Yeah. Now give some value like 8. I think it is still 100% open because the value is
I think we have not turned on the rung condition. Let's turn on that so that it will get update. Yeah. Can you see now it is 75% open because it is the value is above 6,000, right, and below 11,000. So when you give above 12, let's give 12 exactly, it's 50% open. Like that you can give for 25% open and completely 0% open also you can give, right? So this is the way to use the SCP. Just practice this in a software. Like that you can convert from 0 to 3 to 767 to 4 to 20 milliamps as the output scaling function. You can do like that also, or you can go with 3 to 15 psi. You can give. So input scaling function is also there, output scaling function is also there. So just practice this in a software. I'll meet you in the next session. Bye.
Hello everyone. In this session we are going to see program control instructions. So we are having 3 program control instructions. One is this jump, another one is subroutines, another one is this master control reset. Fine. So let's see jump in this session. So what is this jump instruction? So what is the combination where we are going to use it? Along with the jump we need to use any other instruction. So let's see what is that exactly. Fine. Let's take a scenario. You are having 5 motors. Maybe you are running an industry. In that you are using 5 motors daily for production or manufacturing. Let it be, right? So for all the 5 motors you are having corresponding inputs, or it may be take same input. For same input there are 5 motors. Fine. So you are daily running this, and some days due to some power cut or any other case you cannot able to run 4th and 5th motor. You should shut down that, right? So for the same program, okay, for the same program, can you able to establish it? So daily you will be running all the 5 motors, and particular days you are supposed to skip some motor operation. Fine. So for that you need to write a different program on that day. There is no need. You can use some instruction so that you can able to achieve this. On that particular day you can able to skip on those 2 motors. On the remaining days you can run as usual. So within a single program you can able to do it. So let's see how to do that. So now I am going to take 5 motors here. Let's name this as, okay, first I'll take a copy of this and I'll paste. Yeah. So I'm having all same inputs, okay. This is gonna be M1. Yeah. M2. And this is M3. M4. And the last one is M5. Fine. Right. So on normal day you will be turning on this, automatically all your outputs will be on. This is common, right? So to turn on all the 5 motors you will be turning on inputs. So here I have taken the same input for all the motors. Fine. So on some particular days you are supposed to switch off this M4 and M5, right? So in the same program you can able to do it. So how to do that? So whenever the word called skipping is coming, you want to skip some rungs, you are in need to skip some rungs, means you can go for the jump instruction. So what is the use of jump instruction? Means on certain condition you can able to skip the number of rungs as per your requirement. You may need to skip 4 or 5 rungs, or you may need to skip only 1 rung,
or it may be 10 rank or the group of 20 ranks, whatever it may be, depends upon your requirement. You can select the number of rungs. For in our case, we need to skip only M4 and M5. So I need to skip this rung and this rung. Fine. So in this case, you supposed to introduce jump before the rung. Fine. So I'll tell you, just take one rung here. So here only I need to introduce the jump instruction because I'm going to skip this rung and this rung. Fine. So we need to give like a border from this place to this place I want to skip. In that case, you are picking the rung before that. Here only you need to introduce your jump instruction. So just add the jump instruction. You can find jump instruction in the program control menu. Here program control menu, take jump. So when you click jump go to output side because it is output instruction. Fine. So for this you need to suppose to connect one input. So what I'm going to connect means I'm having one input. Let's take some other thing. Let's take one and just give jump input. Jump in. Fine. So whenever I'm turning on this jump in, that time it will be skipping these two functions. I mean these two rungs, right? And yeah, so jump is having some question mark. So we need to give some address for this jump. Okay. So here in Allen Bradley, you need to give Q2:0. You can start with a 0. Even in the same program you are using some other jump, you can go for Q2:1, Q2:2 like that. It is having limit, depends upon the processor. Fine. So right. So here you have introduced a jump before the rung. You need to tell up to which one. So here it is starting. Then where is the limit? Where is the end limit? That one also you need to tell, right? So for that, you need to have one more instruction, one more line here. I mean rung here. Here you need to give your label. So jump and label are combinations. Can you see LBL here? You need to give here. Fine. You need to give here also. Fine. It will take you anyhow. It will take you to the new rung only. Fine. So this label is also having a question mark. So here you need to give Q2:0. Fine. So same address we need to give. Then only you are setting the limit for this. From this place to this place like that. Check for errors. It is showing output missing on rung. Fine. So whenever you are using a jump, the label should not be at the end. Okay. So what you can do, you just take this rung and you just put it over here. Or you can connect like this. Put it here and this gonna be anyhow. See, this is a rung, correct? Whenever you are turning on I0.0, this will be automatically running. Fine. So that will not be the issue. So label should not be empty. You can connect anything in this line. So jump is starting from this place to and ending at this place. That means before this. Fine. Now check for errors. It will not show you anything. Fine. So I'll just go online. Just go for run. Yeah. So on normal days, whenever you are turning on, all the outputs are on. M1, M2, M3, M4, M5. All the 5 motors are running in your industry. This is fine. Correct. On those particular days, whenever you supposed to skip M4 and M5, just turn on the jump first. Fine. You have turned on the jump instruction. Okay. Now if you turn on the input to the motor, can you see only 3 motors are running. M4 and M5 are skipped. Got it? So this is jump instruction. Because this input is on, the input to the jump instruction is on, it is skipping these 2 rungs. Input we cannot control. Input like we are turning on, so it is just showing the status. But see the output, check the output. It is in a off condition. Got it? So suppose if you are turning off your jump, this fellow will automatically on. Correct. See, now all the 5 motors are on. Fine. So once it is on, now you jump, now turn on the jump. It is not going off, right? But see, if I turn off the input, all the outputs are on except M4 and M5. Correct? So we need to understand here is whenever the jump instruction is on, it is skipping the rungs. It is not related to whether it is in off condition or whether it is in off condition. It is not bothering about that. But it is skipping the rung condition. That we need to understand. Fine. Now see, it is not updating the status of M4 and M5. M4 and M5 is still in a on condition. Can you see input is off but still it is in a on condition. Just turn off this, it will update. Correct? So it is completely skipping. Fine. Like that you can use multiple jumps also. So we'll see that. So now I add some more rungs. Okay. So just give some other input here. 3. And here let's change the address. Pump. And let's take, this is jump 2. Okay, jump 2. And this gonna be your jump instruction. Correct? This gonna be the jump instruction. Give jump here. Yeah. And now you should use Q2:1. Fine. And here you have introduced a jump. This is gonna be another input. Fine. And this is some different output. So this is the one you are going to skip. Okay. This is the rung you are going to skip. So in the next rung you can introduce the label. This is gonna be the label with what address? Q2:1. That's it. Here you can give some normal input and output. Just drag it and place it this side with some output. Yeah. Some other input and this is gonna be some other output. Check for errors. No errors. Go for online. Yeah. So now this is common. Whenever you are turning on, this will be on. Whenever you are turning on, this will be on. And this will also be on. If you are not turning on the jump, it will be like a normal operation, right? So now you turn off this. Turn on the jump. Now if you turn on, it will not on. It is skipping the 8th rung. Same. If you turn on this, everything is on. Fine. All the 5 motors are on. This one we have seen already. Just have a look. Fine. If you turn off and turn on the jump first, if you turn on again, your 2 motors are off because the line is skipped. Got it? That's it. Fine. This is a way to use the jump instruction. You can introduce jump within jump. That is also possible. Fine. You just try that. Just try that in a software. I'll meet you in the next session with subroutines. Right? Thank you. Hello everyone. In this session, we are going to see about subroutines. Right? So we are having an instruction, jump to subroutine. So generally what is subroutine? Let's see that. So whenever we are creating a new project, you can see this program files. In that we are having LAD2, ladder 2.
That is our main page, right? So the system 1, sys 0 and sys 1 are for the project usage. We cannot use this. Even you cannot open and see this, right? This is for the project. And here only we will be writing. User can write. Okay. So this one we cannot use. And ladder 2. This is the main page we usually write. Correct? So this is the main page. For example, if you want to write some particular function, for that you can take a new page. So ladder 2 is the default one. When you are creating a new project, it will be coming. It acts like a main page. So apart from this main page, if you want to add some more pages, for example, for IO mapping or for scaling, for some other different function, if you want to write some functions separately, means you can make use of the second page, third page, like that you can create. How to create means just go to program files, right click, new. Right? So whenever you are clicking new, it is giving 3. That means what? Already 2 is there. Already 0, 1, 2 is there. And now the new one is 3. Right? You just go with that. So can you see? Ladder 3 is created. So here this is the new page where you can write your new functions. Fine. So you can add input and you can add output, like whatever you want you can write here. That IO mapping I have told, no? So you can write a new program. I'll just write for one DI and one DO. Fine, right? So just check for errors, and just go online. This is our main page, right? Now just try to turn on this. Is that your output is on? It's not on, correct? Not only DI, whatever function you are writing here, that will not be in a running condition. If you are adding timer here, that will not run. Counter, it will not count. Comparator, whatever it is, the function will not happen. Input, I am turning on, so it is on. But output, see, output supposed to be on, no, but it is not happening. Why means, whenever you are adding a new page, you should call from your main page, right? So, whatever function you are writing in a program, you are writing in a project, that should be called from your main page. Unless or until you are not calling from your main page, it will not perform the function. So, the same thing. It was not turned on, no? Your 0.0:0/8 is not on. Because anywhere is that you have called? No, I have not called. So what is this calling? That calling is called as jump to subroutine. See, the extra programs, no, I mean the pages extra you are adding, right? Those are called as subroutines, sub pages. Okay, so we need to call from our main page. So how to call means you can have one input and that input will be turning on to call that. So we are having block for that. So let's see what is that block. So this is the input I am going to call my sub pages. So let's go to program control instruction menu. Yeah. Here there is an option called jump to subroutine, right? Click on that. So when you click on jump to subroutine, it came as an output instruction. Fine. So it is asking a question mark. So here you need to write the subroutine file number. Subroutine file number. Check out what is your file number. It is 3. Correct. So there is a format to give. What is that format is? U:3. 3 means what? Ladder logic 3. Suppose you are adding one more page is 4. You want to call that subroutine, you need to give 4. Correct. So I am giving U:3. That means whenever this I:0/5 is on, I'll just give the description. Call ladder logic lad3. Fine. So whenever I'm pressing this will be calling our ladder logic, right? So let's go online. Yeah. One more thing. There is two more thing we need to add. So we have added this jump to subroutine. In the subroutine page,
in this page you need to add this SBR. Okay, this is the format to use the subroutine. You need to add this SBR block. After that, in the next rung, you need to add this return function. So this is the format to use. In a main page, you will be adding this block. In the subroutine page, you need to give this kind of label. This is the subroutine label and this is the return label. Fine. Now go for online. Yeah. Now if you turn on, it will not on. That we have seen already. Now go to your main page. Call your subroutine first. You have turned on, you have called. Now go to your subroutine page. Now if you turn on, your output is on. Got it? So unless or until you called in this main program, it will not perform the function. Got it? So this is subroutine. So like that you want, you can use multiple pages also. Now it is 4. So in the 4, you just add one subroutine label, some functions. So I'll just copy from something. Put it here. Even if you want, you just add timers also. Just give T4:0, right? And preset as some 10. Let it be. After that, in the next run, just add reset. If you want to continue this logic, you can. You can create. And sorry, this is not a reset. That will be return function. Fine. Just give return. Got it? So in the main program, you need to call this. Let's take this to call that page number 4, subroutine. So what you need to give here, U:4. That's it. Fine. So this, just give the description as call lad 4. Fine. Just check for errors. Go for online. Fine. Now go to your page 4. Turn on this. It is not turned on. Main page. Call this first. If you call this and go and check, it will be started running. Got it? So this is a way to use the subroutines. You need to use jump to subroutine and this subroutine label and this return label also. Got it? That's it. Fine. So I'll meet you in the next session with master control reset instruction. Bye. Hello everyone. So in this session we are going to see about master control reset. So what is this master control reset? You can find here as MCR. So simply I can tell you that it is like a main switch in our home. So in our home, in energy meter, we are having a main control, no? So if you are turning on that, then only you can able to turn on all the lights, fans, whatever home appliances we are having in our home will be in on condition. So if we turn off that, automatically, even though the switches in the electrical board is in on condition, but main is off means everything will be off. It's like that only. Okay. So I'll tell you how to use that. So for example, in an industry, they may have more number of inputs and outputs, right? So in some emergency cases or sudden we need to turn off everything at the same time. Maybe in some cases, maybe that may be emergency or it isn't requirement or whatever it is. So in that case, you can make use of this MCR. So MCR, if you are using, you can turn off all the outputs at the same time. Let's see how to do that. So let's take M4, M5 and this M3. These three are the outputs I need to turn off immediately and at the same time, even though the input condition is different. See, here input is different, here input is different, here input is different. Even though the input is a non-condition, if it requires, you can turn off your respective outputs. So for that, first fix which output you want to turn off. I'm going to turn off 1, 2, 3. So you need to introduce before this. MCR should introduce before that. Just take a MCR. MCR is the output instruction. Got it? So it is not asking any question mark and also no need of giving any address, but whenever you are using the MCR, you should give the input condition. Okay? Just give XIC. After that your MCR. This is your main switch, like that. MCR on, right? And you have created the starting place where it should end. It should up to this only, so after this rung you need to finish MCR. So take one more rung and give MCR here. Just check for errors. Go online now. Right? Now if you turn on, automatically everything will be on. Right? But see here, your outputs which is in MCR zone is not at all on. I have told you, it's like a main switch. So you need to turn on your main switch first. Then only it will on. Fine. Suppose in any condition if you turn off, all the outputs are immediately off. Got it? Understood? This is the use of MCR. It's like a main power supply, main switch. So whatever outputs you want, you need to put that in the MCR zone. MCR zone is starting from this place to this place. Even you can introduce 2 or more MCR zone also. So let's see that. So let's see, I have introduced one MCR zone here. Let's take few more rungs. Let's take, yeah. So here introduce MCR. Fine. And here connect some IOs. Take some output. After copying, you can change the name. Right? So these 2 outputs I need to turn off when it requests. So I am concluding the, ending the MCR here. Fine. So check for errors. Go online. Right? So if you normally turn on, it will not on because main is off. Turn on that, automatically this will on. So you can introduce multiple MCRs in same program. If you want to change the MCR border, zone means, for example, only these 2 outputs only I want to put it in a MCR. I want to remove this means you just take this rung and place it before M3. So I'll show you. Take this rung and put it here. So now M3 is after the MCR zone. So it will not come under MCR. So now M4 and M5 are in
M5 are in MCR zone. Got it? So this is the way to use the MCR instructions. Whenever you want to turn off all the outputs at the same time, or you should have some main control, in that cases and all, you can make use of this MCR instructions. Fine. Okay, I'll meet you in the next session. Thank you. Hello everyone. In this session, we are going to see about sequencer output. Let's see where is the instruction. So you can see file shift bar sequencer. Okay, so whenever you want to have a control of the sequence operation, you can make use of this instruction. So in the file shift and sequencer menu, you can see SQO, sequencer output. So just click on the instruction. So this instruction is having various parameters. First is the file number, then it is a mask, then it is a destination, the output file, then there is a control part, then length, then position. Okay, so what are the inputs over here is file, mask, control, length. Okay, so these four are the input parameters, and destination and position are output. Okay, so destination is the complete 16 bit file, so where you are going to see the output. Mostly it will be the output file like O:0/0, that one. Okay, and the file number and mask should be the binary. So I have a program for that. I'll open that. Yeah, can you see the file over there? Hold on. Yeah. So in this sequencer output, I have given the file number as B3:0. That hash automatically it will take. Okay, B3:0. And the mask bit I have given as B3:10. Fine. And the destination file O:0.0, complete file I have taken. See, I have not given as a bit. Okay, I have given as complete 16-bit file. One channel I have given. Okay, and this is the control file. Okay, R6:0. You can get from here. Can you see? Control. So this is taking care of the controlling part. Fine. And this is the length. You need to give this integer. You can give from 1 to how many numbers according to the processor the limit will be. So I'm giving here as 4, and the position is automatically changing whenever you are going for online. So what it will actually do, I'll tell you. So in the example or in the exercise session, you will be seeing example like four-way traffic light control or two-way traffic light control, like that you will be seeing, okay, in the exercise or in example problems. So there we are in need of to write multiple rungs. Fine. So take a four-way traffic control. So there you are having 12 outputs. Okay. So each direction 3 outputs. So 12 outputs. For all the 12 outputs, you will be connecting in the rung. Fine. So all the 12 outputs should have some necessary, needed conditions. So to reduce the number of the rungs, you can make use of this sequential block. Okay. So how to turn on multiple outputs with a single condition? Okay, so it will reduce the number of rungs if you are using this block in the four-way traffic light control, right? So what exactly it will do means, for each and every position, so for example here I have given length, length is 4 here, right? So for this, each and every rung, whenever this switch is going on, the position number will be changing. Okay, so according to the position numbering, it will be feeding the output file with some ones or 0. It will update the files for each trigger. Okay, so I think I can go for online so that you can understand better. Hold on, it's loading. Yeah. Fine, I'll go for online. So I have given the file name. Okay, apart from that I have not given anything else. Now I am going to give, just take a binary file. Okay, so in the binary file, mask bit we have given us, what we have given, B3:10. Can you see? Mask bit. And we have already discussed regarding the mask, right? Like the comparison block and all we have seen. What we have seen, mask bit need to be 1. Fine. So for example, B3:10 I have used means all the bits need to be 1 so that it will exactly give the output. Whatever input you are giving, that will be comparing with the mask bit. Okay. Mask bit, if it is 0, it will not process. So mask bit should always be 1. Fine. So what I'm going to do means, I'm going to take this mask bit completely to 1. So instead of typing 1, I need to update here. Okay. 1, 1, 1. Like I need to update here because this is a input file. You need to give the input. So I'm going for this hex and I'm just giving here as F, 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 F. Okay. Now you go for, oh, I didn't press the enter. Enter. Okay. Now go for binary. So everything is 1, 1, 1. Fine. So this is the first step we need to do. This is, in our example, I'm just giving everything as 1. According to the requirement, you can change the bit. For example, you can go for first 4 number as 1. Okay. So that's your wish. And the second point here is just to open this output file and keep it here. Okay. Yes. Now, what is the file number we have given over there? B3:0. Fine. B3:0 I have given. So what is the length I have given? 4. So how it will take the input file means, it will take B3:0 we have taken, no? So it will take B3:1, B3:2, B3:3, B3:4. Since I have given the 4 length, it is taking length 1 as this one, length 2 as this one, length 3 as this one, length 4 is this one. Got it? So now update your file. For example, when the length is 1, see when you are triggering this, it will change to position 1. Okay. In that position 1, it will read this file. Okay. It will read this file. According to that, it will turn on your output file. For example, see here, I am turning on this one. Okay. This is my input file. Okay. Next, for second position, whenever this fellow is going for the second time, I'm turning on this output. Okay. Next, whenever it is going on for the third time, I'm giving this one. Okay. And give the fourth one is here. Let's see what is happening. Fine. Got it? So I have updated the input file B3:1, B3:2, B3:3, B3:4. For example, here you have given the position as, length as 6. You need to update these 2 files also. Fine. I'll go for the first trigger. Let's see. Turning on. Can you see what is happening here? This O:0.0 will be updating. Don't bother about these 3. Okay. Everything will be updated in the O:0.0 because I have given output there. See, destination file is O:0.0. So it is updated here now. For the first, see, position is 1 no. So it is reading B3:1. What is position number 2? B3:2. What is the file? This one, first bit. So it will be turning on now. Let's see. Now if you turn off, it will remain in the on condition only. It will not off and all. Okay. Now, yes. Can you see? It is changed. Got it? Yeah. Can we do the third trigger? Do the third trigger. What is happening? Third file. Because B3:3. Correct? Now, fourth trigger. Can you see? It is updated, no? Fine. Now turn off. Now what will happen? See, position is equal to length now. Fine. Next, that's it. 1 cycle is completed. Now if you press for the 5th time, it will go back to the first position. Can you see? It is updated here. Okay. So it's not only for the 1 bit. You can give multiple bit also. I'll show you.
Now you update this. You can update wherever you want. See, you are updating like this. Just update whatever, according to the requirement you can update. Fine. That's it. Now this is 1, so it is showing this. See, now just now I have updated. Fine. So let's go for the second trigger. Can you see the second trigger? 1, 1, 1. Can you see here? This bit, this complete rung. It is updated. See, 15th bit is also 1. Correct. So let's go for the third trigger. Yeah. Fine. It's updated. Now fourth trigger. That's it. Okay. I hope you have understand the working of this sequence. Fine. For example, if I am turning off all these mask bit except the last 4 bit. Let's see that. I'll show you. Instead of F, I'm just giving 0, 0, 0, only 1 F. Okay. Now go for binary. Now this is only happening, right? Now if you go for the first trigger, it will be working. Can you see it is updated? Okay. But can you see this is also turning on? Fine. This is also turning on. But in my output file, it was not there. Okay. This is why still in on condition means in the previous position. What was the previous position? Length 4. Correct. In the length 4, these 2 fellows were on. That's what these 2 are on. For the next cycle, since mask bit is off, it couldn't able to filter it out. See, mask bit is off here. No, that's what it couldn't able to update the 0. So it is continue with its previous position. Okay. So better you keep all your mask bit as 1. Okay. Else it will not update. Fine. So see, even though if I go for the second trigger, it will be still there. Okay. All the 4 bits are updated continuously. See, for the second bit, you are having 15th bit as 1, but it is not updated here. Correct. Because mask bit is 0. Got it? Fine. So this is how you need to use the sequencer output. So all the corresponding outputs, see O:0/0, these and all you can use it in your program if you want. But the basic concept is you need to give the binary inputs and mask bit. According to that, it will be updating here. Got it? So just practice this in the software. I'll meet you in the next session with another interesting topic. Fine? Yeah. Bye. Hello everyone. In this session, we are going to see one example problem. Let's see what is that. So there are 2 switches for start and stop the lamp. By following the below condition, write the ladder logic program. So we are having 2 inputs and 1 output. Fine. And when the start switch is, this is a switch, not a push button. Fine. So when the start switch is 0, lamp is 0. That's fine. First condition is 0, 0. When the start switch is 1, lamp should on. When the start switch is 0, lamp should remain on in this state. Again it is on, lamp is 0. Like that, input is having multiple states and output is also changing for each state. Correct? Can you see? So whenever you are having multiple states of input and output for the same program, you should have the concept called memories. Fine. So without memories, we cannot able to solve this problem. So I hope you have remembered our memory sessions. What we have seen. So by using memories, we will be storing the state of start switch in coil, memory coil, right? So we will be storing this, we will be storing this. Like that, we need to store all the states of inputs. And in the last rung, we will be joining all those memories in one rung to establish this outputs, corresponding outputs. Fine. So let's see how many memories we need to use. For the first condition, there is no need because 0, 0 is the normal one before starting the program. Fine. Yeah. So start counting from this place. This is 1 and this is 2, 3, 4, 5, 6, 7, 8. So 8 memories we need to use. So each and every memory is storing the corresponding. For example, this is M0 means this M0 is storing the state of start switch. And M1 is storing 0 state of start switch. The one important thing here is sequence. Fine. So this one state here, the start switch is enabling. No, this is not equal to this one. Why? Because this is the first step, this is the third step. And same, this is not same one because this is third one, this is fifth one. And this 0 and this 0 is not same one. Same, this 0 and this 0 is not same one because start switch is pressed in a sequential manner. Like first it is turning on, then it is off. Then it is turning on, then it is off. Like that they are doing toggling. Okay, so for each and every toggling, we need to show the corresponding lamp status. Got it? So for that only we need to store all the states in corresponding memories. Right? So first we'll start with this one. We'll store the status of start switch here in M0 first. Right? So let's do that. So totally here 4 toggling happen. See 10, 10, 10, 10. Let's see how to do this in a software. So just go to our software page. Now take this one as a start. Right? So just type START and this is the switch which is going to change hereafter. Fine. And include your stop switch also. Just a minute. Got struck. Yeah. Just delete this. Click on this and just type I:0/1 which is our stop. Fine. And here whenever the switch is going to turn on for the first time, I'm going to store that in memory. So I'm going to use the memory coil and I'm going to name that as M0. Okay. So we need to latch here, and why we need to latch, that and all we have discussed in the memory session. If you couldn't able to recall that, just go to that session and just see why we are doing the latching here. Okay, to follow the sequence. Fine. So let's go to the second rung. In this rung, our switch is going to be in the off condition, right? So you need to use normally closed contact R of our switch. And this state I'm going to store it in M1. So use some different memory B3:0/1 which is our M1. And this fellow also need to be latched. Fine. So latching is very, very important. If you are not doing the latching, you cannot get the output. Got it? And so how to connect the first rung with the second rung? Yes, we need to have the previous output. So like this, you need to give this is step 1, this is step 2. Like that you need to give. Fine. So let's go to third rung and just copy this. Yeah, just we'll type from next rung, we will start copying. Fine. So here and the previous address, previous output and your start, because here in the third step your start switch in a on condition. Fine. And this is gonna be your third memory. So name that as M2. Fine. So here also we need to have a latching. So latching of your new output. I need to have one normally open coil. After that you can drag and place the address here. Fine. So 1, 2, 3 is done. Just see the PPT. See here. This is 1. This is 2. This is 3. All 3 are done. Now again we need to do for 0. So for that I am going to copy this rung and just paste it here. So now you need to use the previous memory and your start switch, and this is gonna be your new memory. What is your new memory now? Which is M3. Yeah, M3 it is. Just keep it over here, and the next rung should be this one. So you can pick and place from the reduce the time, you can do like this. So this is gonna be, because we are going to repeat the same steps whatever we have seen before, right? Nothing new we are doing. That's what I'm just copying from that place. So this is gonna be your M4, and M4 should be your output now. Fine. So all the 5 steps are done. Now the 6th one should be this one again. Keep it here. This is your previous memory, and this is gonna be your new output, which is M5. Fine, M5, and keep it here. Fine. And what next? This one. Just copy and paste. But whenever we are pasting, you need to change the address. Fine. It's gonna be this one, and this is gonna be your new memory. 6. This is M6. Keep it here, M6. Fine. So what next? We are going to have only 2 more rungs. One for the last memory, another one is for the output. Got it? Yeah, I think M1, M2. This one is M2. Yeah, fine. So we are going to have one more rung, which is the normally closed contact of our switch, because our switch is in 0 condition. I mean closed condition. That is whenever it is going 0. Fine. So that's what I'm using the closed input here. So this is gonna be your new output, I mean new memory, which is M7. Fine. The same thing is going to be here. So totally how many memories we have planned? Totally 8 memories, right? So 8 memories are here from M0 to M7, right? So the last rung is the main one. Fine. Because in the last rung only we are going to have our output. What is our output? O:0/0, which is my lamp. Fine. Just type lamp. And now we need to have when your lamp is turning on for the first time, when it is going to off, like that. Fine. So let's see when it is going to on for the first time. See, for the M0 memory itself, it is turning on. And when it is turning off for M0, M1, M2. For M2, it is turning off. Right? So just type M1, M0. For the first memory, it is turning on. We just change the address. This is the first memory. Whenever you are turning on, lamp is on. For the next memory also, it is in an on condition. So there is no need to connect this M1 here. When it is turning off, M2. So normally closed contact of your M2. What is the address of M2? It should be B3:0/2. Fine. So when it is turning on again means for the next memory it is turning on. So I am connecting the normally open contact in a parallel to the place where it got broke. So now here I am typing B3:0/3. This is M3. Can you see here in the PPT? 1, 0, 1, 2, 3. See here it is turning on. Fine. For 4 it is turning off. 5 remaining turning off. 6 it is turning on. So put a 4 here. 4 here. For 4 it is turning off. So I am putting a normally closed contact in a series. Again for 6 it is turning on. So I am opening a branch. parallel to the break where it got broken, correct? And here I am connecting my 6th memory. Fine, 6 I have connected. Now check the status when it is turning off for the last time for M7. So for M7 I need to connect it in a series. Fine. So just check for errors. There is no errors. Let's check how it is working. Fine. So first save your program. Fine. Go for download. Go for monitor. Run. Fine. Shall we do this now? So let's recall this first. Whenever you are turning on, your output should on. Fine. I'll use this. I'm turning on, output is on. Fine. If you are turning off, output remains on. That is the second point, correct? So now whenever you are turning on for the second time, output should off. Let's see that. You are turning on, output off. You are again turning off, output remains in on condition. This one. Okay. Fine. Now, if you are turning on again, output is off. If you turn off, it remains in off condition. When you turn on again, it will on. When you do the last one, it will off. This is M7. Can you see one by one your memories are in a on condition, right? So in between, whenever you press stop, everything should go off, no? Yeah, all the memories are going off. Fine. We'll do from the beginning once. For that, we need to follow this sequence properly, okay? We'll do one thing. We'll take one pointer. This is 0, 0th memory. This is 1. This is 2. This is 3. This is gonna be the 4. This is 5. This is 6. And this is 7. Fine? Got it? So let's see this. I'm turning on for the first time. Your output is on. Fine? 0 and this is gonna be the 1. For this, output remains on. For 2, what should happen? Output is off. Just see here. For 2, output is off. Got it? Now I'm going to do the 3. For 3, output is on. For 4, output is again off. Let's see that. For 3, output should on. This is 3. Output is on. For 4, output is again off. Correct? So let's see what is for 5. For 5, output remains off. For 6, it should on. For 7, it should again off. Right? So let's see. I'm going to do for 5. Output remains off. For 6, output on. For 7, output off. Got it? So it looks complex. It looks like a big program, but it is very easy because we have done the repetitive process. Like repetitive runs we have used. Whatever, concepts we have put it in a first and second run was repeated again and again for the 4th and 6th run, 4th, 5th, 6th, 7th. Everything is repeated. Got it? So this is one important example that we can understand memory concepts more. Got it? So whenever we are pressing the stop, everything will go off. Fine. So this is the importance of stop switch. Got it? So just practice this in the software. If you have any doubts, put a comment over there. Fine. I'll meet you in the next session with another example. Thank you. Hello everyone. In this session, we are going to see the example number 2. So let's read this. When start switch is pressed, they are having 5 statements. So all are in one single problem. So if the water level is below 5, motor should turn on till water level reach 95. So we are having one start switch as an input and water level as another input, and motor as one output. For the second one, if the water level indicates the value below 5, low level water alarm should turn on. If the water level indicates the value above 95, high level water alarm should turn on. If the water level is exactly at 95, steamer should turn on. System under control indication should always on when water level is below 10. So this is the simplest example that we can understand the comparator blocks. Fine. So let's see this in a software. So I'm having one start switch, right? So for the first output, how to turn on a motor, for that I'm going to take a limit test. So in this limit test, in a test I'm going to give N7:0. Fine. I'm connecting N7:0. So in a low limit test, I'm just giving 0. In the lower limit, I'm giving 0. And in the higher limit, I'm giving 95. So when N7:0 is below 5 means, it will be 0. It will start from 0, no? So from that to 95, our motor should be in a on condition. So this is the motor we are going to use. This is the motor which will be turning on when the water value is from 0 to 95. Got it? So for the second one, what they have told is, when the water level is below 5, low level alarm should turn on. So for that I'm going to use the same start switch here, because whenever the start is pressed, then only the process should happen. For that I'm going to include the start switch in all the rungs. So here I'm going to use the comparator value which is lesser than or equal. Fine. So A lesser than or equal to B. So what I'm going to give in A is N7:0. When this value is less than or equal to 5, what I want? I want to turn on an output which is low level alarm. Correct? So O:0/1, which is low level alarm. Got it? Fine. So what is the next problem? What is the next statement we are having there? When the start switch is pressed. The third one is when it is above 95, we should have the high level alarm. So what I'm going to do is greater than or equal I'm going to use. Here we have used less than, no? Here it should be greater than. I'm using same input. And this is also same, and here it should be 95. When it is above, I think here we should not use greater than or equal to, right? Because in a statement they have given greater than 95, right? So we should not use greater than or equal to, take greater than. Give 95 here. Got it? And just delete this. And here we are going to have one more output, which is high level alarm. Fine. O:0/2, which is high level alarm. Fine. Which is high level alarm. And let's take one more rung. In that rung, what we need to tell? We need to turn on a steamer. When steamer should turn on? Whenever it is equaling 95. So I'm just taking the equal block. Connect your same input here. Fine. Here I am giving N7:0 with 95. Because these values and all is a constant, right? So there is no need to give the parameter for that. You can give the constant value. And here this gonna be our new output which is steamer on. Fine. So what is our last one? When the value is below 100, always we want a system under control indication. So what I'm going to do means I'm going to take lesser than or equal to. Fine. Lesser than or equal to I'm going to use. Just give the same input. This is our N7:0 and this one is 100. So whenever the value is less than or equal to 100, we need to have an indication which is telling system under control. O:0/4. System under control. Fine. Got it? Check for errors. Right? Save the program. Go for download. Fine? Yeah. So now the value is 0, right? We have not changed anything. Let's see. Let's start the switch first. Yeah. So here we are having two outputs. One is low level alarm because the water level is below 5. One more is motor, correct? So now just increase to 5. Still it is on. Just increase to 6. Low level alarm is 0 now. I mean it is going off. Motor is still running because it is below 95. So let's turn on above 95. Exactly 95 means what will turn on? Steamer is on. Steamer is on. If it is 96, steamer will go off. High level alarm is on. Motor is also in off condition. Check it. Motor is also in off condition. Got it? Motor is off. High level alarm is on. And system control under control will always on when the value is below 100. So when it is above 100, you can see high level alarm is on. System under control is not on because it is above 100. Got it? So like this you can build some example for understanding the comparator blocks. Got it? Just practice this in a software, and if you have any doubts, please put a comment over there. Fine. I'll meet you in the next session with another interesting example. Until then, bye. Hello everyone. In this session we are going to see the third example. Let's see. Write a ladder logic program to make on delay timer block works as off delay timer. So what they have given here is we need to use a one input and one output. That means whenever you are turning on, one output need to turn on. Fine. That is a normal concept. But what they have given here is we need to use a on delay timer block, but that should work as a off delay timer. What is the working of off delay timer? It will delay the off condition, correct? So whenever you are turning on an input, output immediately on. Whenever you are turning off the input, output takes some time. Maybe that according to the preset value we are giving, according to that it will be turning off. So this is the one we need to write. Got it? But to make this concept, we should not use the off delay timer. We should use the on delay timer block, but it should work as off delay. Correct? So don't confuse that how we can do it, because on delay timer if we are taking means that will work as a off delay or on delay only. That will perform like on delay, but with the logic, with some logic we can make use of the on delay timer to work as off delay timer. So with the logic everything is possible. Fine. So let's see how to do this in a software. Let's go to the software page. Fine. So now we are going to take a on delay timer only, but concept wise it should work as a off delay. So imagine if it is an off delay timer. Whenever you are turning on an input, what should happen to the output? It should immediately on, correct? So let's do that first. I'm taking one input and one output in the same rung, because whenever you are turning on this, immediately your output need to turn on. So let's give some name. I'm giving input. This is the input, and this is gonna be the output. O:0/0. Fine. This is what our output. First step is done. Fine. Whenever you are turning on, output is on. What is the next one? Whenever you are turning off, output should remains on. Can you get the point? Whenever you are turning on off the input, output should remains off. Okay, so for that what we need to do? We should latch it, correct? Because even though your input is going off, your output should go in a, remains in on condition, means it should be latched. Got it? So in this condition, what should happen? In this condition, if it is an off delay timer, it will start counting. Whenever you are turning off, it should start counting, correct? Fine. So for that, I'm going to have a timer over here. In the same rung, I'm connecting a timer. I'm using the on delay timer block. See here, TON. Just give the timer address. I'm just giving the preset value of 10. Let's take 10, okay? 5 means it will be a very little duration. So whenever you're turning off, this should started counting. Fine. So after counting, what should happen? It should turn off your output. So for that, I'm going to give the normally closed contact of our done bit here. So here you may have some doubt. This timer will start counting immediately whenever it turning on, no? Correct. So whenever you are turning on for the first time, this fellow should immediately on. So if you are not connecting anything to this timer, apart from input, if you are not connecting anything, it will be work as a normally open, normally on delay timer, right? So it will be on. After 10 seconds, it will be automatically off. But my condition is not that. Whenever I am turning off the input, that time only this fellow should go counting, should start counting. So for that, I'm going to get help from one more input. I'm going to take one memory. Okay, what is that memory means? Whenever I'm turning on this memory is turning on B3:0/0. And what I'm going to do, and that memory I'm connecting here is normally closed contact with my timer. So why I'm connecting like this means this will restrict my timer to count in the initial condition. Okay, so let's see that. Because if I'm not putting this, no, it will be work as an on delay timer. So I'm restricting that from counting. Shall we see that? See, I'm turning on. Immediately my output is on. Can you see? Timer is not started counting. Okay. See, my output is on. Whenever I'm turning off, output is not off, but timer started counting. After 10 seconds, output should go off. What is this? This is exactly my off delay timer. Can you see output is off? I hope now you understand what is the use of this memory contact. Okay, because of this memory contact only, we are restricting the timer to count in the initial condition. See, whenever I am turning on this fellow is open because this is get energized. Because of this get open, the timer is restricted from counting. Okay, if I turn off, this will again comes to close, which will make a timer to count. Fine, because timer is getting complete input from here. Since it is latch, it is getting flow from here. So the rung condition making the timer to count. Rung condition making true. Rung condition is true because of the output latch, and this memory. So timer started counting. Simple now. So by using a logic, we made a on delay timer to work as a off delay timer. Fine. So just practice this in a software. You can use directly in, see, there is no place, no such application that we can utilize this concept. But with the logic, no, with logic we are making. So this is for your practicing purpose, to play with the logic. Fine. Right. So just practice this in a software. I'll meet you in the next session with another interesting example. Thank you. Hello everyone. So in this session we are going to see our last example, that means fourth one. So let's see. Design a ladder logic for two-way traffic control. Fine. So in your exercise you'll have a three-way traffic control. So in an example we'll see how to do the two-way traffic control system. Fine. So this is one of the classic example in ladder logic. So for this, the concept is yours. You can design the concept as per your requirement, as per the customer requirement. Okay. So here I have taken two direction. So let's see. I have taken east and west direction since it is a two-way traffic, and I have built some concept here. You can change the concept if you want. Fine. So see, we all know we will have a three outputs, right? So I mean each direction three outputs. So I'm taking east and west. And whenever east side direction is having a green color, I mean those people can move forward. West people should have a red color. And whenever the green or red going to change from its place, I mean going to change to another color, I am putting yellow in between. Fine. So for the first few seconds, east should be green and west should be red. And after some time, both should be yellow, and after some time east is changing to red and west is changing to green. And after some time again this is yellow, this is yellow. After some time the cycle is going to repeat. Again east is going to green, again west is going to red. Got it? So this is how two-way traffic control will be. You can design like you can start with east red and west yellow, and you can skip this yellow. Okay. You can skip this yellow if you want, but in my concept, I just included yellow in both the places. Fine. And in after some time, no, I have told about after some time. For that, you can make use of the on delay timer. Fine. So let's see how to do this in a software. So for this, I'm going to have one input. Fine. I'm going to have one start input, which is I:0/0, which is start bar stop. For both it will be doing. Fine. So whenever it is turning on, what I want, I will be having two outputs, right? What are the two outputs? One is my red, east green and west red. So just type O:0/0, which is our east green. I'll type EG, and this is gonna be the O:0/1. What is this? West red, WR. I'm typing that as WR. Okay. So this is the one which is starting our cycle. Fine. So after some time, these two fellows should go off and both of their yellow should turn on. What is that after some time? For that, I'm going to use a on delay timer. So just have an on delay timer here. Right. So let's type this as T4:0, and I'll give the 5 seconds delay, or let it be 7 seconds delay. 7. After some time means after 7 seconds, both the output should go off. So I'm putting one normally closed contact as a common to EG, east green and west red. What is this? My timer's done bit. T4:0/DN. Fine. So what is our second cycle? When the start switch remains on, after this time delay, two outputs will turn on. What are the two outputs? East yellow and west yellow. So connect those two outputs first. For its corresponding input is this one. When the switch we need to include in all the runs, okay? And this DN. When this time delay is done after 7 seconds, these two fellow will go off. No, at the same time we should turn on both of their yellows. So this is gonna be east yellow, new output, and this is gonna be the west yellow. Got it? West yellow. At the same time, what we need to turn on? We need to turn on one more timer, because this should go off, no? So for that, I'm going to have one on delay timer here. So let's take one on delay timer. Name that as T4:1. Fine. Just give the time delay as 5. Okay. So after some time, these two yellow should go off. So I'm connecting one normally closed contact with these two. I'm just putting as a common. You can give here also as a separate contact. I'm just giving here like that. T4:0. I mean T4:1 it is /DN. Fine. So after 5 seconds, these two will go off. What should turn on? Yes. East red and west green. Fine. So take one more new rung, insert append rung. Okay. In this have 2 inputs and further another 2 outputs. Right. One is east red and west green. So take one more coil here and just change the name to 4. O:0/4, which is east red, and the next one is west green. Correct, west green. So we have used all our 6 outputs, and this is gonna be again the start contact and this timer's done bit. So at the same time, what we need to connect? Yes, we need to have one more timer here. Fine. So this timer, what this timer will be doing? This timer will be turning off our east red and west green. So T4:2, and I'm going to give the time delay as 7. Just type 7 here. So we need to have one closed contact, which is our done bit of our timer. Fine. It's done? Yeah. So after this, what should happen? We should turn on our yellows like that only, no? See the PPT? Yellow. Fine. So just go to your programming page, and here the yellow line got broke, no? So here take a parallel contact and put your timer's done bit as normally open contact. Got it? So this is the one you need to understand, because all the 6 outputs are already used. So for this yellow, you need to go back to your output and you need to connect a parallel contact. Fine. So what should happen next? After some time, and for that some time, I'm going to have one more timer here directly. Fine. This is gonna be your start switch, and this is your timer. When this timer is done, you need to turn on one more timer, which is our last timer. And for that, I'm giving a time delay as 5. Because this is yellow, no, I'm just reducing the time. So when this is happen, I need to turn off those yellows. And what should happen next? I need to turn off the yellows. You can put here or you can put here also. Your third timer, T4:3. Fine. /done bit. Fine. Yeah. So these two will go off. What should turn on again? It should restart the cycle. For that, I'm going to put it here. The last timer, I'm going to restart the cycle from beginning. whenever you want to restart the cycle from the beginning, put the normally closed contact of last timer in the first rung. Shall we see? Let's save it first. Go for download. Go for run. Yeah. Okay. First I'm turning on. Two outputs are on. After 7 seconds, both the yellows are on. Can you see these two are off? Okay. Now these two are on. After some time, east red and west green are on. After some time, after 5 seconds, after 7 seconds, both the yellows are again on. After 5 seconds, this is started running. So your cycle is started again. That's it. This will be continue, okay, until you stop it. Just see. Again yellow happen. Then again red green happening. Red green happening. And again yellow will be happening. After yellow, again green red will happen. This will be continuously happening. And if you press stop, everything will go off. Can you see? All the timers are going to reset and all the outputs are off. If you want to change the preset, just go to offline and just reset. Give some give some different value to the preset, and you can download and start the programming. Fine. So just practice this in a software. Fine. So this is the last example. You can find the same similar exercise problem also. Fine. Yes. Thank you. Bye.